Sharp as well with this guy. So, yeah.
Yeah, so no new .NET without a new C#. This time it's C# 11. Yeah. So really getting deep into the 2 digits here.
Yeah, yeah. It feels like, but this time it's just one. It's one larger, right? It's one more than C# 10.
Yes.
So, all
yes.
right.
Just that extra little bit. So we didn't bring slides. We just brought code.
Yep. We're going to dig right in.
Yeah.
Okay. So first up, it's tradition that Mads and I in our demos, we start with a very, kind of simple person demo where we have a person class. Now, what's cool about this is that we're using some new features that we've introduced over previous releases. We're using a nullable string there with a question mark. We're using init only properties, but there's kind of a downside to this as well.
Yeah. I mean, we really want to make it nice to use object initializers and not have to, do constructors for everything. They can be a little cumbersome.
Yeah.
But something is a little off, which is that with object initializers, up until now, it's always up to whoever's creating the object to decide which things to initialize and which not to initialize.
Right.
And that kind of bleeds through here a little bit, right? Because you see there's some squiggles in there.
Yeah, there's some squiggles here. This is where the blessing of nullable is helping you. And essentially it's telling us that, hey, we haven't declared these as nullable, but there is an implicit constructor that will get called before the object initializer up here is run, before those properties get assigned. So technically, these properties will hold a value of null, and we have said we don't allow that. And this is kind of a stumbling block in some of these cases where I want to use object initializers. So often we try to find ways to work around this, and so users often are doing things that feel unnatural, right?
Yeah, but
you might have to assign it to null just to tell the compiler.
It is. Yeah, but this, now you just move the warning, right? Yes,
so you say null bang.
But now we have a place to put a bang and say, and I know what I'm doing.
Yeah, try and pass code review with that. Not for me. But this is the sort of thing we have to do, and it really is uncomfortable.
Yeah. You might even try to get around it by assigning a non-nullable string to it, right?
Yeah,
do
this sort of thing
the empty
as well.
string or something. But you're really just hiding a problem that's still there, which is that the object is not properly initialized. You can get the compiler to shut up about it, but it would really be nicer if you could ensure that it was properly initialized.
Right, and there's another issue here too, which is that the object initializer itself doesn't initialize all the properties I want it to. Like with a constructor, I can be very prescriptive about what things need to be passed, what I'm expecting from the user to initialize the object. And here, even if I assign these to null or I assign these to empty string, I don't really want those, but if somebody's using an object initializer, I can't guarantee that they've actually filled in the last name.
So wouldn't it be nice if we could tell the person creating the object, you have to initialize this. It's required.
Yeah.
And that is
and so we can do that now.
Yeah.
And so the nullability warning goes away because we're telling the compiler, we're expressing in the language that this is a required property. Therefore, it means that when it's initialized, it is going to be initialized. We don't have to worry about some of these details around this time where it might be null. We've guaranteed that. And so if I do the same thing with last name, then looky there. Because I haven't specified last name up here. So it says required member must be set in the object initializer or attribute constructor. Now that's curious. Attribute constructor.
Yeah, so let's celebrate the red square.
Yeah. Celebrate
this is
that.
Yes, you now expressing a contract.
Yes.
Whose job is it to initialize this property? And unless you put required, it's the class's own responsibility.
Right.
But if you put required, you're pushing that responsibility, that requirement onto the person initializing the object.
Yeah, and so we can correctly initialize it as that contract defined, right? Now, that attribute piece I mentioned earlier was kind of goofy, where it said attribute constructor, and it turns out since C# 1.0, we've allowed properties to be assigned as optional kinds of parts of the initialization of an attribute. And so while doing this, it kind of felt like we should also attack that problem as well. Since the object initializers are all about initializing an object through properties, attributes also have a way to do that. It's kind of merged together. So if I were to make this an attribute, you'd see the same error. So we'll just call it an attribute. Yeah, sure, that's a thing. And if I have the same code here, you'll get the same error. And so now, with an attribute, you can also do this. It's kind of a nice way of just taking it all the way through the language, but also back to C# 1.0 and improving the experience that already existed there.
Yes. Where now you can actually have the old style of optional attribute parameters also be required.
Yeah, it's fantastic. Yeah. All right, let's move on. This has been a cool feature. I'm really excited about this because it feels like over the course of the language, we are continuing to make these kind of small improvements across initialization and really getting to a place where it starts to really coalesce and feel really good.
I mean, it's been a theme for a couple of releases now to make object initialization flow more naturally, have more expressiveness and more conciseness, and this is another step in that direction.
Well, let's take a look at something else.
Yeah.
We've got C# 11 is full of features, and since we're looking at things that improved C# 1.0 from long ago, there was another set of things that we've wanted to do over the years for many years.
Yes.
That also appear in this language.
So everyone who's had the pleasure of doing math in C# and then trying to abstract over the specific kind of number that you're talking about, you will, even if you just used system.math, you've gone and seen all these overloads. There's an overload for each possible numeric type of, absolute value and so on. And you might wonder, what does the code look like inside of all of those overloads? And it looks exactly the same. But we've had to write it like 12 times or however many overloads we collect.
So just to kind of illustrate this, the demo we have here, there's a function. Again, we're using top level code here, so there's a function inside that. So we have a method that will take an array of integers and just adds them up. Okay.
It's a numeric algorithm. It's a beautiful numeric algorithm.
It is genius. We slaved over this one day. We really were toiled over it. Yes. And then we're passing an array in here. And if I run this, you can see that it adds them up successfully, which is great. But now if I wanted to make this work over other numeric types, what if I wanted a different sort of like bytes or doubles or anything.
Yeah, what you really want is
basically I'd have to copy and paste this and do it again.
What we really would want is to make it generic, right? We want to say add all of t, and then this t, then somehow
So we're going to return a t. Now we're going to take a t array. I guess this is going to be a t.
I think that's
and that'd do it.
So that would be cool if you could do that. Of course. You can't plus random t's and they can't be 0. But, if this was just all about instance members, we would put a constraint on that generic. We would say where t something something. And wouldn't it be cool if we could put a constraint on that is like somehow says that I'm a number. I have operators and things that make me a number.
Yeah, so I did that, and I used iNumber, which is new in .NET 7, and when I hover over that, I see now that the plus equals error went away, and in fact there is some interface that has the operator plus that is generic and can be used
this
for this.
Is magic.
It is magical.
Yeah.
The only problem I have now is I still can't convert int to t, but I know that when I'm doing generic methods, I can dot in and look for the static things.
Well, you didn't used to be able to.
No, you didn't.
On a type parameter.
That's correct.
But now there's stuff in here.
Yeah. There's one that would work if I were a mathematician and really good at math. I would know that additive identity is what I need here.
Yeah.
For the rest of us, we could just say 0. And so now this is completely generic, and if I build and run, it still works.
The sum of those numbers is still 15. But now,
and wait, there's more.
What if you use another kind of number?
Yeah, so right now this is an int of int array, but if I throw a double in there, that will cause the inference of the array type
now it's
to
a double array. Yeah.
And now it's calling add all with an array of doubles, and it still works. And if I
And now it's using doubles plus and 0.
yeah, right. So this is generic math on C# 11, and it is driven by really a much larger feature.
Yeah. So this is sort of the domain that we chose to double down on.
I see what you did there.
Yeah, we're not just inting down anymore. We're doubling down.
Yes.
On the like the thing that where we took the BCL, put interfaces and everything in, but it's really like a special case of a broader language feature that we added. That is, allowing static members and interfaces to be virtual or abstract.
Right. So let me just I will go to definition on this iNumber type, and we'll see what this has. And this has static members, and these are actually interestingly, if you get to how this is implemented, they're just static members. They are default interface members as well. They have default implementations, but this iNumber brings in a whole ton of interfaces.
Look at all those interfaces.
Yeah, there's all sorts of things, including that iAddition operators that we looked at before. If I were to F12 on that, you can see that, well, this has a static abstract operator.
Yes.
Right?
Because
of plus.
Operators are really just static members, right?
Yeah.
They're one kind of static members, and all the different kinds of static members can now be abstracted over an interface. You can say whoever implements this, they must have this operator. They must have this static member, like we saw the static property 0 before, and then you use generics to get at those, like we saw in our example there.
I mean, it's a great feature for the generic math domain, which is really kind of what drove us to really do it. But
and before you move away from here.
Oh, sorry. I did move away, though.
Oh, you did move away.
But
that's fine. I just also wanted to call out another little language feature that we added, just as we're here, which is that you can now overload your operators, all the ones that in their primitive form have a checked form. You can also overload like the plus operator with a checked overload, and in that case, that's the one that gets picked if you're in a checked context.
Yeah, this is and this was, again, it was something that kind of came out of us trying to implement this generic math domain. Well, this is needed to really fill it all out. And you can see that we went a little nuts with filling it all out. As I look at the iNumber again, there's just a lot of interfaces here, and you can see the scroll bar. It really is composed of many interfaces that can be used to define your own numeric types or things that can be constrained on. But there's also something I want to call out that's really interesting, because it has nothing to do with numbers at all.
Right.
But it's just a really great use of this new feature that is static abstract members on interfaces, or being able to implement static members from interfaces in a sense, right? Because you can also have those defaults.
Well, let's have a look. Because being parsable, what does that actually mean?
Right. It means to take a string and give me back an object,
an instance of the type.
Yeah.
So a type that's parsable. That doesn't really mean that things of that type have a instance member on them, right? You can't if you walk up to like a person and say parse yourself. Well, too late. It's already a person object. What you really want to do when you're parsing something is you want to get a string and then create the person.
Yeah.
So that's usually the job for a static member, right?
Yeah, and I mean this goes really well in the BCL because we have these parse and try-parse methods on our numeric types, but also on things like GUID, right? Which I'm not adding together, but they're also still parsable and can be, and now you could constrain on this interface to be able to, kind of have a little factory method that might, given a string, produce things out of it.
Yes. So this is really good. If we can have a look at that, there's a parse and a try-parse. The parse is the simpler one of them. It's a static method. It's abstract in the interface. So you're telling people who implement the interface they want to be parsable. Well, you got to have a static parse method.
Yeah.
You take in a string and a format provider, and you return the type of yourself. Like so, the intention is, class C when it implements the iParsable interface, it will pass itself as the type argument, so that the thing that will be produced out of its parse method is indeed one of itself.
You're going to see a lot of these T-selfs throughout here because they're often, it's about implementing an interface, but I'm actually the generic parameter on this. And so this is kind of a pattern we've used throughout.
It's so you get strongly typed results, right?
Yep.
You saw the same with the or with the addition operator. You don't want to just then get some interface result back, because then you lose your strong typing. You want to be where you have, you thread the strong type through the interface.
Well, this is fantastic. So there are other features we could show here. I think static abstract and interface is one of the things I'm very excited about it, because I feel like that whole kind of embedding of kind of factories almost into the language in that sense, right? These static abstract factories is something that I'm really excited to see what people go and do with it. I mean, we've done the generic math piece, but this is something that much more flexible to see what libraries, next libraries we see that do very interesting things around serialization and all sorts of stuff that I'm really excited about.
It's super open-ended, right? We thinking about design patterns, for instance, like we saw that factory it was an abstract factory, right? But it was also a static factory. It takes those two classic design patterns and puts them together and gives you something that is, combines the power of both. And I wonder where else people are going to find that kind of application. This is really one that we are going to see uses that we had never thought of, and that are going to just be exquisite and beautiful. This is kind of raw new expressive power.
Yeah. I'm blown away by it. So, all right, let's kind of take a step in a different direction.
Yeah.
We can talk a little bit about we talked earlier about required properties and how we kind of continue to refine and evolve larger feature areas in the language. Another one that we've been consistently doing that with over many releases, I think most releases, since Csharp 7, is pattern matching.
Pattern matching, which is this gift that keeps on giving, right?
Yep.
In Csharp 7, we added pattern matching for the first time. It did just a few key things, but already then it was like really, it was opening up a new way of working with different shapes of objects that was more declarative and had less confusing if then else's and casts and so on in it.
Yeah, for me, when we first did it, I thought it was a really great moment of design where we used the is keyword, which was already technically pattern matching.
Yeah.
Right. We were saying, well, if it's this type, well, now is it this type and I can give it a variable, or is it this type and it's length of 2 or something like that. That's something that I feel like that's caused that keyword, which has been there since Csharp 1.0, to continue to just evolve and get more powerful. We've introduced, and we did the same thing with the switch statement, but introduced the switch expressions. How might I do this? This is a pretty reasonable implementation of this.
Yeah.
But I think it would be interesting to try and do this with pattern matching.
Let's try to do it with pattern matching.
All right.
Essentially, we want to do a switch expression. Instead of all this imperative logic, let's try to go all out and do this declaratively with a switch.
This is the nerdiest way to do it. This is so let's do it this way.
Yes.
Now, to be able to match on an array is a trick, right? I mean, we could match and say, okay, this array has a length of 0 or something like that. But that's
we don't really up until now we haven't really had patterns for things that are list-like. You want to talk about the elements of the incoming thing. So that's what we can do now with list patterns. So you can say, for instance, and we use square brackets for that. Is this an empty thing? In that case, return 0. Except
Actually,
it has to be t.0 now.
T.0.
And but then if it has something, what is that? Let's say it has one thing.
Okay, and so we can use a recursive pattern here and say, oh, it's one thing, and we'll pull that first thing out of it using a variable.
A var pattern.
A var pattern.
But that could be any pattern in there. We could say if the first one is null, then do this. But we'll use the var pattern here. And then
so,
it's just that.
Yeah, and so then we can just kind of have a contest, I suppose, to see what gives out first, the compiler's ability to process the size of this file or to produce cases for it. And we can just keep on going, right?
Yeah, but that's
because this is telling me that, hey, I haven't covered length 3 yet, so I've got a ways to go.
Yeah, so this is not sustainable to keep adding more things, but we need a way essentially to say the rest.
Right.
What we haven't talked about yet.
Right, and so similar to range expressions, we use ... here for that, right? And so that means instead of just the second element, it means match the first element, put it in here, and then all the rest of the things, put them in this variable.
Yeah.
Second, we should probably call this something else like rest.
Yeah.
Yeah. And so now this is another array, okay, which contains the rest of the elements.
This actually uses the slicing that we introduced in C# 8.
And I can be very clever, and now I can make this recursive.
Yes.
Yeah, that feels good, right? Although one thing, I bet you were just about to point it out too, is that it kind of feels like now we don't really need the second one, right?
Yeah, I mean,
if I look,
let's try to swap them around and see what happens.
Yeah.
Now we get an error saying we'll never get here.
Right, because it's subsumed by the branch above. That's awesome, by the pattern above. That's great.
Yeah, so pattern matching telling you, it's doing a more in-depth analysis of what you can do and not. It's giving you feedback when your pattern matching is kind of off.
Yeah, I would say that though one thing about this that's a problem is that it's kind of slow. Right, we're allocating. This is now an allocation factory. We're allocating new arrays.
Yeah, this is using slicing on arrays, which is not the best.
But we have ways of doing that.
Yeah,
and we can use a span right here, and then we can come in and also say use a span right here, and now you'll see that on the sliceable, this thing is sliceable, and therefore we can get another span as the rest of it, and we are no longer
slicing spans is cheap.
Yes,
because it's just kind of looking at the same thing. So very cool.
That's very cool.
Yeah.
All right.
There's one like little sleeper feature we should get to before.
Oh yeah. Yeah, for sure.
Before they tell us to leave the stage.
I just started a build to show that it does run. All right. Yeah. Next up. Then let's talk about this last sleeper feature.
Yeah, so string literals in C#. Great for like Shakespeare. Not so great for JSON or XML.
No. In fact, if I run this, I mean, you could see how it prints, right?
Yeah.
But I had to come in here, when you copied and pasted this, you had to come in and escape these quotes. You can make it a verbatim string, but then you still have to escape the quotes by putting 2 double quotes.
Yes.
Yeah.
No,
it's really annoying.
Yeah. So new kind of string literals that we call raw string literals.
Yeah.
And they are the ones that have no escapes in them whatsoever.
Right.
Delimited by...
Delimited by 3.
Yes.
Exciting. And so you can see, maybe if you look close, you can see that the colorization on these went away, because those are no longer escaping double quotes. Those are now part of the content.
Part of content.
Yeah.
Everything in there is part of the content. But Dustin, that someone would say, what if you want 3 double quotes in your content? What if you paste something in that has 3 double quotes? Then it's going to get confused, right?
Yeah, then it gets confused, and this now ends it, and that's a problem. So in the spirit of C# 11, I would say just add one more.
Yes, take it to 4.
Yeah, take it to 4. And so now you can do exactly that.
Always contain any content by just putting more double quotes around it than it needs. Really cool.
We can also make these multi-line by introducing. But the problem with that, or not the problem, but there's one restriction that this guy has to be on its own line.
Yeah.
And we will clean up the front and the back of that. And so if I come in here and run this, you'll see that this is now multi-line. But this is always annoying too, doing multi-line, because
they go to the margin.
They can always go to the margin. And so if this were in a method body, I would be slamming this against the left side to try and strip the left. Or maybe I was clever and wrote code to do that, which seems also not in the right direction. So, but I can indent these just fine. And if I also, indent the trailing delimiter, you can see this little line, if you can make that out. That's what that's doing, is that's showing you where it's going to trim the left margin.
Yes. So this has a left margin trimmer built in, which you can control with the end quotes there to see what it is. And so we're out of time.
Here we are.
But we should just mention here, there is a story for interpolation of these guys as well. So you want to copy paste something and then start poking holes to compute values and insert their string representations. That's all there as well.
Awesome.
Okay. So with that, any more C# features, go and play with it. And if you haven't already, send a quick tweet so that we can get questions here right now from Richard Campbell over there in the corner. Richard, how are you doing?
Nothing like language geeks for breakfast. Hi, I'm Richard Campbell, and we got some great questions for Mads and for Dustin. I'm going to start with this one right here from Jay Sakamoto. It was one of the first questions that came in asking, is C# 11's required and init property effective for property injectors, like inject foo service foo of get and init on my Blazor code? Because if I could get rid of the workaround null bang, I'd be a happy person.
That's a very specific question.
Highly specific platform question.
Blazor people want their love, man.
I
Yeah.
assume they do. Yeah.
So I would say go try it.
Yeah.
But
I mean, the required
C# 11 code is going to C# 11 features show up in Blazor.
Yeah. So exactly. So I can't see right here without looking at it whether.
No, it sounds like something you should try. Right.
Yeah.
Right.
Yeah,
Take it out for a spin.
I would say if you've been writing null bang and that works today with an init only property, I would say it almost certainly works to take the null bang off and do a required property.
Yeah, some code brings you love, Dustin, and some doesn't. And you guys have shown some great things. So I'd be excited to take those all out for a spin. I hope Jay Sakamoto does as well. Let's grab another fun one here. This is from Maran, whose name is Upside Down, and he says, does the C# 11 required keyword participate in inheritance too? Is it possible to override it?
That is a great question, because this was like the source of like 90% of our design discussions.
There's a lot of discussion around
Yes, it totally, requiredness is inherited. So your derived class will definitely also require your required things. There is we discussed, to what extent should this be overridable and how granular should that override be. And in the end, we said, okay, we don't know that there are scenarios for very granular override. So we put in an attribute called set required members attribute. And if you put that on a given constructor, then that is exempting that constructor from the requiredness of the member. So essentially you can say, this is a special constructor, like a copy constructor. This initializes all the things, even the required things. So when this constructor is called, don't give them errors for not initializing. That was the override that we picked. We can always refine that later. I mean, that's a C# again already next year, but we want to see solid user scenarios to make that worth our while, essentially.
Yeah, that's exactly right.
So great question.
Yeah, and I really appreciate all the thoughts you guys have on these particular problems. Watching your presentation hit me right away. How many of these features that you get to show today, you've actually been working on for years. I know you put out C# 11 just this time last year, but I got to think some of the things I saw today, especially around generics, they've been worked on for a long time.
Yeah, the abstract virtual statics, or the abstract statics and interfaces, that feature was actually prototyped the first time over a decade ago.
Sure.
Yeah. That was back when it was all, the classic .NET runtime, and we didn't have the same ability to evolve the runtime. This really needs tinkering with the runtime itself, not just with the libraries or compiler. And we couldn't do it back then, so we had to not do it. But it's been on the radar for that long.
Yeah, and it occurs to me doing the history of .NET work, like generics have been part of .NET since the very beginning. They were part of the original specifications written in the late 90s. So it is cool to see these things still surfacing that were part of the thinking right at the very beginning.
Yeah. Essentially we're trying to stick with the spirit of C#, the really core ideas that were there from the beginning. We keep trying to refine those, and we keep trying to do our design in the spirit of those, even as we take C# in a direction certainly of more terseness and brevity, kind of make it feel more lightweight and more approachable for new adopters as well. We try to keep those core concepts, rally around those rather than, slam things in.
Well, Mads and Dustin, you guys hit me hard first thing in the morning. I'm glad I had a cup of tea early because it got me thinking about a lot of stuff. Thanks so much for putting this great presentation together. Hey, there's our first talk for day 2. It's amazing to me that the code base continues to evolve and keeps getting faster. So the code you wrote yesterday on 6, running even faster on 7. There's nothing that can compare to that. Like, there's very few platforms that actually get faster as they age. But we keep seeing this version over version over version. New numbers, new speed. It's really a remarkable thing to see, and I can't wait to see what Steven's going to be telling to us about. He's on Teams, so we're going to see him from remote. I'm Richard Campbell, and I hope got him here with us. doing that technology thing. You know, it's always fun to have all these different pieces working together, but we're good to go. So talk to you at the end of this session.
Thanks a lot, Richard.
No worries.
All right. Thanks a lot, Richard. It's great to be here. It's always hard to follow the Mads Dustin show. They're wonderful to watch, but I will try to do my best. There's nothing I like more, at least in the technology world, than talking about making things fast. And there is a lot to talk about in terms of making things fast in .NET 7. As some of you may know, I've taken it upon myself every year for the last 5 years or so to, towards the end of each .NET release, getting ready to ship, sort of documenting the myriad of performance improvements that have gone into this release. And I did that again this year in August. And if you were to print it out, it comes out to more than 200 pages, just sort of highlighting how much stuff from a performance perspective has gone into this release. If you haven't read it, I'd encourage you to. But the reason I bring it up is to say there are huge numbers of improvements. There were over 500 pull requests and improvements discussed in this PR. That's only a subset of the ones that there are. Obviously, I'm not going to talk about 500 different performance improvements in the course of 25 minutes. So instead, I've pulled out just a representative few and sort of tried to up-level them a bit to look at them through sort of a lessons learned, or how we think about the kinds of performance improvements we want to make in a given .NET release. And I should say, when I say we here, I don't just mean those of us on the .NET team or those at Microsoft. Many of these performance improvements, over a fifth of these performance improvements, have come from folks outside of .NET, outside of Microsoft. We have a wonderful .NET community, and if you're not already participating in the .NET repos, I would highly encourage you to do so. So with that, let's dive in. So the first sort of category here is about trade-offs. For those of you who aren't familiar with the English idiom of having your cake and eating it too, it's all about having two things that are sort of diametrically opposed, and you find a way to have both of them rather than having to choose between them. And a really great example of that when it comes to .NET and managed languages typically in general is around JIT compilation. So with a JIT, where you're compiling all your code as part of the process's execution, you have this trade-off to make between how much time do you spend fully optimizing your code and how much time do you spend at startup. So you want to get really great code quality, but that requires more time to compile it, to analyze it, which then negatively impacts your code actually getting going. So one of the technologies that was introduced in .NET Core 3.0 is tiered compilation. This is an instance of having our cake and eating it too. With tiered compilation, we actually allow the JIT to compile a given method multiple times. It can compile it once and do so with basically few optimizations enabled, as few as it can muster, such that it can compile it really, really fast and doesn't have to spend any time on analysis and optimization. And then if it finds that that method is on a hot path and it's getting invoked over and over and over, it can recompile it, this time with all the optimizations it can possibly throw at it, backpatch the application such that all further invocations take that highly optimized route. And this gives you a really great startup without sacrificing code quality. In fact, you can even get better code quality with this, because when the JIT does that initial what we call tier 0 compilation, it's able to instrument the code for a variety of things. Not only can it instrument it for the number of times the method is being invoked in order to determine when it needs to tier up, but it can also instrument it for other things. For example, with a given interface, what is the concrete type that is typically being used for that given call site, and it can optimize based on that, and other things that it can learn about the method from that initial invocation. Now, the problem where we haven't been able to have our cake and eat it too is that this doesn't apply to all methods. There's a category of methods that could actually be really important for throughput, that could be really long running, where optimizations could be really valuable, but that aren't frequently invoked. And if you imagine a method that has a loop, you could be sitting in a really tight loop doing a whole bunch of processing, but only invoke that method a few times or even once. Your main method, for example, is typically only ever invoked once in your process. And so by default, tiered compilation was disabled for methods with loops until now. So in .NET 7, there's a new technology as part of the JIT called on-stack replacement. And this, again, lets us have our cake and eat it too. In addition to tracking how many times a method is invoked, it also instruments loop iteration counts. And when a loop has iterated enough times, the JIT is able to generate a brand new optimized version of the method, jump from the unoptimized code into the optimized code, transferring over all the relevant local state, and continue executing there. And as a result, we're able to have tiered compilation for all of these methods, including ones with loops, which we couldn't in .NET 6. So let's take a look at this. I've got a very simple example here. Trivial code, not something that you would actually write because it's computing something you already know. 10,000 times we're looping through all of the characters, 0 to 65,000. We're checking and counting how many of them are ASCII digits, basically the numbers 0 through 10. Obviously, the answer is 10. We don't really need this to compute it, but it's some computation to make an example out of this. So let me run this. I've got I'm going to build this for .NET 6, and I'm going to build this for .NET 7. And then I'm going to run this on .NET 6. And when I do so, we can see it's computing an answer of 10, and it's taking just over half a second to do this computation. Now, this is with tiered compilation, but loops are off by default. And if we saw my method here, it's just a main method with a big loop calling this little helper function. But this function is only ever going to get invoked once. Now, if I were to override that default, and I were to set .NET TC quick JIT for loops, now I rerun this, and we can see because that main method was opted into tiered compilation, now it's taking over a second because it's unoptimized, but it's not being invoked enough times to tier up to tier 1 with fully optimized code. If I instead run this now with .NET 7, note I'm not unsetting this environment variable, which is actually set by default. Now when I run this in .NET 7, not only is it not taking a second, but it's taking even less time than it did on .NET 6. So now it's taking less than half a second to compute the same results. And more so, I can even fully understand what's happening by taking advantage of another set of new features in the JIT, which is that the JIT can now tell us information about what it's doing and when. So I can say .NET JIT disassembly summary equals 1. And now when I run this, we see that the JIT has output a line for every method that it compiled. Now, obviously, in order to run Hello World, it's actually there's actually more than 7 methods that are running as part of my application, but most of them are coming from the ready-to-run images that are shipped as part of the core framework. The JIT had to compile these 7 methods for a variety of reasons, and we can see one of them is my main method, and indeed, it started out at tier 0, and then because it was executing the loop so frequently, it very quickly tiered up to a tiered 1 with on-stack replacement. And in fact, I can go further than this. I can say not just JIT disassembly summary, but I actually want to look at the assembly code that's generated for my main method. Now when I run this, I will see that there are 2 blocks of code very quickly spit out. And if I scroll up through this, all this assembly code here, I can see that first, I have an assembly code output for tier 0 compilation with minimal optimization. And we can actually see that these optimizations aren't kicking in. If I scroll down a bit, we can see that there's a call to that 1-line trivial helper function, which you would normally expect to be inlined. But inlining is one of the optimizations that's disabled as part of tier 0. So in my unoptimized code, I see that I indeed have a call to that function. If I then scroll down to my next block of code, we can see it rejitted that method. Now it's using optimized code. And if I scroll down to approximately where we saw that call, now I see these few instructions. And if you know your ASCII table, the character 0 is decimal value 48. So this is that inlined is ASCII digit, subtracting character 0 and comparing against the number 9. So on-stack replacement and as part of tiered compilation is a really welcome addition to .NET 7. Another example, another category of lesson learned is if you're writing libraries, if you're writing services, you'll often deploy, and then you'll find that your consumers end up having to sometimes rewrite the same functionality over and over as part of consuming your work. And an example of this comes with reflection invoke, for example. So reflection invoke, you use reflection to get something like a method info, and then you want to dynamically invoke it. So you call method info.invoke, you pass in your object array of arguments, you get back your object result. It's very dynamic. It's also relatively expensive. And in order to work around that expense, we found that a variety of consumers of .NET, including ourselves and our own libraries, were spending a little bit more time at startup to use reflection emit to actually generate custom little invocation stubs where once at runtime we learned what we needed to know about the method, we could generate a custom invoker just for that method, and then we would have a delegate to that custom invoker that would make it really fast. Well, we don't want everyone having to re-implement all that functionality themselves. So in .NET 7, we've implemented that as part of reflection invoke. So I have a simple little demo here. I have two methods, one that has 0 arguments, one that has 1 argument, and I'm just doing a benchmark that over and over is going to invoke them using reflection invoke. And if I compare the runtimes here for .NET 6 versus .NET 7, we see the 0 argument version where on .NET 6 it was taking about 45 nanoseconds. It's about, 7 times faster, 6 times faster on .NET 7 by having this reflection emit functionality built in. And similarly for the 1arg method, with what was taking 82 nanoseconds on .NET 6 is taking about 20 nanoseconds on .NET 7 for about 4 times faster. And this is just one of those things where you upgrade and all of a sudden, if you're doing this in really hot loops, you're going to notice a performance boost. Moving on, another category that is sort of near and dear to my heart is it's really easy after you've implemented a solution to a problem to forget that all the research you did, things may have evolved since then. And there might be a better solution available to your problem. And you can see all the research going on in academia and in various corporate think tanks and work groups. There's a lot of interesting research happening in computer science that we need to reconsider every release. Are there areas we could improve based on that research? So one example where this impacted .NET 7 is some research from MSR, actually, Microsoft Research, that's gone into our regular expression engine. Or some really nice new math, basically, that came out of, I believe it was JP Morgan Chase, around how to do some math around calendars. That's allowed us to improve some of our core primitives in date time, getting the month, day, year, stuff like that. And then some lovely work out of a professor in Canada, Professor Daniel Lemire, who he and some of his associates came up with an approach for parsing floating point values about twice as fast. And that is now built into .NET 7 as part of double float triparse. So let's dive deeper into one of these, in particular, regular expressions. So some of you may remember back in 2016, there was an outage at Stack Overflow, where for, I don't know, it was 20 or 30 minutes, the system was down. And Stack Overflow released a really nice post-mortem after the fact, detailing what went wrong. And what went wrong was a regular expression that hadn't been fully validated for its performance characteristics, getting past a particular input that basically spiked CPU on all of the front-end tier servers. So what I've done here is I've just extracted the details from that post-mortem. I've got the particular regex here and the particular input they described, which was basically 20,000 characters. And in the bad case, it was 20,000 characters that did not end in a white space. And now I've run this on .NET Framework 4.8, .NET 6, and .NET 7 using the good input. So we have 2 inputs here, a good input and a bad input. And now if we look at just the good input, we notice something really nice. .NET 6 is about 10 times faster than .NET Framework 4.8. .NET 7 is about, 15% faster than .NET 6. Yay, we're making forward progress. Now we try the bad input. And the good news is .NET 6 is still about 4 or 5 times faster than .NET Framework 4.8, and .NET 7 is more than 2x faster than .NET 6. Woohoo! You can see the downside here, or the bad news. The bad news is all of these numbers are like 14,000 times worse than the good input. There's this huge disparity here. And that's what this research has gone into address with a new option in .NET 7 that is regex options.non-backtracking. This is a fully implemented engine that's able to support most, not all, regular expression constructs. But if you limit yourself to that subset, it has this exact same semantics as if you're using the regular backtracking engine, so you can switch back and forth. And the important thing two important things to note, actually. First, for the good input, it is a little bit slower than at least the .NET 6 and .NET 7 implementations. In this case, for this particular input, it's about 5x slower. So this isn't always necessarily going to give you the best performance. However, you notice that for the worst case, it is orders of magnitude faster than all of the other numbers. And in fact, it is exactly the same whether it's a good input or a bad input, subject to minor noise in the benchmarks. And that's the really important thing with this option. You get the same semantics as with the backtracking engine, but you get consistent performance regardless of the input that's being provided. Some really exciting work in .NET 7 here. Another category of work is sort of, or of improvements is thinking about all the places that we can reuse existing functionality. As developers, we like to kind of hand roll things, but often if you just take advantage of the built-in helpers for things like searching with index of, every release, when we make those operations faster, anyone who's relying on those operations themselves gets faster. And so we've done work in this release to not only improve those primitive operations, but also use them in as many places as we can in our own code, such that not only your code using it gets faster, but our code using it gets faster, and then your code using those indirect uses gets faster, and so on. So here's a simple example. We did some improvements in the vectorization of index of, for searching strings, spans, etc. In this particular case, I've got the complete stories or works of Sherlock Holmes from Gutenberg, and I'm searching for elementary, my dear Watson. And you can see in this particular case, when I search for elementary in .NET 6, this was taking about a millisecond, and on .NET 7, it's taking only about 57 microseconds. So a huge improvement there. What's that, 20x? Because we're doing a better job of figuring out exactly what to search for and how to vectorize that search. Similarly for ordinal and nor case, we're also employing a better form of vectorization now, and so this also gets about four times faster. Continuing in that theme of taking advantage of these helpers, any place where you're not, it's worth reconsidering, are there workarounds that you've employed where you'd be better off just getting rid of your workaround and going back to the original thing. So here's an example of that. This comes from some real code, which I've simplified down. If I want to look to see whether a URL begins with https://, I can use starts with, ordinal ignore case, because I don't care about whether it's capital HTTP or lowercase HTTP, and so on. Now, at some point, when someone wrote this code, they must have benchmarked this and realized that they could do it faster if they just open coded it, if they just did it themselves. So we have they're checking the length here to make sure it's at least 8 characters. Then they're doing some really cool ASCII tricks, recognizing that the uppercase ASCII letters differ by only 1 bit from their corresponding lowercase letters. So if I just OR in 0x20, I can do a single comparison for each. And they probably benchmark this. And in fact, when I benchmark this on .NET Framework 4.8, I see indeed the open-coded one is 10 times faster. Woohoo! Good day's work. 2 nanoseconds instead of 20 nanoseconds. But then let's say we run it on .NET 6. Well, it's still faster, but both of the numbers have actually gotten faster. The 21 nanoseconds has dropped to 6 nanoseconds. The 2 has dropped to 1. Still better, but is it worth it? Maybe. Depends on the use case. Now we go to .NET 7. And now, not only is the open-coded version way more code to maintain, it's also twice as slow as the built-in implementation, where the JIT is now recognizing these patterns and is able to generate the most optimal implementation it can muster for the simple version of the code. And so anytime you're employing these kind of workarounds where you want to revisit them and figure out whether we can just make the central thing better, everyone can use the central thing, and anytime it gets better, everyone's code gets better. And speaking of getting better, another important lesson is no matter how much you've optimized, there's always more opportunity. There are always new things you haven't explored. Maybe there are improvements elsewhere in the system that you previously dismissed because they're too slow, but now they're actually highly optimized and you can take significant advantage of them. And a great example of that, again, comes from regular expressions. So here is this particular benchmark. Isn't actually one that I came up with. This is from an open source repo that's comparing the performance of regular expressions across a whole bunch of languages and frameworks. So I've just copied that expression as well as the input that repo is using. And I'm counting how many times an email address, which is what this expression is meant to find, occurs in this input text. And if I run this on a variety of previous releases of .NET, we can see on .NET Framework 4.8, this was taking about a second. You go to .NET Core 3.1, it improves by about 10%. That's pretty nice. You go to .NET 6, and oh man, it gets what, about 20x faster at about 49 milliseconds. And then you go to .NET 7, and it gets even orders of magnitude faster at about 620 microseconds. But then there's even more opportunity. So one of the things we've done in .NET 7 is introduce a bunch of additional methods onto regex for doing both specific operations like counting, which is what I want to do here, or enumeration without actually allocating, sort of amortized, non-allocating matching with regexes, as well as be able to pass in spans that I can slice or get from wherever it may be. Maybe I stack allocated some memory, or maybe I got some data from native code. I no longer have to copy it into a string to search it. I can just pass a span directly into the regex engine. And now when I just change the code to use this simpler code, it's also faster. It got about 20 microseconds faster, and you'll notice that lovely allocated column is blank. That's because there was nothing allocated as part of this operation. So there is always more opportunity. And then finally, one last category to think about, and there are many more than this covered in the paper, but one more for this presentation, is being thoughtful about your defaults. And we strive, when we design APIs, when we design language features, we try really hard to come up with good defaults, where if someone uses something, they're going to get kind of really great average case behavior, average case performance out of the box. We don't always get it right, and I imagine you don't always get it right either. So it's worth thinking about those defaults both for new things and revisiting previous choices. And an example where we revisited a previous choice in .NET 7 is with compression, and specifically with Brotli compression. Brotli is a compression algorithm from Google. We've been shipping an implementation, a Brotli stream type, and Brotli encoder and decoder in .NET since, I believe, .NET Core 2 or 2.1, around there. And if you look at the Brotli compression algorithm, like many compression algorithms, it has a knob you can turn, a dial. In Brotli's case, it goes from 0 to 11. And on one end of the dial, you have really, really, really fast compression, but maybe not the best compression ratio. So maybe you end up with a larger output. And at the other end of the spectrum, you have the smallest possible file size or output size it can muster, but it might take a really long time for it to figure out how to optimize it fully. Now we can see I benchmarked both size and time on a particular file in this case, and we see from 0 to 11 a nice sort of linear progression. Excuse me. As I turned up that dial, going from about 2.5 megabytes down to about best compression ratio down to about 1.7 megabytes. But on the time, we see not so nice a linear scale. In fact, towards the upper end, it starts looking extremely exponential. Now, the problem is that in prior to .NET 7, we chose a default of 11. Which meant that by default, if you just set new Brotli stream, you were getting the rightmost side of these graphs. That meant best compression possible, but also absolutely abysmal throughput. So with one of the smaller significantly performance impacting changes in .NET 7, we basically changed our default from 11 down to something more in the middle, around 4. Now, this does mean that by default, your output sizes might be a bit larger. In fact, if I run a simple benchmark, we can see that for this particular input, the resulting output is about 20% larger than previously. Now, all you have to do is set a compression level, and you can get exactly back to what it was before. So we're just changing the default. But in exchange for that 20% increase in size, we have about a 50 or 100x, about 50 75, I don't know, I can't do math off the top of my head, somewhere between 50 and 100x improvement in throughput. And we think this is a much better use of your time when using Brotli as part of your algorithms. So that was just a really, really quick tour through just the tip of the iceberg. If you have a few moments or maybe a few hours, I'd welcome you to go read the blog post about .NET 7 performance improvements. I'd welcome feedback. We'd love for you to actually get involved and contribute to the next incarnation of that paper by contributing pull requests to .NET 8, which we've already started working on and which is going to be an amazing release a year from now. So thank you very much. Back to you, Richard.
Thank you so much, Stephen. You blow my mind as always. I can't believe the ongoing performance improvements we continue to see from Csharp, and you got some great questions coming in from Twitter. I'm going to start with this one here. For Menham asking, let's dive deeper because he doesn't know we're already feeling like we're at the bottom of the ocean. Okay, not a question, but boy, oh boy, he's not wrong. He had another question, which I thought was a little more technical here. Same fellow. Aren't there some cases that this type of looped optimization in .NET 7, which Stephen's talking about, actually involves some logical bugs?
To my knowledge, there are no cases where we introduce bugs. If there are, that would be a bug that we should fix.
Yeah, I would presume so. And you always have a test suite for all of that as well, right? Whenever you do an optimization, you match behavior exactly in the new in the optimized version.
Yeah, every PR we run a pull request. We run about 8 million tests across multitude of operating systems and versions of operating systems and so on. Plus then kind of not as part of PRs, we have an additional set of tests that we run kind of on a rolling basis on a huge number of platforms. Now, there are always gaps. There's always the possibility that we'll introduce bugs, but we have a very, very large test suite in order to try to catch these issues. Some slip through. That's why we have servicing releases, where every month we will ship bug fixes for things that are either brand new in that release or maybe that have been latent for many, many years and are only just noticed. But if you do find a bug in how the JIT is compiling loops, we would love, love, love to know about it. So please open an issue in .NET Runtime Repo.
Yeah, and so GitHub's there for a purpose, right? We'll be able to put the issues in directly to you and see them directly addressed back again. Hey, let me give you a little more philosophical question as well, which is, why didn't you optimize this stuff in the first place?
That's a great question. I mean, we strive to optimize things in the first place. In some cases, there are opportunities where we just didn't notice them. Maybe we got smarter or we learned from other people. For example, the index of case. We're actually taking advantage of a really nice algorithm that was designed by someone outside of Microsoft that's become really popular amongst various frameworks and languages in recent years. And so we're building on the shoulders of giants, taking advantage of somebody else's work there. In other cases, we're able to build on our own shoulders, work that we've done in previous releases to improve sort of lower level things or add new lower level constructs that we can then use elsewhere in the libraries. For example, we did a lot of work in .NET Core 3.0 and .NET 5 to add literally thousands of new methods that represent direct hardware instructions for doing SIMD. And then in .NET 7, we added new Vector 128 and Vector 256 APIs at a higher level for taking advantage of all of those hardware instructions across platforms. And anytime we add those kinds of intrinsics or helpers, we can then go and take better and better and more advantage of them elsewhere in the platform, finding more and more opportunities to sort of leverage those underlying performance benefits. In other cases, it's research. I mentioned all the stuff coming from MSR or from other companies or from academia. There's always more opportunity, and as much as we try to get it, quote, quote, right the first time, invariably there's always more to do.
I really appreciate your point that computer science research continues to go on, and MSR bringing you things and moving that hardware underneath you so that you now have to take advantage of it. I get that too. I was also thinking that sometimes your customers use your product in a way you've never thought of, and it introduces a new optimization opportunity.
And in fact, many of the performance improvements that come from outside of our team are things where we just weren't looking at it. Someone else had they were using some code path that we weren't focused on, and it ended up being a bottleneck for them. And the beauty of open source is they can come in and contribute a fix to something we may not have touched or may not have realized was even an issue, and they can improve it not only for themselves, but for everyone else that happens across that code path in .NET.
Wow, I can't imagine trying to do my own optimizations to the code base. That's stunning to me. But I guess it's a possibility. Does it happen very often?
It's actually pretty common. About 20% of the performance improvements that I sort of document in my paper came from outside of our team. And a lot of times it's removing an allocation here or finding that some code here could have a fast path that's actually quite common. Or there are certainly some of the more intricate ones, someone going in and actually adding an optimization to the JIT. Those are more impressive generally. But there's a wide spectrum, and we love them all.
Stephen, I'm wowed as usual. Thank you so much for your contribution to .NET. I love that my code runs faster with each new version. And we've got to move on to the next subjects, but make sure you do your survey. Links below me here. We need that feedback to know exactly what's going on. And don't forget our great sponsors. They've put together some awesome swag bags. And if you do the secret decoder, tomorrow we'll be doing a draw. Now it's time for me to hand over to Parsons, talking a little bit about how language features actually get built. So if you wanted to understand how the plumbing works, we're talking to the right guy. And I'll talk to you afterwards.
All right, hey everyone. My name's Parsons. I'm the C# compiler dev lead, as well as a member of the C# language design team. And here we're here today to talk about let's design a language feature. And what we want to do in this session is kind of pull back the curtain a little bit and show you kind of how the language design process works. How do we start from a problem and an idea and get through all the twists and turns to a shipping feature that we deliver as a part of the .NET and C# releases. And what we're going to be doing in this session is we're going to be using an example of a feature we shipped in C# 11 to kind of take you through that process. And that is file local types. Now, all ideas start with a problem. In this particular case, the problem came from our source generators teams. Now, for those of you who are unfamiliar, source generators are a way that the library authors can plug into the compilation process. They can look at the code you're writing and use it to generate code to augment your application. They can add new functionality. They can add optimizations by moving stuff that used to be done at runtime into the compile time part of the process. And we're shipping a lot of generators with .NET 7. We have like the JSON generator, the library interop generator, and like what we're going to be looking at here today is the regex generator. Now, what the regex generator does is normally when you use a regular expression in .NET, at runtime, that expression has to be parsed. They have to generate all the code to do the matching at runtime. That can impact things like startup. It can limit your optimization opportunities. But now in .NET 7, we have the ability to, at compile time, do all of that work. And you can see here that I have this nice little partial method called getEmailRegex. And I have this attribute generateRegex, which tells the regex generator, hey, here's a regex that I want you to process at compile time. And we can do a nice little go to definition here, and we can look at what this generator is doing. It's taking that regex, it's processing it, and it's generating all this beautiful code here, nicely commented, that's actually processing that regex. And it did that all at compile time instead of at runtime. Significant performance wins for our applications. But the regex, the generator authors came to us because they found a bit of a problem with this approach. Because in order to do a lot of their generation, they have to generate these helper types, like you'll see here, this derivation of regex, getEmailRegex0. And they said, this is a bit of a problem. We really want these types to be implementation details of our generators. We don't want users depending on them because this is something we want to evolve over time to continue making these scenarios better. But unfortunately, it's a part of the compilation and users can see it. Worse off is that when users are typing, IntelliSense actually shows it to them. It starts leading them down the path, telling them, hey, this is a type that you should use. Look at all these cool members. Take dependencies on them. And this is something they worried would inhibit their ability to evolve these generators in the future. And also, there's another problem. What happens if the user defines the exact same name type that they want to generate in their code? Well, that means that their generated code stops working. And in order to solve this problem, they have to complicate their generation process. They have to start scanning the compilation, looking for any types of that name, and making sure they don't have conflicts. And overall, they felt like that this made the generator scenario a bit more fragile, a bit more incomplete. And they were looking for ways to solve it. But they also had an idea. They came to us and said, listen, why don't you let us write private in front of these top-level types? And the effect we would have there is make that type local to this file. It doesn't conflict with types and other files and other people can't see it. And this is where kind of the language design process starts. We have a problem. And we have an idea for a solution. And it fits in with some of the big themes that we're shipping in the current version of .NET and C#. Now, you may have, at this point, be asking yourself, did I come to the right presentation? The kind of promise of this presentation was it's going to talk to us about all the problems you hit in the language design process. But it's just one word. This is just one word and one scenario. How hard could this really be to design? Well, first off, let's talk about that word, because one of the things that we focus on a lot in language design is syntax. And this is a new type of syntax that we have to look at. And one of the first questions we start asking ourselves is this word going to stand the test of time? For example, right now the idea is just how can we make types local to a file, but a logical way you could extend this feature in the future is making it apply to members, methods, and properties and making them local to a file. And private's not going to work if we did that because private already has meaning in those scenarios. So that's just not going to work. The next thing we talked about is what if we just take two existing modifiers, slam them together, and let's create a new one. And let's use private internal. And this may seem silly, but this is something we've done before. A few releases ago, we introduced private protected to express a new form of accessibility in C#, and it was a very successful feature. But it is a bit wordy. It doesn't really ring the scenario we're trying to get here. It doesn't really scream this is local to a file. So the next thing we talked about is maybe we just use modify private. We say, hey, private was a good idea, but let's give it a little more meaning by saying file private. And this is going to resonate with customer. This reads really, really well, and people are going to kind of get an intuitive understanding of this by looking at it. It's also a bit wordy, though. It is using two words where we felt like one word might be enough. And so eventually we kind of said, let's just use file. File is nice, it's descriptive, it's simple, and it's going to extend to other scenarios in the future should we want it to. And after a lot of discussion, this is where we came out with. This resonated the most with the language design team, the generator authors, as well as the various community members we talked to. And I've made this process a little bit silly, talking about the ways we deal with words, but the look and feel of C# is incredibly important. And we spend a lot of time talking about it, rat-holing, and going back and forth on the ideas. And we spend a significant amount of time on even little tiny problems like this. But the next thing we do, and we did in this case, is we said, hey, have any other languages done this before? Because if other languages have solved this problem, we can look to them for inspiration. We can see what went well with their implementation. How do customers use this feature in their ecosystem, and what can we learn from it to make our feature better? And when we looked around, we found lots of examples of other languages that do this. For example, F# has the concept of signature and implementation files. Very similar to like header files and C files in C++. But they have this really nice property. Only things that exist in the signature file are visible to other parts of the program. If you have a type that is only in an implementation file, it is limited to that file. And that is almost exactly what we're trying to build here. Has a bit more ceremony involved, but it has the basic properties we're going for. And this is a very successful feature in F#. It's used in lots of programs to wild success. Next, we looked at like Golang. Golang has a similar concept called package level visibility. Their mechanism is a bit different. Uppercase type names are visible outside the package. Lowercase type names only visible within the package. It's simple, but it is very effective, and it is highly used by the Go community. And these are not the only two languages we found this in. In fact, when we looked at other languages, pretty much every language we looked at had this type of capability. And this made us feel really good about this feature. It made us feel that we were going to be using a feature we're designing a feature that was not just usable by our source generator community. It was going to be something that was going to be generally usable by the C# developers. And so we felt really good at this point. We felt like we were on the right track and going the right direction here. So we took a step back and said, okay, before we get further into the design process, one of the things we want to do is establish the core properties of these features. What are the things that the experiences we are trying to deliver when we get to the end game here? And this is really important because sometimes you can get very deep in the weeds in language design, very deep in the spec, and it really helps to have these properties established that you can come back to and say, okay, this is the problem we're really trying to solve. How do we apply it to the current thing we're doing? And the core properties we had here is that if you have a type or a member marked with file, we want to make sure that, first off, you don't have to think about any other name conflicts in other file. What you're writing is what you get, and you can just simplify your world to this file. Also, this type cannot be observed outside of this file. I don't have to worry about people taking dependencies on it. I don't have to worry about any kind of weird conflicts. It is just right here. And lastly, what we're doing should not be observable by other languages. I mean, if we go through all the work of actually doing this in C#, but then F# can see all these types, it devalues the feature just a little bit. So with that in mind, The next thing we often do in language design is we say, hey, can we generalize this? Yes, we have a problem, we have a solution, and it looks like it's going to solve it. But is there a bigger problem we can solve here? Can we tweak this idea just a little bit and get a lot more bang for our buck when we do this feature? And there are two ways we looked at generalizing this feature. The first one was we said, hey, what if we also said, let's make types local to a namespace. Let's have this idea where a type is only visible to the namespace it's declared in. And when we looked around the kind of the .NET ecosystem and even like the C# compiler codebase, we found a lot of evidence that this would be a valuable feature for customers. To the point that we got pretty far in this design, but eventually we kind of stepped back and we said, yes, this is valuable. It seems like this would add a lot of good to the language. But it isn't actually necessary for us to ship .NET 7. And we do have a finite amount of resources for innovation in a given version of .NET. So we kind of put this one on the back burner. We said, this is a good idea. It's going to have value. But let's come back to it later, maybe in a new version of .NET. What we spend a lot of time on, though, and what we're going to talk about here, is whether or not we should let file apply to methods and properties. Now, intuitively, this does probably seem valuable. Like if I want to make a file local, a type local to a file, maybe I want to make a member local to a file. But there's a big gap between saying you want something and figuring out how to make that a reality. Like, what do we do in the compiler to make that enforcement real? And the first thing we thought about was maybe we just make file an access modifier. In the same way you have public and private protected, let's just make file a new modifier. Unfortunately, that has a lot of problems. First off, you have to go and change the IL specification for .NET to recognize the bit pattern for file. And then you have to go to all of the languages in .NET and make sure they recognize it. We have to go to F# and we have to say, hey, we have this new access modifier and we really need you to recognize it. And lastly, you have to go and update a ton of libraries. Like, there are a lot of libraries and code that look at metadata in libraries. So you have to change reflection. You have to change like any kind of metadata reader. And ultimately, this is an enormous cost to the ecosystem. And while it would work, and this is a valid way to do it, the cost is just out of proportion with the benefit that we would get from this. But we weren't done. We had another idea up our sleeves. What if we just took those methods and we emitted them with an unspeakable name? So an unspeakable name is a technique where when we admit to metadata, we just put funny little characters, usually less than and greater than signs, in the name. And that is a tried and true way for compilers to say, we want to hide this member from other compilers. This does not have the ecosystem cost associated with it. All the compilers recognize this pattern, and it would give us a way to hide these members from other languages without boiling the ocean. And C# does this a lot today. For example, if you use anonymous types, we emit them with this like unspeakable name where we have that less than and greater than sign as a key to ignore this particular type. Same with anonymous delegates that we generate. And even if you used a record before, part of the with process of records is we have to clone the original record before applying the new property. And that clone member is emitted with an unspeakable name because we don't want people using it. We want that to be an implementation detail of the compiler. And we could apply the exact same logic to file members too. If you said file void create, we could emit it with an unspeakable name. That would make it invisible to other languages. That would make it local to the file and really kind of achieve those goals we were going for here. Unfortunately, we found out that when we dug into this, that this has a number of side effects that are really unfortunate because a lot of features out there depend on the name you emit from members matching the name that the developer wrote in code. For example, interface hookup depends on name matching. If you're doing any form of reflection, like data binding, the developer needs to know the name that they wrote is the name that is in IL. And even C# features like dynamic depend on the names matching. And so while this would work, we could implement a like coherent feature here, it would massively subvert user expectations and break other scenarios. And we decided that that was not a good path for us to go down. And this kind of ended our exploration of using file on members and properties. We had a couple of ideas on how we could make it work, but we decided the cost was just not in proportion with the benefits of providing it. And so the final design we came up with this feature was we were going to give the developers the ability to annotate their types with file, and those are just going to be very local or private to the file they're declared in. And at this point, you might be saying to yourself, like, isn't that where you started? Didn't language design just go in like a big circle here and spend about like a couple of weeks doing it? And largely that's true. Modulo changing private to file, we ended up basically in the same place we started. But this wasn't wasted time. Along the way, we looked at other languages. We gained confidence that this is a general purpose feature that people are going to benefit from. We explored new features that we could do in the future in the form of namespace local types, as well as we charted a path forward for how we could extend this in the future to apply to members. Yes, we ultimately decided the cost wasn't there this time, but it could be the cost dynamics could change in the future. So while we did end up where we started, we have a better understanding of kind of what we're shipping. And we should always do this. We should be pushing the boundaries in design and trying to generalize. Sometimes it works, and sometimes we find a much bigger set of scenarios that we can tackle. But sometimes we end up largely where we started, and that's okay, as long as we kind of get this enhanced understanding as a part of that. But we're not done yet. As I said earlier, we have to find a way to kind of make this work. It's great to say that this type is local to this file, but how do we make that a reality? And as we talked about before, naming is the key here. We have to find a way when we emit this type into metadata that it has a name which is local to the type. And this name has to have a couple of properties. It needs to be unique per file, it needs to be hidden from other languages, and it needs to be the same between builds. If I build my code 10 different times, I need to get the same name every time. That's just a general property of compilers that you have to have. But it does mean we can't do anything cute, like saying that the name is just GUID.new GUID, which would meet the other two properties very easily. Now, when we think about kind of a solution for what are we going to name these types, a couple of the parts of the name are very easy. We need to include the namespace the type is declared in, as well as the actual name of the type. But we need to create a segment that makes it unique to that file. That little part right here. We need to figure out what that is going to be. And we talked about a couple of ideas for this. Firstly, we said, why don't we just make that the file path? After all, that's the whole point here, is to make it unique to the file, and the file paths are unique. Well, unfortunately, file paths have a couple of properties with them that are bad for us. One, they have an unbounded character set. Every file system defines what is legal for them. And many of those identifiers and characters in file paths are not legal as names and metadata. Also, paths can be arbitrarily long, to the point where it would kind of exceed the limits we have for identifiers in IL. And so we kind of discarded that as a solution. Then we talked about, well, why don't we just use the file name? We could force that to be unique, right? Well, that also didn't really work, and we had to kind of discard that as a solution because file names can be duplicated. But then we kind of stepped back and we thought, and we said, okay, every time you compile, files are passed to the compiler in the same order. So instead of using the path of the file, why don't we just use the index to where it was passed to the compiler? So as you can see here as an example, when we compile this simple program, we have 3 files, application, data, and container. Container is the 3rd file, so it has index 2, and we can just use that as that unique little segment there. And that works great. That actually solves all of our problems that we talked about earlier. We now have names that are local, unique to the file, and we have a way to implement this feature. But at this point in time, we did something we do with every feature, which is we involved the rest of kind of the C# IDE team. This is the team that is building kind of the Visual Studio and VS Code experience for C#. And we involve them because when we ship a feature in C#, we don't just think about kind of the language and the compiler. We think about the ecosystem of features that make up that developer experience, because we want these features to pop everywhere that you can use them. And they pointed out a flaw in what we had done here. They said, hey guys, we have this really awesome feature. It's called edit and continue. And you know what you can do with edit and continue? You can add and delete files from a program. So that customer, they could just say, hey, why don't I just delete data.cs? That in turn is going to change the order of files passed, change their index. That type name is now going to flip to have a different number in it, and that's going to result in a ton of root edits. And this is a big problem because edit and continue is a super valuable feature for our customers. And we just inadvertently made a design which basically made edit and continue extremely hard to get right. But the benefit of involving more voices here is they came to us and they said, hey, what other ideas did you all consider? Let's talk it through. Maybe we can help you out here. And we walked them through the process we'd gone through, the ideas we discarded. And they said, hey, file paths were actually a good idea, but why don't you just put them through a checksum first? Why, once you put them through a checksum, it'll be unique on one side, unique on the other. Also, it'll have a fixed character set and a fixed length. And that solves all the problems you all originally had with file paths. And they were right. It was a fantastic suggestion. It ended up being what we shipped. We now take the file paths, we pass them through a SHA-256, and use the resultant IL. Now, that name is super unreadable compared to the ones that we were talking about before. But at the same time, it doesn't matter. This is an implementation detail of the compiler. What matters is we now have a mechanism to implement file local types. And with that, we essentially have the solution that we were going for. And now we can kind of see that solution in action. So if we go back to this original example where the generator author said, hey, we want to use private, you can see that we have all these errors here because of the duplicate type names and such. Well, we can now just flip this over to file. And you can see immediately the errors go away because there's no longer a duplicate type problem. This type is specific to this file. It is completely isolated, and the generators can think only about this file when they are writing their code. Even better, when we flip over here, you can immediately see the error squiggles change because this class no longer conflicts with the one that the generator was producing. And as a result, we have an error up here because there's no member instance on this type. Now it's even more fun is we go up here, if we start typing like we did before, notice IntelliSense is not offering me to use get email regex because it is specific to the other file. It is not available here, and as a result, IntelliSense is hiding it. But it's not like we hide it all the time. If we go to places where it's legal, we can see IntelliSense is happily suggesting it to me. It's showing me it's there for me to use. And so now we have kind of solved this source generator problem. We have made this overall scenario a lot tighter, a lot more reliable, and we've also provided a feature that customers can just use generally in their C# code. All right. And so thanks so much for being a part of this session. So I think now we're going to flip it over to some Q&A questions.
Thanks, Jared. Awesome stuff. It's amazing that we're still talking about files today. It's not something that ever goes away, although I'm talking to kids these days using technology, and I hate to say kids, but I'm in my 50s, so I've been doing this a long time. And it seems like a younger generation user doesn't even think about files, even though we know they always exist. So I'm really impressed with the work that's going on here. Is this a feature that was really driven by user demand, or did you feel it needed to be addressed?
So this is a feature that we've had kind of rumblings for in the past. There has always been a bit of a desire to say, hey, as programs have gotten bigger and bigger and bigger, how can I effectively, we have great mechanisms for hiding code between assemblies. You can use internal or private and keep code isolated to an assembly. But as assemblies have gotten bigger, customers have pushed on us on ways of how can I isolate parts of my library or parts of my application so that they just don't inadvertently talk to each other in ways I didn't want. And we've had numbers of suggestions over the years. Early versions of the Roslyn code base, we actually had a unit test where we would dig into all of our emitted code and make sure that certain namespaces weren't talking to each other. And so we've had rumblings on this for a long time, but we've never just had that push to get us over the edge and say, all right, it's now time to invest in this and make this a real feature. The generator scenario was one where it finally gave us that push. It's a feature we've kind of wanted to do before, but now we have a compelling scenario that is part of one of our big themes for .NET 7 that could really kind of put a nice little bow on that whole thing. And so that's what kind of gave us that push to go over the edge and design and ship this feature.
And at the same time, you're banging right into that sort of hardware versus software thing. I mean, fundamentally, a file is a singular entity. So you really don't want to have multiple pieces of code trying to touch it at once. Like every time you run into that separation between what we can run in multi-instance parallel and so forth versus what's physically on a disk, that's got to be a problem.
Yeah, it can definitely be a challenge. Like files are really problematic. And even if you think about the fact that like Roslyn, the compiler, is actually an API. Like this is an API that we provide to like the IDE team for helping them generate IntelliSense, for users compiling code on the fly. File paths there's not necessarily physical files when you're doing a compilation. Some of these things are just in memory. Like you can absolutely construct compilations in memory and emit code. And one of the things we really had to struggle with is like, in a lot of corners, you don't actually need even file paths. Like you can actually manipulate the APIs and libraries so that you're just compiling code without any paths associated with it. And like, how do we solve those problems? And those ended up being some interesting challenges kind of in the compiler. But yeah, the mix between like physical and non-physical files has really gotten blurred, particularly as we've moved the compiler from this kind of physical command line batch tool to a full-fledged API that we hand out.
Yeah, right. And the concept of a file being separate from the physicality of a file. Because of course the other part when I think about the physicality of the file is now we're stepping out of that managed memory space. We're trying to talk to the operating system. I'm not going to say Windows because it might not be. And how does the operating system actually address that physicality of the file on the drive, wherever that may be, or whatever that may be?
Yeah, it can definitely be a challenge. We have lots of fun with the file system, and particularly having to deal with the fact that like file systems are not consistent. Like one of the ideas we end up with a lot is like, what do we do with case sensitivity? Because we have to decide things, are you giving us the same file twice and things like that. And even on a given file path, parts of it can be case sensitive and parts of it can be case insensitive, depending on how weird your file system implementation is.
Well, right away it's Linux versus Windows. That's the one you're going to run into for sure. But how much of that is owned at the lower level into the operating system runtime versus what would live in the CLR for you?
A lot of that is handled in the libraries for us. Like they deal with a lot of the low-level kind of managements of the files and the interactions. We are at the compiler level. We're a little bit removed from that. We're mostly just opening files and writing them to disk. So a lot of that is abstracted from us. Mostly like I said, the biggest challenges we have to deal with is just whether or not paths are case sensitive or not.
And I'm actually going to grab a question from the board here. This one's from Inva. This latter part I think is very powerful, which is how do we follow these discussions? Having really enjoyed your thinking and your team's thinking through a language design feature, is there a routine way that you expose that to us, that we can actually see those conversations you're having when you consider new design features?
Absolutely. So if you go to the GitHub repo .net/C#lang, that is the repository where we kind of host our language design process. So we have regular language design meetings, typically 2 times a week for 2 hours each. After each one of those meetings, we post notes from that session. And so that's the way to kind of follow the active discussion of the language design team. We also, all of our language design process is done in that repo. All feature ideas pretty much start out as discussions. And then from discussions, we evolve to like physical, like actual proposals that can be championed by people who are on the C# language design team. And then from there, they start moving through that design process, and you can follow them in the meeting notes. And also, you can just ask questions. Like most of the language design team is pretty active in the repo. If you ask questions, we can get the right people kind of on there to tell you how things are going and why we have or have not pursued certain ideas.
And I got to think this part of the fun part of that whole thing, exposing that all on GitHub now. That's the new way to work. It's only been a few years you've been like that.
Yeah, we've been on GitHub, I think about 6 or 7 years now, but it did take us some time to take what used to be kind of this very internal process where we just kind of had internal documents and internal meetings to like, how do we expose it to the community? How do we get them involved? And like, how do we even like open up, set a path down for them of like, hey, if you have an idea, like these are the steps we want you to take so that we can treat it seriously, invest our time in helping you make that real and start pushing through the process. And we've been increasingly successful over the last few years, as I think pretty much every release now, we have 1 or 2 features that have been very largely driven by community members from all the way from the design to implementation.
Jared, that's super awesome. Thanks so much for your time. Great talk as always. It's really a great insight. Hey, we got to cut straight over to the next one. I've got a panel conversation to do next, and I get to participate to some degree. So come with me as we come sit with Michaela Hutchinson, Davian Edwards, and David Fowler, real architects in software. Not like me, I'm just a professional storyteller, but somebody has to manage these folks, and I'm going to be able to take your questions directly on the board here as well, so we'll be able to keep going. Let's kick this thing off, guys.
Awesome.
Let's do it. How do you get to designing language features? Like, we just saw Jared walk through a great piece, one particular case, but how much of this is internal inspiration versus what your customers are asking for?
It's a bit of both, I think. It's a bit of both. Like, for example, during .NET 6, we worked fairly closely on the ASP.NET Core features to do with minimal APIs. And the desired outcome for the coding experience that we wanted for our customers with regards to like what code you actually write in the CS file in the first 15 minutes of using ASP.NET Core, we were hitting some aesthetic issues. We was like, well, we don't want the code to look like that. We want it to look like this. And then the reasons it didn't look like that today were due to language design things. And so we worked with the language team to drive those changes through. So that's one example. Then obviously there are examples where people log issues on GitHub or wherever it might be.
So, and I mean, I'm aware, so we've talked about this on .NET Rocks at times too. It's like the issues that come into GitHub, that is your meeting, right? Like that's part of your whole conversation about design for everything.
Every week we triage with the whole team all the issues. We sit around as a team, we sit in the room, we go over every issue, and we decide what we need to put as feedback for every issue. So what's funny about designing like, features and language design features are, we wanted the code to look a certain way. That seems very easy from the onset, but to actually change the language to get that code to be written is insane. Like we had to fix issues in overload
Resolution,
and we have to fix a couple more things like that. It was very difficult to actually get the changes in to make the code look good. And for us, it was like, let's just make the code look like X. That was
so
a
you
big
sort of drew
issue.
that on the
we
board.
Drew on the board.
It should be
that
expressed
was a
like
vision,
this.
but it was like, then Jared was like, we're going to have to change this and that and this has to gel with that feature and this other feature. And we were like, okay, but in the end, we want this.
It's probably like working with an interior designer.
Oh, yeah.
And the customer is like, well, I want the wall to be this color. And then the interior designer is like, I don't think you understand all the things that have to happen for that to actually work. And I'm not a language wonk by any stretch of the imagination, so it's a very, it's quite an in-depth learning experience when you say, but why can't it just look like this? And then the 400 things are told about why.
And of course, on one hand, I feel like, are we really that focused on aesthetic? Is that important? But I'm all for readability of code. Is that really what you come down to? Is like, when I look at this, this means what I think it means?
Yeah, a big part of it is syntax. Like one of the big things that we can do is paper over a runtime goop with syntax. So the language can let me do var f equals some function. And for that to work, the language has to infer like 10 things, but the end experience is that f infers the type of function that's being written. And it looks great. And if you didn't know the language design, you would think that would work to begin with. Because like, why couldn't the language infer? I'm telling it the arguments, the return type. Why is that?
Yeah.
And then you dig into the actual design, and you sit in the room with these people that built the compiler, and you understand. You're like, okay, whoa. Okay, that case. Okay, this case. Okay, generics. Okay, open, close generics. Object, delegate. Like, which one wins? So it's really complicated.
Yeah, it's a plumbing kind of
It's
problem.
plumbing, yeah.
It's like, it looks like a faucet on the top, but
Yep.
wait till you get under the cabinet. There's all kinds of things
no.
going on down there.
Yep.
Yeah, I'm a huge fan of things doing what you expect them to do, but that's partly about setting expectations and partly about staying true to expectations. So once people get a sense of how it works, they can actually trust that. So every decision you make, you have to evaluate whether it's breaking those promises you've made.
I love that point, Michaela, too, because you're also talking about changing code I already have working, right? When you talk about changing that view, you are talking about, it's quite possible that I'm going to fire it up with the new compiler, and it's actually laid out differently. Like, am I happy? Do I recognize my own code anymore?
Yeah.
Yeah. The big thing is going from a thing that was an error to a thing that now works.
That is not an error.
Yeah.
We actually changed a bunch of that stuff in .NET in C# 10, I think. And there's a big debate, like, do we want when people recompile their libraries that they get this new behavior change? And I think we actually went over and compiled a bunch of code on GitHub, and we found a couple of cases of like, this library would break if we make this change. And then we have to make a call, like, do we want to make that change? Is it going to be opt-in? Is it going to be a warning? So yeah.
And the language has been around. The more code there is in that language, the harder it is to make those type of changes because you have to consider so many more cases.
Finger in wind. How many people are using this feature? No one is.
Yeah.
First preview, you broke my library.
Yeah, everybody. Yeah. Well, and it is always that great debate about you're not necessarily your customer, right? I mean, even though C#'s used extensively outside of Microsoft, you're definitely going to bump into folks who use your languages and your tooling different. And I think that brings up a really powerful question. Like, .NET is one thing. It is not just C#. There are other languages. There are the base class libraries. There are the APIs, and there's the runtime. How often does the conversation get into about how do we get this feature? Where should it live?
Yes, absolutely. And then even with the context of the runtime or the base class library, there are layers within that as well. In today's modern .NET world, we have we have the BCL, which is the system.star, typically the stuff that ships in one of the runtimes. And then we have Microsoft.extensions, which is a set of BCL extensions, which it's hard to kind of explain the delineation there about.
I would say dependency injection-based libraries that live in the BCL are kind of that extensions-based.
That's fair. That's fair.
Lineage.
And it's stuff that it admittedly started with the development of DNX and ASP.NET Core. And then has moved into sort of its own island that gets reused among a couple different app models since. And then obviously we have the app frameworks on top of that. We have the WinForms and WPF, the existing ones, and then we have ASP.NET Core and other frameworks. And so when it comes down to like where does this live,
right?
And whether do we utilize, say, the runtimes type system, or do we utilize language features in order to allow expressiveness and to build constructs that people can then build their apps on top of? We debate this stuff all the time. Like, should this be a base class that you inherit from? Should it be an interface that you implement? Or should it just be a language feature that you utilize in order to take advantage of this mechanic? And that's, as sort of designers, something that we do quite often.
And there's not one right answer, right? Like
No.
many of these things could have been implemented any of those ways.
Absolutely.
Or do you put it in all the places?
Yeah.
Do you rate limit HTTP client and pipelines and streams? And do you do it in ASP.NET Core? So for rate limiting, we actually put it in the BCL, the core abstraction, the core implementation, and then we built stuff on top in the BCL, in ASP.NET Core to rate limit requests. So we decided that feature was super generic and can be used for more than just HTTP. So we split it into and broke it into like core, implementation, and abstraction in the BCL, and then a feature in ASP.NET Core to rate limit incoming requests. So that's pretty often.
Michaela is newer to the architecture. Like, I've talked to you guys for 10 plus years. I think, Michaela, we first talked back in the Xamarin days?
Yeah, it's been a while. Yeah, I came up from the Xamarin team. I was originally a dev, then became a PM, then kind of ended up in the middle, which is really what an architect is.
You used to have a real job. How'd you end up running with these guys? Like, honestly, why choose to be an architect in this scenario? And I'm just thinking, you bring particular experiences to the table for the architects too.
Yeah, so my area of focus is tools. I recently ended up on the tools team, and I'm very happy about that because tools is always an interest I've had about making these tools that help people build things easier. And I like to think very holistically. Like, I'm one of those people who, when you try and build something, tells you all of the other things you're going to break when you build it that way. I like to focus on how we solve those problems, not just give you the problems, but I like things to be consistent and make sure that we can set those expectations for people and make sure that it works for as many people as possible. And being an architect is really the place to be doing that.
Yeah, no, it's an interesting locus of you're also making decisions that are going to impact people for a really long time. So it doesn't come with a light burden. Related to that, let me grab this question from Dimitri, who said, who decided that minimal API is aesthetically pleasing at all? Because I think there's an interesting question here about what is the aesthetic. And then you throw in the word minimal, because that's a kind of aesthetic right up front.
Yeah. I mean, there's an interesting history there. One thing we haven't talked about, which I was going to mention as part of language design, is we can't ignore the ecosystem, the competitive landscape. Like, obviously, we sometimes have to react, or we sometimes take influence from changes that we see happening in the wider programming language,
competitors,
or software development industry. And one thing that was fairly apparent was that when looking at the experience of very new developers, building APIs, which is a very common thing for new developers to be building these days. Everyone builds APIs. Even if you're building a front-end app, you build an API for it to be called. That when you compared some of the more modern frameworks that really focused on we are for building APIs, and you compared to what that looked like in the first sort of 15 minutes, compared to what it looked like to use something like ASP.NET Core in the first 15 minutes, there were some differences. And then on top of that, there were some other forces, like we wanted to make MVC faster, but we had kind of hit the limit about how much more we could take out of MVC without impacting what makes MVC MVC.
Right.
And so those kind of two things together led to Fowler and some others doing some investigations, right?
Yeah, so we started a project called Feather HTTP, and the goal was to talk to non.NET customers and give them a tutorial where they have to write a React front end and a C# back end. No ASP.NET Core, no names, just C#. And they all had a preconception of .NET being old and crusty and for the enterprise. And by the end of every interview, we did like Go, Python, these devs, and they felt like it was JavaScript. And that was the first so most of the people don't even know about modern C# and how it looks, how it works, how it does feel like other frameworks. And that led into kind of a functional approach. I think in general, there are kind of two approaches to doing web APIs. If you look anywhere, like Node, Go, Java, there's two styles. There's a class-based approach where you have a top-level class like a controller, and it has methods that are routed to by attributes or some declarative means to declare a route. And then I have a function, and I have the function maps from a route to a function, right? And those were basically the two styles that were out there. Right, and we kind of dipped our toes in the other style. I think Damien did it in 2.1. You can call map get, map post, map
felt like I had a big
no one knows
about that.
No one knows, right? It's not we kind of didn't say it was a big thing, but it was a thing that was there for a long time. And minimal APIs was the first time we were trying to say, okay, let's embrace this functional approach and just kind of support direct to. I think we call it route to code. That was the internal code name. Could we make it more direct to route to code? No classes, less indirection. I could just close over state and just write functions, right? Because it's more simpler, it's direct. You can see it all in one place. And how do we simplify startup, program, app settings? There's file new project is super useful, but it has 4 or 5 files. And then you add a controller in a different folder. So you have to go find that class. So how do we start new developers who have never used .NET? How do they find their function? How do they understand by looking at the code that / will return hello world? And minimal APIs came out of I think me and Damien sat down and we started from the Feather code base, and we drew out the end goal. We wrote a to-do app with EF, and I think that was it.
Yeah, in Markdown.
And SQLite, in Markdown, in a gist.
Not in a real file.
It's still there in a gist. And we said, okay, we need to change the framework, languages, and tools to get this endpoint. And every preview, we would check to see how close we were to that end goal. So we changed EF APIs, we changed the language, we changed ASP.NET Core, and every preview, we would go, how close are we now to this end state? And is the end state still good? Right. So that was how we kind of push ourselves past our typical design principles to get to this end goal.
It's always my fear with simplification like that is then as complexity gets added to the app, as the feature set as we go deeper into what we actually need to do, are you managing that complexity well too? Because the actual functional parts of the app are going to be complicated.
Well, there's that, and there's also the tooling aspect. And that, a lot of that structure or that ceremony, there's a word that comes up a lot when we talk about minimal, is the lack of ceremony. A lot of that ceremony that exists is not only useful with regards to creating structure for your app, which helps understanding, helps organization, but it also can create structure for tooling to attach to and tooling to leverage in order to make your code more dry or make it easy to find things. So I know, Michaela from the tooling side, obviously focuses on those types of aspects more than we might, 100% of the time. But we had to take that in consideration as well, which is like, okay, if we're going to remove a lot of this structure towards this goal, what does that mean for all of these great tooling features that exist today? How is tooling going to allow someone to navigate from here to there, or to do this type of refactoring, or whatever it might be? Or what type of new tooling innovations can we create when people are going to be working with this style of application rather than this style of application? Right. So there's always a bit of a cycle, I think, between runtime, framework, and language design and the tooling design. And obviously with the language team, Jared was just up, they work very closely with the tooling team. In fact, they have basically together, the C# tooling and language team are basically part of the same unit. So they have to think about it a lot. And on the framework level, we have a little bit more distance between us and the tooling, but we definitely think about that a lot.
Yeah, because I got to think, if you don't put tooling around a feature like that, people aren't going to use it. Like ultimately, do the squigglies show up in the right places? Does it become a refactoring option? Like, how do I learn about this new feature?
Right.
So very controversial. We changed the template in .NET 6 to start with the new minimal ceremony, like that template. And that discussion internally was, and Damien made the change, so if you want to blame someone, blame him. But the discussion we had internally about how do we get people to see this feature, to even know that it exists, right? So a brand new customer comes to our platform, they do .NET New API or web, and they see the startup class and program and like the 4 files, and it's more complicated. How would they ever find this other way?
Right.
That we want to be the primary way that new developers find this tooling. And this comes to a problem where we have a lot of different customer cohorts. We have like enterprise developers who are our like bread and butter, and then we're trying to get these new developers that wouldn't otherwise look at our stack.
Right.
And how do we like trade off what to put front and center with those two cohorts of customers? Right?
So you're never going to take a feature away.
Right. Exactly. Exactly.
Because people's code depends on it.
Yep.
But
Yeah, I like to think in terms of off-ramps, like when you have the fast way and you have maybe a more complex side underneath that lets you have more flexibility and do more. Like, how do you let people get, like, once they hit the limits, once they realize that maybe for their use case, the fast, simplified way doesn't quite do what they need to do, how can they find their way off? Like, you don't want them to just like go straight off the side of the overpass. You want them to have a nice ramp down, and tooling is a big part of that, right? Whether it's tooling that helps you discover those other features, or tooling that helps you transform your code, or there's all sorts of things.
Because I think the greenfield brownfield scenario is very different there. The new person coming in greenfield is going to use the new language features, especially if the tools put them front and center. But how much push do you have on brownfield to say, you're using a C#2 kind of approach to this. We got C#11 here. Let me show you the refactorings of that.
Yeah, it's not really terminology we use, but I guess that is a natural mirror to off-ramps, which is on-ramps. How do you get people onto the more readable, smoother, simplified way if it is the better solution for them? How do you help them take advantage of these more modern approaches and more modern features? And refactorings are a huge part of that, and analyzers. There's only so much scope those have, though. Those aren't going to help you currently with your project files or, yeah.
And that, Menren asked this question specifically at Roslyn. So much of this new magic is part of Roslyn. I remember talking to Mads back in the day saying, I'm feeling like we're about to have a Cambrian explosion with the open sourcing and the compiler as a service mindset and so forth. But how much does it affect how you do tooling today? Like, you now have those analyzers. You have the ability for C# to analyze itself a lot. Like, how much does that shape both the frameworks and the tools?
A lot, actually. It's interesting that there was a running meme inside the team that I'm on, which is every time we say we'll just fix that with an analyzer, I usually retort and say, great, that means we'll never fix it.
Yeah.
And that's mostly just because we have to build the muscle to write the analyzers.
Right.
And analyzers are not a a solution to all problems. There are so
Yes.
many, as I mentioned before, there are things that we can express using language constructs. There are things that we can express using the type system and runtime features, which obviously are tied to language constructs, but they are separate and distinct concepts. And then there are things that we can express and enforce using framework constructs, or app level framework constructs, the things that we have there. And sometimes when we can't express something in a language construct, we might be able to enforce it with an analyzer. So rather than saying you must implement this interface, we may say, well, we'll detect when you're doing something that we can't protect against with a language construct by creating an analyzer instead.
Right.
But we need to build up that muscle so that the team that builds ASP.NET Core builds the analyzers for ASP.NET Core. And that's something we've been working on a lot at the moment.
And are those things just going to run automatically, or do we actually have to convince the users to use those analyzers?
Well, that really speaks to Michaela's point about on-ramps and
Yes.
off-ramps, about how do we get those people to use those things.
Well, and some people look at the new editor and the way that code gets decorated with all of these tools and say that's noise, not information. I mean, I know the difference between a red squiggle and a blue squiggle, but it really gets into the various pop-ups, arrows, like when do you know you need to do or there's an opportunity for a refactoring. This falls pretty clearly to Michaela. It's a tooling thing.
Yeah. Well, that's a very valid perspective. A lot of the things that analyzers suggest that you might do are a matter of personal choice or aesthetics and so on. So it is important that we have tools to suppress them or to change the severity of particular analyzers in your editor config file. So that is something that tooling does give you. But yeah, it can be very overwhelming if you open up a file and it's just all squiggles.
All we know for sure is all your
and
code
there's
is
also
wrong.
yeah.
That's what we know.
Yeah, and there's also big differences between the different kinds of experience as well. Like if you're writing code and you see a squiggle in the code you're writing, like that's very different than you do a build and you have like 10,000 analyzer warnings because it's run over your entire code base. And the first, like, the squiggles maybe don't seem quite so intrusive because they're more maybe approachable. But when you have the bigger, like we do have code cleanup tools that help you fix whole swathes of analyzers, but that can be fairly difficult to review. So there's always trade-offs, and yeah, everything's trade-offs.
Nothing comes for free. Otherwise, you would have done it automatically, right? I mean,
and even analyzers. Yeah, like there are limits on the analyzers we can build. Like there are some analyzers we would like to build, but we just can't because they're too expensive computationally that we just can't run them in the background, or there's only so many we can afford to run.
Yeah, I could see analyzer propagation becoming a huge issue, especially when the cop-out solution is just make it an analyzer.
Yeah, and then an extension of analyzers that we talk about, Michaela mentioned refactorings, which are generally manually invoked by the user, so they're not so bad. But we also have source generators, which is a fairly new thing, but they run while you're coding. They have to run while you're coding because they actually generate code in your app. And so at some point, performance becomes a consideration. We can't, and Michaela just hit it on the head. It's like being an architect and designing any of these features is about trade-offs. It's literally the number one principle. You are never going to be able to make everything perfect. You are always trading off some part of the developer experience, some performance, some aspect of how accurate what you're showing is and at what point in the development lifecycle you're seeing it, against all the other things. And so a lot of our job is arguing about what is the right trade-off to make this release.
Discussing
strongly.
Yes, with vigor.
With vigor, what the right trade-off is to make. And the equation changes from release to release. Sometimes we get 3 or 4 versions away from when we made a particular trade-off, and we decide that was wrong now, it's wrong for today, so we make the other one.
Wrong, or just we didn't have the information.
Things have changed.
Sure, yeah. And I immediately think in terms of execution performance when I deploy this app versus the development experience performance. Because a lot of those analyzers and so forth, they're running at my dev space as well. Like how much is that impacting my dev cycling?
Right, and the variance
that's
in dev
super.
workstation performance is huge.
Yes.
Sorry,
That's
Michaela.
super. Like we get so much feedback on performance of the developer experience because people get frustrated when they're writing code and things freeze up and they have to pause for a couple seconds, and there's the running joke about going and making a cup of coffee while your code's compiling, and hopefully that's not so much of an issue anymore. But if you invoke a refactoring and it takes 20 seconds, that's a real stall, and those kinds of paper cuts build up.
Yeah.
That's a great expression, a series of paper cuts.
I am worried that when we shift things from runtime to tooling time, it turns everyone into a compiler author. And I don't think everyone has let that sunk in yet. You're basically shifting time. So we think about using SourceGen to improve time at startup and runtime time for the actual app when it runs, but you're moving that time to build time. And I think that works well when you're doing 1 or 2 or 3 small things. When it's like 50, or every package decides to source generate everything because it's faster, then we're going to have performance issues at build time, which we have already, right? But so I think those are things to think about as we're trying to move to this new world of having people write code for libraries and ones that run at build time.
And historically, we've had this difference between debug builds and release builds, which don't maybe mean as much as they used to. But I think there are definitely opportunities for thinking of the different kinds of inner loops and outer loops and so on. Of when you're writing code, you want to optimize for build performance, and when you're building your code to deploy, you want to optimize for runtime performance, and that's always been the case with C++ compilers and the different optimization levels and so on. And maybe that's something we need to be thinking about again as well, now that we have source generators doing a whole lot of work that's really targeted at runtime performance, not developer time.
Yeah, I think it's very fair. We got just a few minutes left. There's been a sort of a gestalt set of questions in Twitter, so I'm going to paraphrase them around open source libraries, open source projects. And let me throw in add-ins and things on the tooling space as well. Do you get into a conversation about should we just be using these open source libraries, or is this a language feature we should add, or there's an add-in that people seem to like, should this be incorporated into the tool? What does that conversation even look like for you?
Trade-offs again.
Yeah.
we've been through, and we continue to go through a bit of a journey on that. Folks who have been with us through .NET Core 1 to about 3 may, if you were using ASP.NET Core apps, you kind of saw the result of a lot of that journey as well. We made
JSON.NET.
JSON.NET was one, but also the introduction of shared frameworks in .NET Core 3 forced us to make some decisions about where those lines exist and how we draw them. And so today, if you create an ASP.NET Core app, some of our templates include open source libraries as NuGet packages, as references.
Right.
We don't have other parties' open source in our shared frameworks. Currently, we used to, and we got rid of that to try and draw a line between the two. But like a lot of, as we said before, this is a trade-off between what different cohorts, I think Fowler said before, want in our community, and we continue to have that discussion.
Yeah, I think it's a constant balancing act. And also what the customer wants, whether those features make sense or not. I think about the ecosystem in Studio, Michaela, and just all of the tooling that exists there already, versus what do you add? Do you have to have that conversation about is this stepping on an existing ecosystem member?
Yes, that's a very important conversation to have. I think historically there has been a tendency of customers to use the Microsoft blessed thing, and maybe some people don't want to use something unless there is such a thing, but we don't want to be suppressing the ecosystem, right? We want to have a super vibrant ecosystem, people building things and other people using those things and us using those things. So part of this is about expectations and historical baggage. Part of it's that we have these trade-offs of when we bring something into the default templates, it has certain expectations, and those are something that we can't necessarily put onto a third-party library. It's complicated. It's a lot of very difficult discussions.
Yeah, and not always easy choices, right? If it was simple, everybody would be doing it. And I appreciate all the work folks do around there. One last question here. This is from Joe Cuerva, who says, what is the state of green threads support in Dot? David's all excited.
Yeah.
So we built a working group This is kind of built up over years of seeing people like doing blocking on thread pool threads and the slow thread pool growth, and we made changes to that in .NET 6 and 7 to make it better. But the fundamental issue will always remain. The moment you have async and non-async methods, and the day somebody ever wants to do an async thing and a sync thing, there's issues. So we have this experiment going on where the runtime team is trying to implement a new primitive in the runtime called a green thread. The idea is that you can call any blocking API, and it will magically yield this runtime-based thread. So it's basically like threads, but in the runtime itself, not in the operating system. And it actually works. And I have a branch. It's actually all open source. For runtime, it's on the runtime lab repository, and then for ASP.NET Core, it's a branch. And it works. It's really slow right now. It's really slow. Don't try it. But it isn't crashing. So
that's
happy
cool.
about it.
That's awesome. Damien, Michaela, David, thank you so much for this conversation. It's so much fun. I hope folks really appreciate it. And hey, if you get a sec, fill in that survey. The links are available there. Let us know if this is the kind of conversation you want to have. And with that, I'm going to pass this over to Dan Roth, who's talking a little bit about .NET's love of WebAssembly and .NET 7.
Hey everyone, I'm Daniel Roth. I'm the product manager on the ASP.NET team for Blazor. And in this session, we're going to talk about all the improvements to WebAssembly support in .NET 7. .NET loves WebAssembly. Now, WebAssembly has enabled a new era of modern web development by providing a standard binary-based instruction language for the web. WebAssembly made it possible to use virtually any development platform in a browser to build web applications. Over 5 years ago, the .NET team began on a journey to see if we could run .NET and C# code in any browser on WebAssembly to enable web development full stack with .NET. Now, building a .NET runtime for WebAssembly is a difficult challenge. There are many technical challenges. The runtime needs to provide API compatibility with the .NET Platform APIs within the constrained browser environment. You also need to provide access to those browser-specific APIs and existing JavaScript libraries. At the same time, the download size of the app needs to stay small so that the app loads fast. You need to have good runtime execution performance, as well as tooling for debugging and profiling and logging and tracing and all these things. Fortunately, the .NET runtime team, together with the .NET community, was up to the challenge, and .NET support for WebAssembly is now a supported part of the .NET platform, and has been for several years now. This enabled support for Blazor, our client-side web UI framework based on components that is part of ASP.NET Core. By supporting .NET execution on WebAssembly and web browsers, .NET is able to provide a complete full-stack web development experience. You can build your front end and your back end using the same languages, frameworks, and tools, which reduces costs and reduces complexity. Now in .NET 7, we've made a bunch of improvements for running .NET on WebAssembly. We now have enhanced WebAssembly debugging support, improvements to hot reload. We have expanded the web crypto support on WebAssembly. We're also using the latest WebAssembly features like WebAssembly fixed width SIMD and WebAssembly exception handling to improve performance. We have a new improved JavaScript interrupt model that's specific to WebAssembly and optimized for WebAssembly. And we even have a preview of multi-threading support for WebAssembly that you can try out. Let's take a look at each of these areas. Now, debugging .NET code on WebAssembly is a tricky challenge. We don't actually use the normal .NET debugger to do this. Instead, we connect to your app, to the browser, using the JavaScript debugging protocol, and then we tunnel .NET debugging capabilities through that channel. This has the benefit of enabling you to both debug .NET code and JavaScript code at the same time, but it does make it difficult to provide a full fidelity .NET debugging experience. In .NET 7, we've made a lot of improvements to the .NET WebAssembly debugging support to improve the fidelity of that experience. We now have support for the Just My Code setting. You can inspect multi-dimensional arrays using the debugger. The call stack window will now correctly show the name of your async methods. We correctly handle the new keyword on derived members. We added support for many of the debugging attributes that are in the system.diagnostics namespace, and we just made a bunch of general reliability improvements. Let's go take a look. Let's look at the debugging improvements for WebAssembly in .NET 7. OK, so here I have a default Blazor WebAssembly app that I've got running in Visual Studio. I've already started it up, and I've got it running in the debugger. I've got the counter up, and I've set a breakpoint in the counter component in the increment count method. When I click the button, we hit our breakpoint, and there we just shown we are debugging .NET code running on WebAssembly in a browser from Visual Studio. That's pretty cool. Now down below, we can see the state of everything that's in our component. And it's nice and clean. Now, if I go into the Visual Studio settings and I turn off the Just My Code setting, let's turn off Just My Code. Now we see like all of the internal implementation details of Blazor and ASP.NET Core, and that can be very useful. In .NET 6, this was the only view that you could get. You would get all these additional details. If you ever wanted to just focus, though, on just your code, there wasn't a way to do that, but now there is. You can turn on Just My Code, and the Blazor WebAssembly debugger will now honor that. So that's really nice. Let's go ahead and let this execution continue. Now what I'm going to do is I'm going to add a little bit of code to my counter component. I'm just going to add a random variable here, an array. And this will be integer array, a multi-dimensional integer. I need a new. And then we'll just add some random data in here just to show what we can do with this. All right, so there's that. And I'm going to go ahead and hot reload that into my Blazor WebAssembly app. And that should work. All right, great. We've got the check mark that says that hot reloaded successfully. Let's go ahead and click the button again so we hit our breakpoint. Now below, notice that we can see our array2D variable, and we're able to now inspect multi-dimensional arrays with the Blazor WebAssembly debugger. That's new in .NET 7 as well. OK, let's continue execution there. The last thing I want to show is in the fetch data component. This is this component that pulls down some JSON data from the server and dynamically generates a table of weather forecast data. It has this onInitialized async component lifecycle method. It's an async method. If we set a breakpoint right here, and then we try to browse to the fetch data page, we hit our breakpoint. And then if we look at the call stack window, notice that we see the actual name of our async method. I think in .NET 6, this would print out like, move next for like every async method, which was pretty bad. Now you get a much higher fidelity .NET debugging experience for your WebAssembly apps. So that's just some of the improvements. .NET WebAssembly debugging just continues to get better, and we're working on continuing to improve it in future releases. All right, let's go back. And let's talk about hot reload. All right, so in .NET 6, we introduced support for hot reload, which is the ability to apply code changes to your running app during development and have those changes apply immediately without having to rebuild the app and restart it. We have hot reload support for WebAssembly-based .NET applications, including Blazor WebAssembly apps. Admittedly, though, the hot reload support for Blazor WebAssembly was initially a bit limited. I think the only thing you could really do was method body replacement. Everything else, you had to actually restart the application. In .NET 7, we've made lots of improvements to hot reload support for .NET on WebAssembly. You can now apply the following types of changes. You can add new types. You can add nested classes. You can add static and instance methods to existing types. You can add static fields and static methods to existing types. You can add static lambdas to your existing methods. And you can add lambdas that capture the this to existing methods that already are capturing the this previously. So all these changes mean that you can stay in your development flow and see changes faster in your running .NET WebAssembly apps. Now, before I move on, it's worth calling out that we know there's still lots of changes that we need to support here to keep that flow really fast and fluid. This is an area of active investment, and you should expect even more improvements to hot reload coming in the upcoming releases. All right, web crypto. On WebAssembly, we've expanded the set of crypto algorithms that are now available when running on WebAssembly. This is the list of new algorithms. Now, I want to make sure it's clear that this doesn't mean that you can now safely store secrets in the browser. Just like with JavaScript-based apps, .NET code running in a browser on WebAssembly can be completely inspected by the user. Any secrets can be extracted from that code. So don't put any sensitive encryption keys or data into your browsers, but you can still use these new algorithms for a variety of purposes, including hashing and so on. What about tooling? The .NET SDK comes with specialized tooling for working with .NET WebAssembly applications. This tooling is available as optional .NET SDK workloads that you can install either from the command line or using Visual Studio. Now, for example, the .NET WebAssembly build tools provide support for WebAssembly ahead of time compilation, which gives you much better runtime performance, runtime relinking, so you can reduce the size of the .NET runtime WebAssembly bundle, and also native dependencies, where you can link in new capabilities into that WebAssembly bundle. You can install these tools for .NET 7 based projects by running .NET workload install WASM tools, or you can select the optional component in Visual Studio. Now, if you still need to work with .NET 6 based projects using the .NET 7 SDK, you'll need to install the new WASM tools .NET 6 workload. The .NET WebAssembly tools, build tools in .NET 7 are not compatible with .NET 6. So if you're a library author and you're using these tools and you still want to support .NET 6 and .NET 7, you're going to need to multi-target it. Okay. There's also the new .NET WebAssembly experimental tooling workload. This is a new workload that contains experimental project templates for running .NET code from JavaScript, as well as preview support for multi-threading. These features now are still in active development, so they're not ready for production use yet, and they're likely to change, but we hope that you'll try them out and that you'll share feedback with us. You can install the WebAssembly experimental tools by running .NET workload install WASM experimental. Now, we introduced WebAssembly ahead of time compilation in .NET 6 to improve the runtime performance of .NET apps running on WebAssembly. In .NET 7, ahead of time compilation produces code that is much faster thanks to support for some new WebAssembly features. WebAssembly exception handling and WebAssembly fixed with SIMD, or single instruction multiple data instructions. You can enable these features using the WASM enable exception handling and WASM enable SIMD MS build properties. And if you're specifically interested in SIMD, it's worth noting that it's not supported in Safari just yet. The WebAssembly feature is standardized, but Safari hasn't quite got the implementation done yet. Hopefully, Safari will get that addressed soon. We also have a new improved JavaScript interop model for WebAssembly apps in .NET 7. This new model is strongly typed and highly optimized for efficient execution on WebAssembly. In Blazor apps, this new model replaces the existing IJS unmarshaled runtime interface, which is now obsolete. Now, for general purpose JavaScript interop, you're still going to want to use the IJS runtime interface, which will work across all Blazor hosting models. Like if you want to write some JavaScript interop code that works in Blazor Server, Blazor WebAssembly, and Blazor Hybrid, you should continue to use IJS runtime, because those aren't WebAssembly specific. But this new JavaScript interop model for WebAssembly, that is great when you only know you're only going to be running on WebAssembly and you care about getting optimized WebAssembly-based execution. Now, to use this mechanism with existing JavaScript-based apps, you can import the .NET.js JavaScript module into your JavaScript code, it's now a proper ES6 module in .NET 7. You can then use the JS import attribute on your .NET methods to import JavaScript functions so they can be called from .NET. You can then also use the new JS export attribute on .NET methods that you want to make available to be called from JavaScript. Now, this model provides a rich attribute-based programming model for controlling how marshalling is done across the .NET and JavaScript interop boundary, and it also supports sync and async methods. It supports promises and tasks, proxying objects, as well as marshalling callbacks. Now in Blazor, if you want to use this new JavaScript interop model, what you need to do is you use the jshost.invokeAsync method to import JavaScript modules into your .NET code. From JavaScript, you can use the new get.NET runtime function to access the .NET runtime that was set up by Blazor so that you can make JavaScript interop calls back into .NET code. Well, let me show you what I mean. All right, let's go back to Visual Studio. OK, so in Visual Studio, in order to show this feature, I'm going to use the new experimental .NET JavaScript, .NET WebAssembly project templates. To show that I've got those installed, we can just run .NET workload list. And there it is. You see I have the WASM experimental workload already installed. And that will give me these new templates. These templates are experimental, but the features that they use are not. They are supported as part of .NET 7. All right, so let's do File New Project. Here are those two new templates. The first one is a WebAssembly browser app. This is a project that will set up running .NET from JavaScript within a browser on WebAssembly. There's also this WebAssembly console app. This is a project that will run .NET from JavaScript in a console app using Node.js. All right, we're going to use the browser-based one for this demo. And let's call this WASM browser app. Looks good. And we'll use .NET 7. I don't think we need to save that. OK, now this project is not using Blazor. This is just using the raw .NET runtime capability of running .NET on WebAssembly. In a sense, we're kind of peeking under the hood of what Blazor does in order to be able to run .NET code in a browser. Let's see how we do that. So if we start in index.html, we can see that all that's doing is importing this main.js module, which is defined in the application. In main.js, we're importing .NET.js. That's the runtime API for starting up .NET from JavaScript on WebAssembly. And then from .NET, we're grabbing a couple functions: the set module imports, get assembly exports, and get config. What do we use those for? Well, set module imports allows you to create named modules, sets of JavaScript functions that you want to make available to be called from .NET and C#. OK, so in this case, we just have one. And we want to be able to get the current browser address location by calling window.location.href. Now in .NET code, the way you do this is you have a class, a partial class, and then you can attribute a static method with JS import. You reference the name of the module that you set up previously. In this case, it's the name of the file. It doesn't have to be that. It can be any string. And then the specific function that you want to bind to. So we're binding this get href C# method to this JavaScript method in JavaScript land. OK, let's go back to main.js. So we've set that up. Well, we can call getConfig to get details about the .NET application, like the main assembly name. And then we can use getAssembly exports to get all of the .NET methods that have been exported so they can be called from JavaScript, so the other way around. Here we're using those exports to call myClass.greeting. If we go back to program.cs, we can see that myClass.greeting has the JS export attribute on it, and it's just returning a string. It's actually calling getHref, so it's calling back into JavaScript to get the browser location, concatenating that into a string, and then returning that string back to JavaScript. And it's calling console write line in the process. All right, so that's what this does. And so we get that string back in JavaScript, and then this is just logging it to the console. And it's also putting it into the HTML DOM. And there's no UI framework here. This isn't Blazor. There's no component model. So if you want to interact with the DOM in this world, then you're just using JavaScript interop to deal with the DOM. This is all the stuff that Blazor handles for you. And then we call .NET Run to call program main. In this case, we're using top-level statements. So the only piece of code in our program main function is this console.write line. So let's run this. And when this comes up in the browser, it's it's pretty plain. It's not a UI framework here. We're mostly just demonstrating how we can call .NET functionality from a browser. So there. So here's our our string that we got from that greetings method, and it's got the correct browser location. If we go into the browser dev tools and look at the console, we can see all those console logs being written. So and then there's hello browser also from program main. OK, so that's cool. This is something you can use now to run .NET code from any JavaScript-based code using WebAssembly. Now, how do we use this from a Blazor application? So I'm going to switch out of this project And I'll show you an example of using this new JavaScript interop model from Blazor. So in this application, what we have, this is going to do hand pose tracking using a JavaScript library. So it uses JavaScript interop in order to do that. The library is MediaPipe, and it does hand pose tracking. So it's going to set up my, hopefully my webcam. But there I am. OK, so if I put up my hands, you can see it knows where my hands are. And then down below, using Blazor, we're displaying some information about which hands are visible and where they're at on the screen. Pretty neat. All right, so how are we doing that from Blazor? Well, if we look at index.razor, we just have this one component, detect hands. We can go to definition on that to see where that's defined. That's in this other Razor class library that we're referencing. And we're setting up the video feed and a canvas to overlay the hand locations. And then we've got some rendering logic that's going to display where the hands are at. And that's all based off of this detection result property, which is defined on the component. Okay, so how is that getting populated? Well, that's all being done using JavaScript interop. Let's go to the code behind for this component. So in the Csharp file, so we have uninitialized async for the component. We're checking that we're actually running in a browser, because remember, this JavaScript interop model only works when you're running on WebAssembly. This is not like the other Blazor model where it works with all the hosting models. So this wouldn't work from Blazor server. Here we can call jshost.import async to import a JavaScript module. This is the one that's associated with my component, just sitting beside it in the file system. And we give the set of exported JavaScript functions from that JavaScript module a name that we can then reference later. Okay? And then we call onInit on this interop class, and that's where we're setting up all of the methods for that to handle JavaScript interop. OnInit, here we have the JS import that's referencing the module name that we imported using JSHost. And this is the JavaScript function that we want to call. We want to call this onInit function. And here we can see some of that attribute-based programming model for controlling how types are marshaled across the boundary. It's using a new C# 11 feature. I don't know if you noticed, generic attributes. That's pretty cool. All right, so let's go look at the JavaScript code. So where is onInit? Here it is. So onInit gets like a reference to the component instance. And then it's calling get.NET to get the actual .NET runtime instance that Blazor had set up. 0 means the first one. There's only one. It's the only runtime that you ever need. And then it calls getAssembly exports to get all the exported .NET methods so that they can be called from JavaScript. And we just have one of those. I think it's this onResults method that we're using with JS export. Okay, and then somewhere in onInit, we're setting up this onResults callback. And then below in onResults, whenever we get results from MediaPipe with the hand post data, way at the bottom, it actually uses that detect hands export to call back the onResults method in C#. So that's how we're getting the results back from JavaScript. So that's how this is working. It's pretty cool. Thank you, Pavel, by the way, for setting up that demo for me. What I think is really great about this is showing how you can take .NET code and use it from any JavaScript-based application. It could be Angular app or a React app. It doesn't have to include Blazor in the component model. You can reuse your .NET code anywhere that you can run JavaScript. All right, let's go ahead and shut that down. And let's go back here. Now, the last thing I want to show is multi-threading support. Now, browsers are normally single-threaded. You only have one thread. That means if you do anything that blocks the one UI thread, then your app effectively hangs. There's no other thread to continue execution. But you can emulate threads in a browser on WebAssembly using web workers and then share memory using shared array buffers. So we have a preview of doing this for .NET 7 that you can try out. To use it, you're going to need to install that WASM experimental workload and set WASM enable threads in your MS-Build project file. Now, this isn't supported at all in Blazor yet. That's something we're working on for the next version of .NET. So in order to try out this feature, you're going to have to use these experimental .NET WebAssembly project templates. Let's take a look real quick. OK, so if we go back to Visual Studio, let's open up this math project. Let me make sure I'm on the right branch. I am. OK, so this project, let me go ahead and run it. What we do is this app will solve systems of linear equations. And it's using a .NET library from the community to do that called MathNet. It's a great name. It reminds me of Square One TV from back in the day. And so it tries to solve these large matrix of variables, which takes a lot of compute. At the same time, it's also running a little animation in the corner of just displaying the letters of the alphabet. So in this version, where I'm not using threading, like if I look at the code and what this is doing, it's just calling solve. So it's just running a bunch of compute on the main thread. That will block the main thread. So if I click solve, watch the letters. So we're on N, and it just stopped moving. We wait, the computation completes, and then the letters resume. That's because we blocked the main thread with that solve. So that's a bad experience. We can make this better. Let me switch to a threaded version of this application. And I'm just going to rebuild to make sure that let me stop this. Stop the old app, and let's rebuild the solution. OK, and so in this version, we're now, instead of just calling solve, we're actually creating a thread. And we're doing the calculation off of the main thread, and that should allow the animation to continue. So let's see if that's now working. Hopefully I didn't mess up any caching by switching branches like that. OK, so we got the animations going. Let's click. Now watch the letters as I click solve. I'm still using the old one. Let me do. That's still the single-threaded version. Let's do this. Empty cache, refresh. I might have. OK, let's. OK, so now if I hopefully. And we solved our system of linear equations. So that's using threading. So we were able to unblock the main thread. So that's a preview of multi-threading, not ready for production use yet, but you can certainly give it a try. Now, all of these great new .NET WebAssembly capabilities enable a whole bunch of new powerful experiences on the web using .NET and C#. For example, our friends on in the Uno platform, they have an application framework for building multi-platform apps that run on a variety of platforms, including the web, using a WinUI-based programming model. They use the same .NET runtime that we use for Blazor. By moving to .NET 7, they were able to dramatically improve their performance. 20 to 50% better performance on their critical paths. They're seeing that exception handling is much faster thanks to that new WebAssembly exception handling support. They're using AOT and getting dramatic benefits from AOT. They're even trying out multi-threading to get smooth UI animations and transitions. You should definitely check out Jerome's talk later today, where he's going to walk you through how they're using .NET 7 to make the Uno platform great. You can learn more about Uno at platform.uno. All right, and with that, .NET 7, lots of great improvements for WebAssembly. I hope you enjoyed learning about them. Be sure to give them a try. Share with us your experiences. Right after this session, Steve Sanderson is going to show using these features to build a real-world Blazor WebAssembly app, so stay tuned for that. And with that, I think we'll now see if there are any questions.
Nice demo save, Dan. You're the best. Let's grab a couple of good questions there. This is from Black Love, who said, how does WASM debugging work with different browsers? Are all browsers made equal in the WASM world?
Well, from a WebAssembly standard perspective, yes. Like all modern browsers support WebAssembly. From a JavaScript debugging perspective, they are different. Now, Chrome and Edge, those are all based off of the Chromium engine, so they have the same JavaScript debugging protocol. So we support debugging Blazor WebAssembly apps with those Chromium-based browsers. We do have work in progress to also support Firefox. I believe it's not quite done yet, but it's getting pretty close. So we're trying to support as many of the JavaScript debugging protocols as we can. But yeah, they're not all the same. Currently, you do need to use a Chromium-based browser to get that debugging to work.
It makes me wonder if we're not going to get to a place where there's going to be a debugging standard, just like many of the other standards for browsers as well.
That would be nice. That would make things more convenient, certainly.
I bet. But it's certainly easier for you, but it'd be better for all of us, too. We could actually have an agreement on how all of those different things work. I'm going to grab another question here. This one's from Farul, who says, what's the state of WASI for .NET?
Good question. OK, so WASI is a system interface for when you're running on WebAssembly. This is more for when you're running WebAssembly on a server. Like here we were talking about running WebAssembly mostly in a browser, but there are a bunch of folks that are interested in, could you use WebAssembly for server workloads? There's a bunch of reasons why that could be beneficial. WebAssembly has a natural isolation model. So if you're trying to run hostile code in a server environment, you could get really great density with a WebAssembly-based server execution. WASI standardizes an interface with that WebAssembly code to the underlying host. Like if you want to access the file system or network or other system resources, it provides you a way to do that. We are definitely monitoring the WASI WebAssembly efforts. We have prototypes and explorations where we have WASI support for .NET. No concrete plans to announce yet, but we're definitely looking at it and investigating it, and we're interested to hear about your scenarios.
Excellent. One more question. See if we can fit this in. It's from Dimitri, who says, for a question for Dan, can I make my Visual Studio stop, or I guess break, on an exception thrown by WebAssembly code without actually having to put in the breakpoint?
Yeah, so when you're running in a browser, the normal pattern, like if you're in JavaScript, is actually the exceptions don't, like I know in a native desktop app, for example, you expect that the exception will like tear down the process. Like you'll throw an exception, it doesn't get caught, and the process goes down. When you're running in a browser, that's not usually what's done. And so in Blazor WebAssembly, we follow that pattern. We kind of catch the exception at the outermost layer. That's why when you're debugging and you throw an uncaught exception, it doesn't actually like break in the debugger because it doesn't see it yet. So that's just kind of a characteristic of running on the web. You can, of course, enable like first chance exceptions, and that should work.
It's a resume next by default world in the web, actually.
That's right.
So I get that's part of the challenge. Although it's interesting to think in terms of at some point in that execution, you might have more than one error that you could now drop back into Studio and say, okay, well, what have we got? What complained? And see where the different execution threads occurred that generated those errors.
Yeah, maybe there's an opportunity to make the tooling better there. That's an interesting thought. We should look into it more.
Yeah, and it gets back to my original whole stretch on the idea that debugging could be a set of standards, because now we could have a collection of objects for the different errors. Like that to me would be fascinating. We could make better quality web pages.
Yeah.
You're all in? We're going to write all those good things for it?
Oh, are we going to do that?
I'm excited you're committed to doing it,
We hope that
Dan.
those browsers get on that right away and start standardizing those things. We do benefit from a lot of great work from the standards community that let us build standards-based web apps. Everything we're doing with .NET and WebAssembly and Blazor, it's all based on the open web. There's nothing specific to .NET here. We're just using pure open web standards. As those standards progress, we're able to make .NET on the web even better.
Awesome. Dan, thanks so much for that. And let me push over to Steve Sanderson, who's going to dig into some nitty-gritty around Blazor and WebAssembly.
All right. Well, thank you very much, Richard. And hello, everyone, and welcome to this session where we are going to be doing some application building with Blazor. Now, I'm Steve Sanderson. I work at Microsoft. I'm on the .NET team. And the idea with this session is to get a little bit more advanced. So we're going to be digging quite deep into a lot of code in this session. And it's mainly intended for people who have some existing background with Blazor. Now, if you've never used Blazor before, there's going to be a lot of code and APIs that you might not recognize. So I'm not promising this is the best starting point for you. Hopefully you can follow along. But those people who have used Blazor before should have a good time. Now, we are going to use a mixture of .NET 7 new APIs and some of the existing APIs that you already know and love to build an audio browser application. Now, the idea with picking this audio browser scenario, it's really just to get you thinking about a different type of application, because I know we've all seen applications that read and write databases. Let's think about something a little bit different. And it doesn't really have to be audio. It could be any type of file. We're just using audio as an example. So consider this. Your user has got some files on their hard drive. Could be audio files, could be some other binary files. Maybe it's log files or some binary data generated by industrial machinery or something, who knows. And you are a developer of a web application and you want some way of working with these files. So you need to get that file data into your web UI so that you can read the data and maybe save changes to it. And you don't want to force the user to go through a process of uploading those files somewhere. That's quite inconvenient. You just want them to work with the file data right there on their hard drive. So that's what we're going to do with our Blazor application in this talk. So let's see how we're going to attack this challenge. I'm going to do this in 4 phases as we build up different parts of the application. And I will have to move quite quickly, so I won't show you every line of code, but I have put the code on GitHub and I'll give you a link to the full thing afterwards. So let's get started with trying to access files on the user's hard drive. So I've got a starting point here. Here's an audio browser application, which is Blazor WebAssembly. And I've got this also a Razor class library called Media Files API, where we're going to put some of the underlying API stuff in case we want to reuse it with other projects. Now, if I run that with a Control F5, you can see it's not really doing very much so far, it just prints hello world. And that is because I have created this using the new empty project template from .NET 7. So we only have one page in this application called index, and it's just going to say hello world. But I've also created this dependency injection service called media files, where we're going to add access to the user's file system. And that's coming from this Razor class library over here. And you can see it doesn't have much logic in it yet, but it does know how to load this JavaScript module. So why would we be doing that? Well, the APIs that we're going to use to access the user's file system come from the browser. It's a fairly recent spec, it's only a couple of years old, called File System. And this gives us some APIs in JavaScript that can access files. So we're going to do that here. And my real purpose is to show you some hints and tips for making your JavaScript interop code really nicely organized. So you can see we know how to load this media files JS file here. And that is coming from here. And that doesn't have very much in it yet. We're going to need to fill that out. And if you were looking closely, you might have been wondering, what is this JS module thing? Is that a framework feature? Well, it's actually not, although personally I think it probably should be, and I might start to argue that we should put this in .NET 8. But at the moment, it's just a general pattern. Don't worry about reading all this code. Obviously, there's too much. This is just a generalized system for being able to load a certain JavaScript module, for knowing how to release it when you're finished, and most importantly, for being able to make invocations into it. So it knows how to wait for the module to be loaded, and then when it is loaded, it can pass on an invocation. So don't worry about understanding that in detail, because it's a bit advanced. We are simply going to use it. So let's start by adding the ability to request access to the user's file system. And we'll do that using this show directory picker API. And we're going to return the name of the directory they've picked and an actual JavaScript object that represents it, so we can get the list of files later. Now, we don't want to work with JavaScript directly. We want to wrap that in a nice, strongly C-typed C# API. So here we go. I've got a method called show directory picker, which will return a JS directory. Now that doesn't exist yet, so we better define it. And you can see it needs to have a name and an instance on it. And we can do that really easily with a C# record type. And it's going to have name and instance. And I've also marked it as disposable because JS object references themselves are disposable. So we'll want to release that when we're finished. All right, so now we've done that and we've followed this simple pattern, we can use this inside our UI. So back in my UI, I am going to add a button. And when you click that button, we are going to try and open a directory. And we're going to have to fill in an implementation for that. And the implementation is going to ask the user to pick a directory using our DI service. And then we'll get the name and we'll display it on the screen. So let's see if this all works. When this reloads, we should hopefully see the button that we've just added there. That's a bit big. And when I click it, it should bring up the directory picker and I can pick a directory. I'm going to pick this particular folder that's got some audio files in it. And when I do that, the browser says, hey, user, do you want to let this web application access this directory on your hard drive? And we'll say yes. And then we'll get the name of the directory back in our .NET code. So that's a good start. But we don't actually just want to display the name of the directory. We want to show the actual files that are in it. So to do that, I'm going to follow the same pattern that I followed before by adding a bit of JavaScript code to wrap a certain JavaScript API. In this case, I'm adding a function called getFiles, and that's going to loop through all the entries in this directory. And for each one, it will return something with a name, a size, and a last modified date. And then I'll continue following my pattern to add a C# wrapper around it. So it's really easy to use. Right, so this is my getFiles async method, which is going to take a directory and return an array of JS files. And then we'll define JS file. And if you remember, it needs to have a name, a size, and a last modified date. So we'll just add a C# record that looks like that. Okay, then we can use that in our UI again. So I'm going to slightly amend this code now so that as well as doing what it did before, it now also tries to get the files from the directory. And then instead of displaying the name, I'm going to use a razor for each loop to print out the name and size of each entry in there. So let's just check that that's all going to work for us. I'm going to open my directory again. And this time when I do so, you'll see that it displays the names of the files and their sizes. All right, so that is pretty good. Now, what else can we do? Well, I want to improve a few aspects of this, and I don't have time to show you every step of the way. So I'm going to cheat a bit here by jumping forwards to a predefined state in my code here where I've added a little bit more functionality. I'll show you what it is. So let me just restart this and I'll show you what I've changed. Okay, so I've added an icon into this button. I've also added the ability when we pick a directory to show you the name of the directory and the number of files in it. And perhaps most importantly, I've added a feature where it remembers which directory you opened. So if I hit the reload button, you'll see it immediately goes back to that same directory. And I don't have to keep clicking that file browser, which would get pretty annoying. The way that works is that I've got this oninitialized async lifecycle method. And when this component is initialized, we'll call back into the browser to say, hey, if you opened a directory before, can you open the same one again? And we'll get the files out of it. Okay, so that is pretty straightforward. But I still want to improve the appearance of it in at least one more way, which is to do with the way that it looks while it's loading. This is a WebAssembly application, so hopefully it will load quickly, but depending on your user's network connection, they might have to wait a second or 10 seconds, it depends on the network. And while it's loading, what does it do? Well, it displays loading in black and white like that. It doesn't look very attractive. I don't even think it looks very professional, to be honest. So I want to show some tips for how we can make this look a little bit better. And my first tip is try and make your loading screen look like the same structure and style as the page when it has loaded. So in this case, we've got this kind of gray bar across the top, and I want that gray bar to show up while it's loading. So what renders that gray bar? Well, it's having a menu with a span inside it. That's what my CSS rule is looking for to render that gray bar. So I'm going to go to where my loading indicator is here in index.html, and I'm going to put in a menu with a span inside it, just the same. And then I'm going to put my loading messages in there, and let's close that. It's a nice subtle loading bar, which I think is better than having a big one in the middle of the screen, especially when it just sort of whips past really quickly in most cases. All right, good. So we've got access to local files. Let's move on a little bit by improving the functionality of the UI. We'll set up an actual grid with some sorting and searching because maybe the user needs to work with a larger amount of data than this. And this brings us to one of the .NET 7 preview features, which is a grid baked into the framework called Quick Grid. This is a preview level for .NET 7, so we'd love your feedback about that. And it's pretty easy to use. All we have to do is go to somewhere where we were doing a for each loop before. We'll get rid of that, and I'm going to drop in quick grid instead. So quick grid is complaining at me initially. The reason it's complaining and why we've got this red squiggle here is because it wants a queryable of t to display so that it can dynamically change pages and sort order and things. And I haven't given it that. I've just given it an array, and it won't be happy with that. So I'm going to change it to a queryable of JS file like that, just to show we're not limited to doing querying over database content. We can also do it on in-memory data as well. So I can turn an arbitrary array into a queryable using this asQueryable extension method like that. Okay, and now our grid is going to be happy that it can work with that data. So when I save that, it should compile properly this time. And if I switch back, my UI becomes blank because, well, my grid doesn't have any columns yet. Let's put some columns in there, shall we? We'll start quite simply with these 3 columns for name, size, and last modified, and I'll mark them as sortable. And hopefully that's all we have to do to get an initial UI that starts to look quite nice. And we've got multiple columns, we've got sorting, that's all good. But some aspects of the way it appears don't look so great. I really don't like the way this size has been formatted. Third-party library called Pretty Size, and that is going to render the size in a more recognizable format. So now you can see it displays a number of megabytes or kilobytes, and that is a lot better. Okay, cool. Right, so remember I also said I wanted to have a search feature, and that's quite important because maybe the user doesn't just have 4 files, maybe they've got a lot more. So in this directory over here, I've got 1,200 files. It's quite a lot. You can't really expect the user to manually search through this list. You'd want to have a search feature. This, by the way, is a load of samples of humans speaking, which comes from the Mozilla Common Voice dataset, which is a really nice one. So thanks to Mozilla for that. And to add searching, I'm not going to go through this step by step. I did do that in a talk yesterday, so you can go and see it if you want to. But I'm just going to show you the finished code for doing searching. It's not too difficult, but we've got limited time and I want to show you more stuff. So here's what we've got now. You see we've got this little search icon, and when I click on that, a box shows up and I can start typing stuff. And on every keystroke, it's updating to produce the search results. And of course, I can still do things like sorting within that. Okay, so how does that work? Well, what happens is I've got a field to keep track of what the user is searching for here, called search name. I've got a text box, which is bound to that field. And I'm using a new .NET 7 binding feature called bind after to say each time this binding updates, we want to update the filter. And what I'm doing is I'm simply adding a where clause onto my queryable there. So that's all it takes to do that. Pretty straightforward. All right, good. Let's move on. Let's think about rendering some previews of the audio data. I want to render actual graphical waveforms, but it's going to take us a few steps to get to that. Let's start moving in that direction. Firstly, where is this preview going to appear? Well, I'm going to add a new template column into my grid here with a title of preview. And I could start putting all my UI logic in here, but it could get a bit complicated. So let's factor out a separate component, and I'm going to call it audio preview like that. All right, now I haven't defined that just yet. So the code editor will offer me the option to create a component from this unknown tag. So I'll click on that and you'll see that's added a file for me now, which is initially blank. And I'm going to drop in a bit of initial content. So my initial content here says the audio preview will have a parameter called file, which will be an actual JS file object. And this is going to be required. And we'll add some real logic here in a minute, but for now, it just displays to do and the name of the file to check that we've wired it up. And if I go back here, you'll see that the editor is complaining at me saying, you're supposed to pass a file and you haven't done that, so I'll do it. And what we'll pass is whatever file is the current grid row, and that's called context in this case. So with all that in place, if I come back here now, you'll see it's now rendering this preview component, which says to do, and then the name of the file that we should render a preview for. Okay, so how do we render a waveform? Well, the first step is going to be getting the actual audio data out of the file. And that could be a bit tricky because we could have multiple different types of files. For example, back in this other folder over here, you can see I've got some MP3s and I've got some WAV files, and there could be other types of files as well. So how are we going to decode all these different types of files? Well, you could start using multiple different libraries to handle different file types. And I actually did start doing that when I first was preparing this, and it was working okay. But then I had a bit of a brainwave, which is we're running inside a browser here, and the browser already knows how to parse a wide range of audio files. So can't we just get the browser to do this for us? And the answer is yeah, it's actually quite straightforward. What we can do is we can use some APIs that are built into the browser like this. So I've added this in the background, sneakily. You didn't see me, but I did. And what this does is it goes through a slightly awkward process to get access to the raw bytes from the file. And once it's done that, it can decode the audio data from it. And we'll pass that efficiently back to .NET through binary interop. And then we can access that through our DI service in .NET. So let's do it, shall we? I'm going to drop in a bit of logic that says when this preview component is created, we'll decode the audio file. And just to get started with, we'll figure out how many bytes we get back when we've decoded it. And I'm just going to render that to the UI right now. So let's render this message. All right, let's check if this works and we're able to successfully decode files. And the answer is yes, we can. So in the case of something like a WAV file, you'll notice that the decoded size is pretty much the same size as the file on disk because it's not compressed. Whereas for an MP3, the decoded size is far bigger than the file on disk. So that makes sense because MP3s are very compressed. Okay, now we don't just want to get the decoded bytes from the file. We actually want to render a waveform from it. How will we do that? Well, we could start rendering it using something like Canvas APIs, or we could use Csharp or some other bitmap renderer like that. But there is potentially an even easier way to do it, which is using SVGs in the browser. Blazor has for a while had the ability to generate SVGs dynamically, and it's a really powerful and quite easy technique. To be honest, I think it's a bit underutilized, so I'm trying to market this idea a little bit because it's a very powerful and useful thing to do. So how could we generate an SVG of a waveform? Well, let's build up towards it. I'm going to give you an example of an SVG. Don't worry about understanding this weird goop right now. Let's just see what that renders. Okay, you'll see it renders 3 vertical lines. Well, why does it do that? Well, it's what this path says. So this first instruction here says, move to 10 across 0 down, and then draw a vertical line down from there. And then move again, draw another vertical line, move again, do another vertical line. So that's 3 vertical lines. So we can use that to render a waveform. We just have to generate a big string like this that encodes all the lines in the waveform. And I've written a little bit of C# to do that. It's a bit too much code to go through step by step, so don't worry about understanding it in great detail. I'm just going to show you, I'll just quickly sort of mention a few of the details about how it works. So we're receiving the raw byte data. We're reinterpreting it as a set of floats because that's what it actually is. Then I'm setting up a couple of string builders, one for the top half of the graph and one for the bottom half, because I want them to be in different colors. And then we're looping across the image horizontally. And for each column in the image, we're finding the highest and lowest audio sample in that part of the file, and then appending some SVG path instructions. Okay, so that's the whole thing. Don't worry about it if it wasn't completely clear, but we're going to use that now. So I'll add a waveform SVG field right here, and I'm going to populate it by saying the SVG equals generate waveform SVG from the data that we've decoded. And then finally, I can render that into my UI, just like this, with the top path and the bottom path in a slightly different color. So let's try that out, shall we? I'm going to restart my application, and now you'll see it actually does display real waveforms. So that's pretty good. Let's just check it works if I move to a different set of files as well to make sure everything's really happy. And it seems like it is working. Okay, great. So we are doing well. Right, the last thing to think about is performance. So we're probably feeling pretty good about ourselves as developers right now because we've got everything working, but does it really perform well? And I'm sorry to break it to you, but bad news, there are some scenarios where this is going to behave quite badly indeed, because we have been a little bit naive in some of our implementation decisions. So let me show you one of the ways that this is going to go wrong. Let's start with if you've got a big directory with lots of files in it. I'm going to reload this directory, and then I'm going to try and scroll down to the bottom really quickly. And my UI is really laggy. I don't know if you can see, but that gray box is following ages behind my mouse, and it's kind of all locked up and where are the waveforms? This does not seem to be working well at all. So what's going on? Well, eventually it shows up. But what's going on here is that we have very stupidly decided that we're going to when a directory is open, we'll load every single file in it into memory, and we'll decode every single file, and we'll render a waveform for every single file, no matter how many of them there are or how big they are. And that doesn't really make sense. We would ideally only load and generate previews for the things that are actually on the screen. And the good news is it's very easy to do that. We can go back to the grid, and we can tell it to enable virtualization. And that means that it will only render the stuff that's on the current screen. So we'll only instantiate audio previews for stuff that's on the screen. So we'll only load and render stuff that's on the screen. You get the idea, okay? So let's try this now and see if it's a little bit better with the large directory. So now when I scroll to another point, you'll see it immediately just generates the previews for whatever matches my current scroll position. So that is clearly far better. Okay, so again, we might think that we've finished now and we've solved all the problems, but there could still be another issue. And to illustrate that, I'm going to jump forwards in the implementation one last time to a place now where I've got the ability to track some timings of what's going on. So let me show you what I've just changed there. Let's get this going. All right, so firstly, I've added a play button. I don't know if you can hear it. You might not hear it, but it was playing out of my speakers just then. That's good. But I've also added this little timing information here where it says 4 milliseconds. And I've set it up so that every time I click this waveform, it will re-render it and measure how much time it took to do so. And you can see it takes, like 3, 4, 5 milliseconds or something to render. And you might think, okay, that's fine. That's fast enough, isn't it? But what if these files were much bigger and we had a lot more audio samples to walk through? So over here, I've got another directory now with some full-length songs. So these are multi-megabyte files. They've got many millions of audio samples in each file. Here's a whole song. Don't know if you can hear that, but there you go. And how long does it take to render these waveforms? Well, if I click this a few times, you can see it's taking in the realms of about 40-ish milliseconds. And again, you might think that's okay, but what if the files were bigger still? Or what if the user was working on a low-end mobile device, which had a much slower CPU? Maybe it would actually be quite laggy. So to make things faster still, the big technique that we've got for Blazor WebAssembly is ahead of time compilation. That's not new in 7. That was already part of the 6.0 release. But one of the great things in .NET 7 is that the runtime team added a lot more optimization for the way that the AOT code generation process works. So it can produce significantly faster code. I don't have exact numbers, but I've seen micro benchmarks that have been around 50% faster or even faster still than that. So I'm not promising anything specific for your app, but let's see what happens when we AOT compile this one. So I've actually already AOT compiled this and published it. And I'm going to start this up from a static file server here. This is the same application code that you just saw us work on there. And I'm going to open the same big files directory here. And we should see that runs rather a lot faster. So the same big file that was taking 40 milliseconds before is now taking in the realms of 2, 3, 4 milliseconds. So that is something between 15 or 20, well, 10 to 20 times faster than we had it running before. So that is a big improvement indeed. Okay, so we've done a lot of app building. We've made the performance good. We feel pretty happy. I just want to throw in one last bonus for you. Bearing in mind that this application is implemented in WebAssembly, running in the browser, and it's just working with files that are local on the user's hard drive, that means it's absolutely trivial to turn this into an offline capable PWA. Again, it's not a new feature, something that's been in Blazor since the beginning, but it works really nicely in this case. So let's just see that happening. So I've got this AOT compiled application. I'm going to click on the install button here. That's going to now pop up in its own separate window. I'll let Windows pin it to the taskbar. And that means that this user now has on their application taskbar the icon for this application. They can click that and it pops up in its own window separately from the browser, and they can now do all the same things that you saw us do before. And so effectively, they've got something that looks something that feels like a native desktop application. It works offline and it performs really well thanks to the AOT compilation for working with their local files. All right, so there we go. That's all we're going to have time for in this session today. If you want to get more information about this, you can get the code for the finished application from the GitHub repo that I've given you a link to at the bottom there. And if you want to learn more general stuff about Blazor in .NET 7 or all of ASP.NET Core in .NET 7, you can use the link at the top there, and that takes you to a blog post that's got tons of extra content. So there we go. I hope that's been useful. If you've got any questions, you can ask them right now, or you can contact me through Twitter, or you can contact the whole Blazor engineering team through our GitHub repo. But that's the end of me for now, and I'm going to hand back to Richard in the studio. Thank you.
Thanks, Steve. Awesome demo, as always. You always knock them dead, showing all the cool things. Hey, you're getting a great view of the studio here. You're realizing we have more than one set here in the location, as well as our remote sets as well, the different speakers in different locations. It's a hybrid world, not just for you, but for all of us as well. Got a few minutes here left to answer a couple of questions. I think we've got Steve away, so let me take one of these on. Kai asked the question, that's an awesome demo. Is this code open source? I'm curious about the Tailwind bits. And I think Steve pointed this out right at the end of his talk, that all the code is actually on GitHub. Not only Blazor itself, which has always been an open source project, but specifically the sample apps we were just seeing, they publish everything into that repository. So you can always learn from it and even contribute to it. That's part of the power of this way of developing. One more question up here, and this is from Mir, asking the question, can we call multiple APIs simultaneously in Blazor WASM? Now that's, I think what you're asking there, Mir, is really about multi-threading, and multi-threading is a feature we're going to look at in the perspective of .NET 8 and Blazor, so that's supposed to be next year, but there's already previews out, so if you want to experiment with it, and you will be using experimental bits, you can try that on today, so you absolutely have that choice. Blazor is amazingly young. It's hard to realize, and I had the good fortune to be there back in 2016 at the NDC in Oslo. Steve Sanderson did a talk kind of out of the blue, and remarkably, thinking about our days so far today, David Fowler was in the room when this happened. He showed it for the very first time, this idea that he could run C# inside of WebAssembly. Of course, at that time, the C# he was using was a very odd, old, open source project. So he kind of cobbled these bits together, kind of without any warning. We were able to watch this talk where he wrote some code that actually ran in WASM, and suddenly we were running C# on the browser. And I remember David Fowler looking like his head was going to explode. He was just holding on to it, wondering, like, is this really real? Of course, that then turned into this open source project. It was completely experimental for a number of years, largely as they figured out how are we going to make .NET live in WASM as a whole. Today we have this amazing ecosystem. It's kind of emerged, but it's only 6 years ago that we saw those very first bits that even looked like that. That's the fun of a .NET Conf and this whole open source movement around .NET, and I hope you're having a great time too. And I'd be remiss not to call out our awesome sponsors, the folks that help make this show possible, and they are running that secret decoder event so that you can actually win some of the swags. There's a ton of good prizes, so check out the links. Do the secret decoder test and be part of that. The draw is going to be tomorrow. There'll be lots of fun things to win there too. And hey, don't miss out on your Code Magazine subscription. If you're a viewer, you can be a subscriber too. Get some paper. Get back to the old magazine fun that Code Magazine is actually. I think we're just about done here. We got to hand off to our next topic, which is Playwright. I've got Debbie and Max waiting over on Teams. Let's send it to them and I'll talk to you later.
Thank you very much, Richard. So yes, we're going to test Blazor applications with Playwright. My name is Debbie O'Brien. I'm a senior program manager at Microsoft. I'm working on Playwright, advocating for Playwright, and I have with me
Max Schmidt, and I'm a senior software engineer in the Playwright core team. And today we are showing you how to test Blazor applications with Playwright for .NET.
And that's us running in Berlin because we get so much time to do sport because our tests run so fast. Am I right?
Absolutely.
Okay, so for those that don't actually know what Playwright is, Max, how would you define Playwright?
Now, Playwright is a very modern end-to-end testing framework to test modern web apps, and you can do it in any browser, any platform, any language you want. Like we are available in Node.js, we're available in Java and Python, and obviously where we are focusing today in .NET. And yeah, any browser. What does it mean, Debbie? It means like we are available in Chromium, in Firefox, and WebKit. So for Chromium, this means you can use us in Microsoft Edge, you can use us in Google Chrome, and any Chromium-based browser. So you can test Android applications, you can test WebView 2 applications, and you can test also Opera and so on. For WebKit, for example, yeah.
If you're on a Windows computer, you can test WebKit Safari, right?
Yes, WebKit Safari. So usually if you're a QA tester and you're usually on Windows, it's hard to test WebKit. It's hard because WebKit is only available inside Safari normally. But with us, you can either do manual testing in WebKit, but you can also do automated testing by writing Playwright scripts for end-to-end testing.
Excellent. And Playwright runs in full isolation. Now, how I define this is I write one test and then I write another test and nothing leaks in from one test to the other. How would you define isolation?
Good point. Isolation is like from other end-to-end testing solutions. Usually after each test or after each test file, you restart the browser, right? And restarting the browser takes a lot of time, usually between 1 and 3 seconds. And what Playwright does differently is we have this concept of browser context. A browser context is an in-memory browser profile, which is fully isolated from other browser contexts. And each of the browser contexts has pages underneath. So you can easily represent multi-role testing scenarios by using multiple browser contexts. For example, you can log in on one page with your admin account and on the other page with a user account, and then write an end-to-end test and test against these both roles at the same time.
Which is kind of really cool, and it kind of makes sure that there's no flaky tests, which means your tests are going to pass and you can have a great weekend, right?
Absolutely, absolutely. So none of these tests then depend on each other since every test gets a different browser context. And that's available in all 3 browsers.
Excellent. And one of the things I notice when I run my Playwright tests is that they are super fast, right? But how is it so fast? What's going on behind the scenes?
So good point. So why are we fast? We mostly explain it by saying this concept of auto-waiting. Playwright has auto-waiting by default. This means when you have, for example, you click on a button, Playwright not simply clicks and then fails if the element is not there. Playwright essentially performs a variety of different steps. So first, for example, we wait until the element is there. Then we make sure that the element is visible, that the element is stable, which means it's not running any animations or something like that. We make sure that the element is clickable in the end, and we also make sure that the button is enabled. And all these steps will perform until the timeout is reached, so you don't have to rely on time.sleep like compared to other solutions.
That's cool. Less work to do. Tests run parallel, run super fast. Everything is fantastic. And we also have very powerful tooling. Now, I'm going to share my favorite tooling, which is my favorite feature is CodeGen. Max, what do you think of CodeGen? Like, just look at this, right? Basically, with CodeGen, I can set up like my application here, right? I've got this to-do app, and I can literally start writing into that to-do. I'm going to write some tests, then I'm going to do the washing. And as I'm writing the test, you can see over here in the inspector window, my test is being created for me. I'm not writing any code. I'm literally clicking like what the user would do. And right before my eyes, that test is being created for me, and I can then copy it and put it into my editor. I mean, that is cool, Max. What do you think?
Definitely. So you don't have to worry about finding the right selectors. It will all automatically generate it for you.
It's amazing. I love it. It's my favorite. What's your favorite tool?
My favorite tool is playwright tracing. Let us show it to the users. So playwright tracing is a tool to essentially debug playwright tests which run anywhere. For example, inside the cloud, which means on your CI. Playwright tracing will, on the left side, list all the playwright steps which got performed, like a fill, a press, a click, or whatever. And it will show us a small timeline at the top. And the most powerful thing, it will not show only a video or a screenshot, it will show you a snapshot of the site. So you can use Chrome DevTools to take a look at the snapshot. You can take a look at the CSS and the DOM structure before, during, and after a certain action. And on the right side, you will have a lot of debug information available. So all the arguments you pass to the call, and you see console, network, and also the source. So it will all the way down to the C# code, like which line performed which step.
It's very cool. Like, we recommend running this on CI when the test fails, but I love actually running it in development when I'm developing because I just get to see what's going on. It's kind of cool.
Definitely.
So Max, let's talk about Playwright and .NET. What is the .NET experience like what's the Playwright experience like in .NET?
So you can use Playwright with .NET in, as of today, 3 ways. So you can either consume it as a library, so you can write your own scripts, you can write your own .NET run programs, you can use it anywhere, like in .NET 6, 5, or .NET 4.8, but you can also use it with our available MS Test and NUnit integrations. And MS Test, speaking of that, that's the integration where we are focusing on today, and we are writing a small test today.
Yes, I love seeing live demos. Let's do it. What are we going to test?
Let me share my screen at my terminal. So here we have a small terminal, and let's scaffold
Where do we start?
Let's scaffold a new MS Test project by saying like .NET new MS Test, and let's call this folder maybe playwright test .NETconf. And what this gives us is a new MS Test project inside a playwright test .NETconf directory. And we can open this folder once it's generated in our favorite editor, in our case, this one here, in our case, VS Code. So let's open it.
So hang on a second. We're working with .NET in VS Code. Can we do that?
Yes, absolutely. So there are extensions available for any language in VS Code and for C# as well.
Amazing.
So let me open it in full screen here. So as this project file got here generated and a small basic unit test and some global usings. The first step, what we want to do with this basic MS Test project is to install Playwright, right, Debbie?
Yeah, I mean, can't run the test if you don't have Playwright.
Yes. So let's install it. So it's essentially this. So this will install 2 things. It will first install Playwright, and it will also install the MS Test integration. And let's make sure that the project still builds. And then we can
does it install the browsers as well?
By default, not. So okay. Good point. Playwright is structured in a way that you need to install the library or like the stuff, how you consume it, and you need to install the browsers. The way how you install browsers is like in .NET that you have this bin directory, and there you have this powerful Playwright CLI. We will see it later. It's the way how you launch CodeGen and how you, for example, open WebKit on Windows, but it's also the way how you install the browsers. So we can do this here. Let's see, it's a bit hanging here. Let me open my new terminal. Maybe that helps. A lot of things are running on my machine.
Installing our browsers, right? And which browsers are we going to get installed by default? Does it install all of them?
So by default, it will install all the 3 browsers, which means like a Chromium, a Firefox, and a WebKit. I executed it here, so you see, and it was pretty fast, right? Because the browsers are already there. So this is a step you need to do on every CI run, or once you have installed it on your machine. So cool. Let's write our first test. Let's see. We have here our unit test. Let's jump straight over to the docs and grab here our example test, which we can run for this demo. Let's copy it in here and fix the usings a bit. and run this.
Okay, so this is a nice easy test where we're basically going through the documentation site, the main page. We're looking for the Get Started button. We're going to click that Get Started button, and it's going to go to the intro page. Simple as that.
Yes, and it's making sure that the title is correct and the URL is correct, right?
Yeah.
So we executed it here with a .NET test, and it said
already passed.
It said passed. Debbie, did you see a browser?
I didn't see anything, like literally, no, there's no browser.
Is it fake? Do you think it's fake?
I mean, I wouldn't trust it. Would you trust it? I mean, I know I write great code, but I don't trust that.
Definitely not. So let's try to make it headed. Headed is essentially the way how we launch it with a graphical user interface. By default, they are launched headless. So to do this, you can specify here this .NET setting by setting playwright.launchOptions.headless, and we set it to false. And then we should see a browser. Let's see.
Okay.
There is a browser. Very. This was quick, Debbie, right?
I mean, it was too fast, right? I have no idea what went on.
Yeah, let's make it a bit slower. So.
Oh my God, our tests are so fast that we're going to slow them down. Is that what you're saying?
Yes. Only to see that something is happening. So I set here the slow-mo to 1000, and this should run it again and delay every action by 1000 milliseconds.
Just to prove to me that the test works. I like it.
Yes.
So now it's going to go slow, obviously, which is what we want. And here we go. We've got our browser. We clicked and we went to that page. Perfect.
Yeah, still pretty fast. Anyways, cool. So you can run it in different browsers as well. You can, for example, here saying playwright.browser name. Should we run it in Firefox or in WebKit, Debbie?
Oh, let's do Firefox.
Firefox, okay. Let's say playwright.browser name Firefox and execute the same. And this will essentially spawn a Firefox instance.
Nice.
Here we go.
Look at that. You can see the difference in the browser. It was very fast, but I saw it.
Yeah. We can first come to a little debugging utility and show that to them by saying await page.pause async. What this does, it will pause the test execution. So you can debug it by using DevTools, by seeing the logs, seeing the playwright actions, and you can also step through them.
Which is kind of nice. So if you do have any errors, you can go through it step by step and figure out what's going on.
Yes.
Excellent. So this is going to launch up my browser. And from there, I'm going to see the browser, but I'm also going to see the inspector like the code gen, right?
Yes, you should see it. Let me, we're all up to date for restore.
And would this be considered your most favorite debugging way? Because there's a couple of ways, right? We've got page.pause, but we also have the PW debug. What's the best way to debug?
The best way to debug, it depends where you run it, right? If you run it remotely, then using playwright tracing. If you run it locally, using the built-in debugger. Let me remove it with Firefox. And yeah, Firefox is normally a little bit slower than Chromium.
Okay, so we're going to open this up and we're going to debug it. And well, we don't need to debug it because the test passes. And if this is not going to launch, then we'll go straight in and create a test. Because I'd like to see CodeGen in action, even though I showed the video, but I want to see us actually build something.
Yes. So it seems like .NET has some problems here with launching. This might be all of this live stream software running on my machine. Let's try to jump straight into CodeGen, Debbie.
Okay, so I want to create a new test. And this is our most favorite way of creating a test. Now, you could totally go to the file and just write all the code yourself. Like, totally okay to do that. But if you use CodeGen, it's just going to save you a lot more time. It's going to make your life more easier, and it's going to help you choose the right selectors. So you don't have to think like, which one am I meant to use? Which one is the best one? Because CodeGen will give you all that for you out of the box, right?
Yes, yes. So to launch CodeGen is the same as how you install the drivers. Let me maybe unplug this external monitor, then it should be probably a bit faster.
See, live coding, this worked so well 10 minutes ago. And you live code and look what happens. Always fun. Okay, so we're going to try again to launch CodeGen. And yeah, new terminal, and here we go. So yeah, we can launch CodeGen, and you can choose between the different, between the library, right? And between NUnit and MS Test, am I right?
Yes, you can.
So while that's launching, if this doesn't launch, then Will can just push that test, because we've already created a test. So we can push that test to GitHub and run it on CI. Should we go ahead and do that, or we see if streaming live demo continues to cause us issues?
Something's happening.
Oh, it's happening. It's happening. Look at that. The external monitor. It was all the external monitor's fault. Okay, so we have a browser window. That's what gets launched. And we have the inspector window. That's great. We've zoomed in there. Excellent. So we've now gone to that page, .NET Podcasts site, because that's what we put in the terminal. So now we can start writing our test.
This one is Blazor-based, right? This one is Blazor-based, so it's
It
all
is
available on
indeed.
GitHub.
Okay, so let's write a test, Max.
Yeah, so what we see on the right is CodeGen, right? You can select your target here. In this case, we want to use MS Test. Let's do this. This will give us a small test. So, and let's write a small test by, let's see, going here a little bit more down. While we hover over these elements, it will show you all these selectors, as you can see. Let's go first to discover more. And then we see a lot of podcasts, right? For example, Hello World and Maui and ASP.NET Monsters. All are pretty interesting. Debbie, what's your favorite podcast?
I mean, .NET Rocks by Richard Campbell, of course.
Very nice, very nice. Well, let's
Did
jump
you know?
through this.
Did you know
Oh.
we have a playwright one on there?
I did not. That's cool. And let's make an end-to-end test. Let's say we want to make sure that this text is there, right? Let's click on it. So for the future, for later, the selectors are there. We will later transform it into actual assertions. And let's make sure this listen later feature works. So I've seen that on this site, a new feature got introduced recently. You can go to each podcast and you can click here on this listen later thing. And
exactly, because we're at a conference, so we don't have time to listen to this podcast right now. So you want to click on later, and then it should be in that listen later. But look, as you're hovering, right, I just want to pause there. Get by role, area role link, listen later. So it's giving you all that, and it's making sure your site is accessible, isn't it?
Exactly. So by default, it's using these area role selectors, which are basically actionability selectors. So if you go to listen later, then we want to make sure this podcast is there, right? So let's click on it again.
Sure do.
To have here these clicks, and that's all what got generated. We can open it here to see it. So we go into the site, and then we are click on Discover More and the .NET Rocks podcast. Then we have these two clicks, which we want to convert into assertions. And we click on this Listen Later. And then we are going on the Listen Later tab on the actual site. And then we actually want to make sure, again, it's there. So let's copy this and make it a real test. Let's go back into VS Code. So let's close CodeGen and paste our test in. Let's close this and make it a real test. Let's say this here.
So now what we want to do is make sure, like the headings, because the user's not going to click on that heading to make sure .NET Rocks exists. That heading, we want to put an assertion and say, expect that to be visible on the page, right?
Exactly. And each assertion, each expect statement, like we have a lot of assertions available, as you can see here. So to be checked, disabled, empty. Like for us, it was important to be visible. You can also use to be hidden, and you can negate them with .not as well. So let's use here to be visible. They will retry, like these are async expects, right? Async assertions. So they will retry over and over again, either until the condition is met or until the timeout is reached. So let's do the same here and then see if our test passes.
I mean, it should pass because Cogen wrote it, so it should be fine. But you never know, especially since we made some changes. Got to make sure it actually works.
Yes. So,
and what I love about the locators here, while you're running that test, I'll just explain role headings. So it was very easy for us to go over the headings to make those an assertion. We know that the link, that's a click event, so we leave that one. So it's really easy to kind of modify those tests. And for someone new to testing, this is such a great way to get started.
It is. So you never have to worry about these selectors. They are all generated for you.
This is why I told you, Cogen is my favorite feature. I love it.
And here you see passed one.
Oh, it passed. And I didn't see anything because it was running headless, right?
Yes.
So this is amazing.
So what do we do next, Debbie?
I mean, obviously, like I want to make sure that everyone can listen to .NET Rocks and listen to my podcast and that test works and nobody comes along and breaks my code. So I don't want to run that test locally. I want to run it on CI. And we have an option for that. And I don't know how much time we've got to get it up and running, but I think we already created one and we pushed it to GitHub. Am I right, Max?
We did. Let me quickly open this so we can take a look. So let's open GitHub. Here we are. And let's open my account.
We're using GitHub, right? But it works on all CIs. So, you can run your tests on any CI that you want, but we like GitHub, so we're going to run it on GitHub just by using a GitHub Actions.
Exactly. So, and here we have our .NET Conf demo. And this is essentially the same as we had before. We have our unit test 1, and it's essentially the same script. But what we added is like we first pushed it to GitHub, and the second is we added a GitHub action. And the GitHub actions are placed in the .github workflows folder. And here we do what we did before. We install the browsers and we run the test with .NET Test. And this means for every commit to your main branch and for every PR, it will run the tests. And these are like best practices you want to have inside a modern web application. So here you see it, test, and passed one.
So if this test failed, you'd actually be able to go in here, see the log, and be able to kind of say, right, I'm not going to accept that pull request because that test failed. And yeah, then it's a lot easier to make sure that, nobody's going to break your site, right?
Exactly. Once you change your Blazor site, then this GitHub check, they call it, will go red. And you can set up branch protection rules to not allow, for example, red status checks before merging them.
Excellent. I mean, Playwright has everything. I think it's just an absolutely amazing tool to help you test your Blazor applications. And I think that's pretty much all from us. Am I right, Max?
This is right. So for any further questions, go ahead, check out the documentation. We have them for writing, running, generating them, for debugging them in the cloud, and for using them with MS Test and NUnit. And we have a lot of guides as well, which cover a lot of scenarios.
Excellent. So this has been so much fun. The .NET experience with Playwright is absolutely amazing. Back to you, Richard.
Wow, Debbie and Max, thanks for all the great endorsements on .NET Rocks, and I hope you'll catch Debbie's show that we did together back at NDC Oslo in the Fishbowl. Not a fancy studio like this. You're seeing a bit of what it's like to do the work in here. Suddenly we're in the studio space, things are a little different. And here's the spot where we actually get all your questions to come in. And I've been having some fun with some of them here. Earlier on, we were talking about with Stephen Toub about doing testing, and our friend Jess Fritz pulled up the classic 8 million tests. And Jeff's here too. He's whispering through the glass there. There he is. Yes, he could be Dr. Evil, but he could be Jeff Fritz also. So beyond that, sometimes the conversations are technical, sometimes they're more about enjoying the great experiences that we have. I think I mentioned this earlier, Menran saying again about Toub, it's like we're diving deep on a subject that's so deep, I think none of us were swimming at that point anyway. So this is the studio experience, and we've had a great first half of the day here at .NET Conf, and we're getting close to the end of my time, but we're also crossing the streams a bit. GitHub Universe is going on as well, and so we're going to be able to transition over to them too. And I hope you've spent some time on the .NET Conf site at dotnetconf.net, also checking out the secret decoder messages with and getting your contribution in to be able to win some of that swag from our awesome sponsors. We've got the Code Magazine subscription, so grab that link to Code Magazine, get yourself signed up, and you can read all the same folks that we've been talking to today and their contributions into the mag as well. And certainly, last but not least, if you got a chance to check out Little .NET Rocks, take it on. See what you think. They're audio only. All the folks you talked to before, we've had Dan Roth on, we've had David on. In fact, we're now talking about that Architects panel being a separate .NET Rocks episode because it's all part of the fun of having those kinds of conversations and exploring deep on the technology. So if you want to learn more, there's plenty more places to learn. You've seen a lot of great sessions today live, but next coming up is many of these sessions are being pre-recorded, and you're going to be able to get them on Microsoft Learning to actually listen in on them too. So we're out there looking for Scott Hanselman right now and seeing if we can hook up with him and get into that conversation and what's going on GitHub Universe. We've got a little more time before all of those pieces come together, and I hope you'll be sticking with us and hanging out for all of that good stuff. Don't forget the survey. Links are available there. And Scott, if you're with us now, I'll hand it over to you. Hey, Scott, you there?
I am. How's it going?
Things are great, man. Wish you were up here. I hope you're having a good time.
Yeah, I wish I was up there. Sorry for not being able to make it up in this particular trip, but I appreciate that you're here.
Yeah, it's great to. I came down, so you didn't have to come up.
Exactly.
All right, so what are we doing with GitHub Universe today?
So as I understand it, the folks at GitHub Universe are, of course, they're happening at the same time, so there's this live stream. And they are, you can see, actually, it looks like we're live looking at, actually, we can bring that up again. If we're going to just be, live TV, let's just be live TV, right? Mm-hmm. You can see the folks over at GitHub Universe are setting up. So we've just finished a session, and folks are setting up there in this center square at the Center for the Arts there. And they're going to bring in Brian Randall in a second here. I don't know if they even know that they're live, which I think is kind of funny. It's very likely that they don't know that they're live. Brian is going to come over and hang out, and we're going to chat with them about what's happening. But I can certainly talk to you about how I'm feeling before they get here. It's unclear what's going on at this point.
Sure. I had the thought from Ghostbusters that it's always challenging to cross the streams.
Yeah, it is. I mean, the thing is that there's two live streams happening at the same time right now, of course.
Right.
And you can see there's a gaffer just walked by, and there's cord management and stuff like that. So they're going to eventually take our stream and broadcast us to GitHub Universe, and then we are seeing, of course, a live feed. This is like the man on the street interview, of course. There's not a hurricane here, but there's just a hurricane of activity as they go and set up the machines there for the next stream.
I'm just appreciating all that sunshine because it's been pretty gray down in up in the Pacific Northwest. We keep forgetting time shifting. It's all the same time zone, but definitely different weather.
Yeah. Actually, one thing that you may not have seen, actually, Richard, let's bring me full screen, and I'll show you something that I've been doing with GitHub while we wait for them to set up. And,
code demo from Mr. Hanselman? I'm all over that.
Yeah. So let's go ahead and put me full screen here, and I'll pop something up here and show you something that I've been working on lately, okay? So here's the deal. We've got this website here is called Azure Friday. You've probably seen this before.
I have watched.
Let's see. Yeah. Let's see what's going on here. So if you can see that Azure Friday, I'm looking at the live stream because I want to make sure that I'm not in a two-shot here.
Yeah, it looks good to me, man.
You're able to see that okay?
Yeah, it looks fantastic.
Okay.
And your perfect zooming skills are still perfect.
All right, good deal. So Azure Friday is the website that I'm running for the Azure video podcast that we do. And if we scroll down to the bottom of it here, you can see right now I'm currently on .NET 6, and I'm in the process this week of upgrading to .NET 7, okay?
Right.
What I've done here is I've put this on GitHub, of course, and people can go up and look at that. It's public. It's pretty awful code, so lower your expectations. But within that, we've got this .github folder, okay? And in that GitHub folder, I've got a workflows with its Azure Friday.
Nice.
Okay.
Is that a YAML
I'm not a fan
file?
of the YAML.
Oh boy.
I'm not a fan of the YAML, but the kids love the YAML. And within this, you can actually see on GitHub that this YAML file includes information that Azure would need, so that we might go and do a deployment directly from a GitHub action. So we've got .NET Core right here. So when I go and upgrade this to .NET 7, I'll add that to this YAML file, and that will tell Azure where the Azure web app's going to go, that it's the release configuration, and that we're going to be using whatever version of .NET that's going on here. All right?
Awesome.
And then the build and deploy job right here is running on Ubuntu, on the latest Ubuntu Docker file.
So that literally just grabbed the latest build.
Exactly. So that's going to use the latest Ubuntu that they've got set up there, and then it's going to use some of these built-in GitHub actions like checkout, which is a pretty standard action, but then set up .NET, right? So GitHub Actions knows about .NET, makes it super easy to do this. I'm going to set up .NET with that version that we mentioned then just before.
Right.
Then restore it, build it, and even I'm going to be running my tests on my website in the cloud.
So this is code, this is your unit test code, like whatever you've written?
Yeah, so this is going to be whatever I want it to be. So in this case, that could be playwright tests, like we just saw from Debbie.
Yep.
That could be headless tests. Mine happen to be xunit.net tests, which is fine. And then we've got .NET Publish, which is an Azure Web Apps deploy. So this is really interesting to point out that here, let me go ahead and show you this again. That uses, and that uses are three different actions. The top one being one that's built into GitHub Actions for checking things out.
Right.
The second one is setting up .NET so that we can do that build. And then here we have an Azure one. So you get this nice sense of orchestration moving through GitHub. And I've got this kind of cafeteria plan where I can pick the actions that work for me and, and make that happen.
What's the @v2, then @v1, then @v2?
Yeah, that is literally the version. So in this context, that version appears after the end of it. So you've got your kind of your namespace, your name, and then your version. Does that make sense?
Awesome.
Yeah, it's pretty cool.
Yeah, no, and it's very clear, right? Those series of steps. Like, I know we're not huge fans of YAML because we've got to get the indents all right, but you can't argue that it's hard to read this, especially in VS Code. The character lighting and so forth makes very clear. This is what I'm going to run. Here's what it's called. Each of the phrases are there. You know what's going to happen.
Exactly. Like you say, you can say, YAML, you can say JSON, you can say XML. You can have opinions about your markup, but ultimately it's just name value pairs. And what's nice about this is it is very readable.
Yeah.
Now, what's cool about this, though, is that inside of that GitHub folder, we do have our workflows. We've also got my most favorite thing, Dependabot.
Right.
Right? This is fantastic. So Dependabot is actually looking at the NuGet package ecosystem because that's the ecosystem that I care about as a .NET developer.
Right.
Right? And we're going to be looking at the package manifests, and that is going to be, looking every once in a while for updates to what's going on. And that is going to then give me a report. So if I go into Actions, we can see these URL changes. This is me. You know how when you do a bunch of commits and you don't know what you're doing, you're like, small change, little tiny change.
Maybe this is the last change. Hopefully the last change this time.
Yeah.
Please save me.
Making a mess. And you can see...
they were all seconds apart, right? I could see
exactly.
19 days ago in X many seconds.
Yeah. But check this out. This is the part that I love. If I go to the pull requests, have you seen this? Have you spent any time with Dependabot?
No. Well, yeah, but not doing this. What are you doing?
Okay, so this is a joy. So remember, Azure Friday is just myself and Rob Karen, right?
Right.
This is not a this is not a team, right? I'm not a team of thousands here, okay? This is just me.
Right.
Hanselman International is exactly one guy, and then Rob Karen, who does my video production. But what's really neat about this is it feels like there's more people working for me.
Right.
Does that make sense?
Yeah, yeah.
So here we've got Dependabot, which is a bot that has decided to bump with a pull request. Hey, there's been an update to this particular.
That's Polly, right? That's
Polly, right?
AppVNX
Exactly.
guy
One of my
supporting that.
favorite NuGets, and Polly has been bumped up to version 6.10. Now, what's
Right.
great about this is the bot writes really good release notes, and it does that by actually sourcing them from here. So that NuGet ecosystem is rich and first class in that GitHub Actions and that GitHub ecosystem. So I'm inside of GitHub doing my .NET stuff. It's first class, and then they'll go and link me out to those release notes. And then depending on how someone fills out their release notes, some of these release notes will actually include a detailed change log. Look at this. So they've actually copied in from other change logs based on the specific well-known text files, like changelog has a format, right?
Right. And so
click
for
on
you as
this
a responsible project owner, you've got enough information to make a
Exactly.
decision about that pull request. Is this going to
Exactly.
be good?
So you can see here we've got a standard changelog.md that is keeping a changelog, which is a specific markdown format for changelogs. Dependabot knows that, so this means that I'm looking at a pull request that feels like a real person wrote it.
Right.
And they're saying, wow, here's the changelog. Should I upgrade? Yeah, I probably should take that upgrade. But then it'll even pull in the commits, and I can go and do a diff and see what changed, which is great.
Wow.
Okay. Then merge it directly. So it's almost like I've got these employees working for me, that those employees are actually bots. And that's really great. So that is built into GitHub Actions. And then these workflows can include testing, building, code QL, quality, and things like that. So later on today, when I go and upgrade my Azure Friday to version 7 of .NET, I'm going to be confident that that is going to work out well because I've got all of those tests and I've got all that support, and it's all going to happen inside of Actions, which is really cool.
Well, and you have all those other possible PRs you could be doing because Dependabot sorted that out for you and said, oh, by the way, that package has got an update. Here's the changes. Like, you don't have to dig around and do all that stuff you used to do yourself.
Yep, exactly. One of the other things that I've been working on that I think is really cool that I'm looking forward to working on .NET 7 again later today is if we go over to my podcast website. Kind of fun, I think. You do this too, is to use your personal websites as, as a test bed for these things, because it's just going to be my site.
Right.
token.
Yeah. No, it's the right place to experiment.
Last week I got to speak to Randall Monroe, if you remember him from XKCD. So folks can go and check that out. But we scroll all the way to the bottom. Look at this. Look at this. See how we've got, again, .NET 6 upgrading to 7. But look at this GitHub integration here. Deployed from this specific
Oh,
commit.
I love that. I know
Isn't that
what
cool?
build's running on my site right now.
Right. Now, you might like that idea. You might not, right? It just depends on how you want to run your site.
Well,
But,
we're this kind of geek.
Yeah, if you're this kind of geek. So in this case here, I want to see that. Now, I could put an admin block around that. So it's like if admin show that, otherwise don't show that, right? You don't have to do that. But what's neat about this is then I can right-click on that commit, and I can go directly to it. So let's go ahead and just bring up that commit. And look, I just went directly to the commit 10 days ago. So I know that I made a change to one of my links, and I had it add, and I had a missing at here. So I know exactly what's in production.
Right.
And then because of those actions and builds, or if I'm using something like Azure DevOps or anything that's any kind of build server, whether that be GitHub Actions or otherwise, I can go and click on that link right here, and that'll take me directly to the build logs as well. And again, I could put if admin around that if I felt like that was important to me.
Yeah, you could hide it if you want to, but you get to see it if you need to see it. I think that's the important part, right?
Exactly.
How many times have we got a built-in test that we thought we deployed, but we didn't? And then someone's complaining about a problem. It's like, oh, I already addressed that. And then you have to, you don't know when you look at the production site that change hadn't gotten pushed up.
Yeah. And if I go back over to GitHub and I show you here under security, you can see that Dependabot and code scanning shows up right there.
Right.
So then I can click on Dependabot and see the specific alerts if there was something in the ecosystem I was worried about. Now, I don't have any alerts because I'm not having any security issues on the site right now, but GitHub Actions and GitHub will warn me as a .NET developer if something goes down.
Yeah. I'm not going to say I look forward to those emails, but I'm grateful when they arrive. It's like, you better go check. Because sometimes these are 0 days, like they're real vulnerabilities, but they're built as PRs. Many times you can just check them in and push your build and be good to go.
Yeah, absolutely. Yeah, learning about these dot files, these .github, or like this .dev container is a super important thing to do. Because, for example, here I could even go and open up a code space and pull that dev container in as well. And that's another nice thing. And .NET developers really need to spend some time understanding what's inside of these folders. And if you bump into one of your favorite open source projects and they have one of those folders, go and look in there, see what actions they're using, see their code QL, take a look at how they are configuring their Dependabot settings, and you might learn something.
Yeah, that's an interesting thing to explore. We always learn from others that way. So,
yeah, exactly.
I mean, being able to look at that project and look at your project. Like, I think I'm going to use you as an example, Scott, and say, well, how did Scott do this? And then see if there's some things I could take advantage on run as.
Yeah, that's a great point, actually. You should figure out what are the things that you can do, because, one of the things that I like about this ecosystem is it makes me feel like a 10x developer,
right?
Even though I'm not.
Yeah.
You know what I mean?
Still trying to figure out if those people actually exist, but I get the idea, right?
Well, I'm just one person, right?
Yeah.
This is, like I joke about Hanselman International. It's just me,
yeah,
right? But if I can go and put up a dashboard that expresses what's going on, I can see here that there's, 200 users on my site right now, and I've got a couple of small errors. This makes me feel like I have an ops team, doesn't it?
Right.
Like I'm a real boy.
Well, a sense of activity and what's going on. It's like now you can go mine into those errors. Say, well, what's going on? Like, where are the problems? What's the actual action look like? And then see the effects of your work.
Yep, exactly. So now I'm excited to get up to date on .NET 7. There's going to be a ton of stuff going on there, and I want to make sure that I know that. So I've recently just updated my Visual Studio, just about 20 minutes ago. So I've got Visual Studio running here.
17.4.
Yep, and I've got 15.4, and I'm all set up, ready to go. So then when I load up, like for example, my podcast website, then I'm going to bring that up and then go through and update this. And in fact, I noticed actually on Twitter earlier, just about an hour ago, Rick Brewster, the author of Paint.net, one of my favorite .NET apps, actually just upgraded it from .NET 6 to .NET 7. And Rick pointed out that it took him 5 minutes.
Wow.
And I was like, 5 minutes? And he says, well, I got a phone call in the middle, so that's why it took so long.
Yeah, I was thinking, what do you do for 5 minutes? It's just a build.
These are the questions that we're asking, right? I'm not exactly sure why it took so long. Well, yeah, it was a phone call. And he's like, a phone call? An actual phone call? Do those even happen anymore?
Yeah.
Right? So
That's
here
not what
we go.
I use phones
I've got
for.
.NET 7 as a choice right there, and I can make the right choice for me, for my website. And I'll be doing that in the next day or two.
And those little incremental updates, like I noticed one of your sites was 6.08 and the other one 6.010. Like, when do you decide to push those?
When do I decide to update those?
Yeah. Like, to actually put those in.
All right, let's get to it. Right now, we're going to go live with Brian Randall at the .NET Conference.
Oh, I think something's happening here. Hang on a second, my friends. I think we're breaking in. This is great because we're doing 2 live streams. We're going to cross the streams here.
Here comes the stream crossing. Make sure your protons stay in place.
Well, while we're doing that, I'll show you. If I hit download right here, can you see that?
Yeah.
So here's the .NET website, and I can decide whether I want standard term or long-term support, so I can make the decision that's right for my business and my company.
Right.
I see Brian coming in soon here, and we'll figure out what's going on. I'm looking at the cam. What's happening? What's happening?
Good afternoon, everybody. How we doing here at GitHub Universe? Ooh.
I'll let you go, Scott. Have a great conversation.
Lovely face I see remote in Portland, Oregon.
Test. Are you there? Can we hear Brian? What's happening?
All right, I hear Scott. Do you hear me?
Hey, how are you doing, sir? We're crossing the streams.
This is crazy. I thought we don't do that. That's a Ghostbusters problem. It's gonna change the universe, man.
Cats and dogs living together, mass hysteria. So you have like like water behind you right now. You're in the middle of a fountain.
I am a fountain here in sunny San Francisco for GitHub Universe. Even the sun thought they should come out for our wonderful event.
Very, very exciting stuff. Well, thanks for letting us jump into your stream, and thank you for jumping into our stream. Appreciate that.
It's wonderful. We love .NET developers. So rumor has it, you guys have this amazing thing going on telling the world about a great new version of .NET.
We are in fact, yeah. We just launched .NET 7, and just a few minutes ago I was talking with Richard Campbell and showing him how I've got GitHub Actions going and building my entire website, testing it, running Dependabot. I've got CodeQL, I've got security updates. I feel like I have a DevOps team, except it's just me, right?
A DevOps team of one, that's fantastic. Love it.
Yeah. So I put together a couple of things for you that might make you smile. First, I've got this lovely slide that includes the shiny GitHub universe. So we got the cooperative crossover for our friends at GitHub. But I think you might get a kick out of this here. You see my LEDs in the background?
Oh, what do you got going on there? Oh, glowing Mona. Oh, that is wonderful, Scott.
Put the Octocat up.
So you know what's wonderful about that is I know in your heart of hearts you're a tinkerer and you like to hack things. So have you got your mail yet today?
I got my mail today? I have not yet received my mail. Do I need to go outside?
Well, no, something's coming for you. We have sent you a special gift, a hackable Raspberry Pi GitHub Universe badge just for you.
Oh.
So Martin Woodward thought of you. It should hopefully even be there today. And we just want to share the love with our buddies. A little ink display, put your name on it, or tell a story, whatever you want to do.
Oh, that is very cool. You know, actually on my desk right now, I've got, Meadow .NET devices. Meadow just had their release 1.0 release candidate, so I can run .NET on tiny devices. I've got .NET running on Raspberry Pis with our friends at PyTop. So adding a Raspberry Pi device to my my pile here is going to be perfect. I've even got this Wilderness Labs project lab right here. And so in this case, I'm actually putting together a weather station, working on a weather station, again, powered by .NET.
It's a wonderful world we live in. It's amazing. So look for this in the mail and let us know what you think. Put some photos on Twitter for us.
Oh, absolutely. I appreciate that. Yeah. Now you've been heads down, of course, focused on GitHub Universe, but have you seen some of the cool stuff going on with .NET 7?
Yes, and I've actually been able to work with it. But why don't you tell the community what we've got for them? Because a lot of the hubbers are heads down today with our keynote.
Yeah. So it's a couple of the highlights here that I'm excited about. I just literally updated my Visual Studio just a few minutes ago, but I was pointing out to Richard Campbell that we've got native support for ARM64, which is really, really cool. So that's cool for a couple of reasons. First, I've got just over here on my standing desk the new Windows Dev Box, which is an ARM64 device. So we've got native ARM. So I've got both native ARM for .NET 7 and native ARM for Visual Studio itself, which is really cool. And right over here, I can grab my Surface Pro X ARM-based device, which I can now run Visual Studio and .NET 7 on. So we're starting to see a lot more action in the ARM space, which is really, really cool.
And then
that is great news.
It is great news. And then, of course, Linux support just keeps coming, right? We keep the hits keep coming with the Linux support on with .NET. We're in the box with Ubuntu at this point. So, when you have Ubuntu, you have .NET and you have that ability. So it's nice to just have that out of the box. And we appreciate our partners at Canonical for, making stuff like that happen.
That's fantastic, because just reducing the friction to get started is wonderful.
Well, you're just nice to know that it's available and it's ready to go out of the box. So the other thing that is really cool is you can build container images with .NET without having to install anything. So you're getting container images out of the box without using Docker Desktop. You can build a container and then push it to a container registry. So developers can build containers locally and push them without any additional software.
Man, friction-free. Keep it up. That's great. What else you got there?
Yep, that's pretty cool. And then, of course, cross-platform mobile apps, the .NET MAUI, the .NET Modern App UI, the ability to create applications that are going to run anywhere. I mentioned before these devices that are running. Is that a DJ?
Yes, we have a DJ. We are getting ready to have some music. I want
to go back to that. You just casually threw out a DJ. That's pretty cool. I'm showing my slides, and then suddenly there's a DJ available. It makes me feel like maybe we should have had a DJ here, and now you're just trying to show off at this point.
Well, it's great to have a live conference after the pandemic, man. You know how it is.
Yeah, that's very cool. I love that. That's cool. We're gonna have to step it up next time and get a DJ, because now you're just showing off. Yeah, so I was saying that actually I want to go back to .NET 6 is included in Ubuntu 22.04. So you just go apt install .NET 6 and you just get it, which is ridiculous.
That's beautiful.
Yeah.
Well, anything we can do to make reduce the friction so the developer can do the magic and write code as opposed to work on infrastructure and all the stuff that goes into that and getting their machine ready is great.
Yeah. And then, for folks that are maybe on .NET Core 3 or .NET 5, and they're like, I don't know, what do I want to do? You have the .NET Upgrade Assistant now, which is like a step-by-step command line tool that'll walk you through the upgrade process, and it basically will perform the migration for you. So, one of my games that you might remember, Baby Smash,
yes,
is almost 16, 17 years old now. And in fact, the baby from Baby Smash is getting their driver's license this week.
Oh, you poor thing.
Yeah. But that's interesting, because .NET is both mature, it's ready to go in containers, it's ready for cloud native, but it's also, there's a lot of legacy there.
Exactly. And organizations rely on it for their line of business software every day.
And Baby Smash, in the example, was a WPF app from 17 years ago. We ran the upgrade assistant on it, and we brought that forward. So if you might be using WPF, you might be using WCF, Windows Communication Foundation, you might be thinking, oh, the new .NET's not for me. Turns out it actually is.
That's wonderful. God, I remember when you brought that out. That was wonderful. My children played with it. It was great.
Yeah. I was surprised how easy it was to upgrade. It walks you through the process. It converts the things that you need to convert, and we're putting in analyzers and code fixers. So if you have a WinForms or a WPF, a console app, or a class library app, we'll have these fixers that will say step by step, and it's not automatic. And by automatic, I mean it's not like a black box where it does a conversion. It literally is like an interview. And it walks you through. I'm going to do this. Okay, I'm going to back up your code. I'm going to do that. So you can put those commits into GitHub really neatly and say, all right, upgraded this, upgraded those. And then if you want, squash the commit and do your thing.
Just think about the changes in the generation when you first built that to now you can build it on GitHub and share with the community, get feedback, get pull requests and contributions to just make it all that much better.
Absolutely. There's also a ton of stuff going on in the web space, in the ASP.NET Core on .NET 7. We've got support for HTTP 3 built in. So just when you're thinking maybe I need to upgrade to HTTP 2, too late. Now it's
too late without 3.
We've got that as well. And if you have been out of the .NET space for a minute, it's really, really easy to make
these web APIs, small, minimal APIs. It's a really interesting expression of how to do a minimal API. So those are great for cloud native apps. I'm looking at the list here. There's rate limiting. We've got new support for output caching. We've got gRPC. The perf numbers that we're getting on .NET 7 are redonkulous and super, super fast. So it's the fastest .NET ever.
That's fantastic. Well,
Yeah.
you know, we're working hard to make it easier for everybody to get started. So do you have another slide there by chance, maybe?
Let's see. Oh, look at
Oh,
this.
look at that.
What's that? What's happening at GitHub Universe?
Well, we love .NET developers, and one of the things we announced today is code spaces for everyone. 60 hours free to do whatever you want. So that includes .NET on Linux with the click of a button, Scott. Don't even have to apt-get anything. Just open up a new code space.
So that just, do I have to click anything? Do I have to sign up? I don't have to. Do I just have a GitHub and I have this access now?
You have a GitHub handle, you go on, click on code spaces, and click the button. And we got new templates to make it easy to get started. Yeah, I know. What? It's absolutely wonderful. And then we've got, as you know, Copilot is available right now for individuals. You can sign up for a free trial if you haven't played with that. And now it's available for companies. We've had great response from the individuals out there. Over 100,000 people use it every day. And now companies want to buy it for their developers. And, you know, you talked about actions. We brought full support for ARM now in the GitHub Actions runners, as well as we have some monster-size runners for Windows and Ubuntu. 64 cores, 256 gigs of RAM. I think you can build the next version of Baby Smash okay.
This is the Godzilla level compute machines.
Absolutely. And so we got a lot of other great features. But I think again, we got this new State of the Octaverse report, 10 years this year. And something I want to tell the .NET community, number one, C# is holding strong as the 5th most popular language on GitHub. And you ready for this? You're going to love this, Scott. Our fastest growing communities, the top 10, number 4, .NET MAUI, and number 5, Microsoft Playwright.
Very cool. We just a few minutes ago at .NET Conf had our friends from Playwright come and show us that. And again, running those Playwright runners in GitHub Actions is a really great way to get started with end-to-end testing.
It's fantastic. And of course, you know, GitHub, we're the home for everybody. So Python, JavaScript continues to be number 1. So, you know, if you want to get your web on, we've got lots of templates for that. And again, in security, as you brought up, I mean, you can be a DevOps team of 1. And we continue to offer, you know, Dependabot forever for free and open source, as well as the new security report. And that's probably a good thing. If you find an issue in one of those community libraries you're contributing to, we can do private CVE reporting to help the community with those problems. So again, GitHub is all about community for everybody, and we love our .NET developers. So I'm so glad we're able to get together and talk. And I really hope you get a chance to hack on this little Raspberry Pi badge when it shows up at your doorstep.
I will head over to the mailbox right now. It's probably sitting in there. I didn't realize.
I hope so, because I really do. But if it doesn't, we'll get you a tracking number.
Very cool. I appreciate that. All right. So let's find out what's next. I think we're gonna call over to our respective hosts, aren't we?
I think we are. We're gonna say thank you to the GitHub Universe audience, and Scott, it's always great to see you and our friends at .NET Conf. I think we haven't ruined the universe. I don't see any lightning or any Stay Puft Man coming over the building, so I think we were safe to cross the streams.
All right, good deal. Thanks for hanging out, and have a great show.
Thanks so much, Scott.
Wow, I got to get my hands on one of those badges. I want to play with a new Raspberry Pi 2 as well, Scott. I hope you got yours.
Yeah, I've got to go over to the mailbox and figure out what's going on. That's pretty cool.
Awesome. Well, I got to move on to the next
stuff.
talk. Anthony's right here with us. We're going to dig a little bit into the build experience with DevBoxes. Over to you, Anthony.
Thanks a lot, Richard. I'm Anthony Cangelosi. I'm the Group Product Manager for Microsoft DevBox and Azure Deployment Environments. Software development's been changing a lot over the last few years, and so is the way that we work as teams. Hybrid work has become kind of one of the primary ways that many developers work today. It brings a lot of benefits for developers, but it also has a set of challenges with how we get tools and resources and devices out to developers that creates challenges for developers and IT alike. On the developer side, Developers are really trying to get into a workstation and get their environment up and running as quickly as they can so they can get into their flow and stay inside of their flow. Now, slow setup and onboarding times has always been a challenge for new developers, but when you combine that with distributing hardware out around the world to remote developers and the supply chain challenges, it only compounds the issues, making it worse, turning a problem that used to be a problem for a few hours of debugging with a team member in the office to one that now takes days or weeks to get up and running. Now, we don't all have access to the same level of hardware and to the same kind of gear to run with. Some of our developers are running on aging legacy devices or have a slow internet connection. This means that our team members may be spending hours building or syncing their code around with their teammates around the world. And the truth is we're all working on things in parallel. You may be working on a feature branch, building a new feature, a bug comes in, a prior one issue that you have to go and address and tackle. You have to stop what you're doing and switch context. That switching of context can potentially poison your environment as you have to go and get your bug from an earlier version of your application up and running, leaving you hours to have to go and recover and get back up and running again. That's just time lost taking you out of your flow. Now, our friends over in IT are struggling with some of their own challenges. They really want to give us the flexibility that we need as developers to be fast and agile, but they need to do this and keep our environment secure at the same time. Now, this can be challenging with so many different kinds of hardware and environments that our developers need to get up and running. You may have one team over here that's working on an AI project, trying to get an AI project with some GPU to be able to do some diagnostics on some large data sets. But at the same time, a few weeks later, you may switch over and need to convert your application from Intel over to ARM. These changing resources mean that developers need to be moving quickly from device to device. Now, many of our engineering systems haven't been built for a remote-first development team. And so this puts a big strain on IT teams to deal with all the support requests that are coming in. Add all of this complexity into our remote environments, and it's ripe for attacks from malicious actors that are trying to take advantage of our systems. And so IT teams need to be able to identify security threats as they come in for developers that are running anywhere in the world. Now, there aren't a lot of organizations that have the scale and the capacity to deal with and solve all of these problems while also addressing their customer needs. And at the same time, those that do often would rather put that energy and resource towards actually solving their customers' problems themselves. And so that's where Microsoft DevBox and Azure deployment environments come in. Two services that help you take advantage of the cloud and bring the scale and elasticity of the cloud into your engineering systems. On the one hand, we have Microsoft DevBox. Microsoft DevBox lets your developers self-serve and provision their own high-performance developer workstations in the cloud. These are ready-to-code development environments that have all the tools you need to build applications for your specific project. The images that run and power these dev boxes are built and managed by your team. Your team can put any of the software that they can run on Windows onto these dev boxes. So any IDE, any database tooling, internal apps and configurations they need, they can build so that they have a ready-to-go environment that's always up to date. Now, these dev boxes are centrally managed by your IT team. They're enrolled into Endpoint using Intune. So all of your group policies, all of your conditional access policies are there so your IT team can manage them the same way they manage all of their physical devices. On the other side, we have Azure deployment environments. Now, Azure deployment environments lets you do a lot of the same things for running and deploying your application infrastructure. Rather than having to manually configure an application environment yourself, deployment environments let you take a template that's built by you and your dev infra team, and it takes care of deploying that environment on your behalf. So you don't have to worry about how to configure your application. You just need to deploy your app into it and figure out how to get your code running. It also takes care of deploying that on behalf of the user. So IT doesn't have to give broad access to the entire subscription. They can have an identity do the deployment on their behalf so that it gets deployed into the right subscription for the right project. Again, developers don't have to think about where their resources need to go. They just need to focus on what they need to build. So let's take a look at a little bit about how this works in DevBox and Azure deployment environments. So I'm going to switch over to the developer portal for Microsoft DevBox. The developer portal lets developers kind of self-serve and create their own developer workstations that they can access and connect to from anywhere. These project-specific developer workstations have everything a developer needs built into them. So here, for example, you see I have 2 workstations already running. I have my main development environment for the podcast app that we've used for a lot of our demos here. And I needed to work on a project to upgrade some of our dependencies, so I've created a secondary box that I can go and do that work and test those changes without interfering with the feature work that I was doing earlier. And I can keep those environments separated and isolated. Now, I can self-serve my own dev boxes, as many as my enterprise or team will allow me to create. And I can create dev boxes from any of the projects that I'm a user member of. So I happen to be a member of the Orchard Core project, the Podcast project. Each of these have their own set of dev box definitions that are each tailored and customized for building those specific applications. Now, one of the key ingredients for the DevBox service is this idea called a DevBox pool. Now, this cold pool of devices has 3 ingredients that give you a number of different options of how you can set up development environments for your team. The first is the image that gets deployed onto the DevBox. The second is the SKU, or the hardware that we're using for it. And then the third is the network connection, ultimately a virtual network behind the scenes that's getting injected into that VM that's getting provisioned for you. Let's talk about how some of those come together. Here you see I have a few different named DevBox pool. I have a backend DevBox. I have a data engineer DevBox. The backend DevBox has an image with Visual Studio and all the tools for building our backend services. The data engineering DevBox, that image on it is running SQL Management Studio and Azure Data Studio with a connection specifically for connecting to some of our on-premise customer data. And then finally, our front-end dev has VS Code and some web tools running on it for our web devs. Now, the second is the SKU I talked about. So you see here our data engineering has a slightly larger disk, and once we introduce higher-end SKUs, it'll actually use one of our higher-end SKUs as well. Our front-end dev is using a lower-end, lower-count core for some lower cost and cost savings there. The third piece I talked about is the network connection, or the virtual network. This is a really powerful piece of Microsoft DevBox because it gives us a bunch of options around how we can define the security boundary of the DevBoxes that we're using. So while most of these DevBoxes have access to the public internet, we also have this privileged access workstation pool that we've created here that has a custom secure network on it that only has access to a few limited endpoints inside of it. It doesn't have access to the internet. It allows our developers to diagnose production environment issues when they come up in a secure, dedicated, isolated environment. I'm going to go ahead and create a new DevBox inside of our West US 3 region, which is our closest to us. I'll call this my bug fix DevBox because maybe I just got an issue that came in that I need to create a new DevBox and keep that work separate from my primary feature work. Now, it takes DevBoxes about 20 minutes, maybe 30 minutes for them to provision. We're working constantly on reducing the total time for provisioning DevBoxes. But what's happening in that time is actually the service is taking care of joining that DevBox into your domain. Whether it's an AAD native domain or it's a domain controller on-premise, it'll take care of joining that domain for you. It'll also enroll that DevBox into Intune for you. That means that your DevBoxes that your team members are using are all being managed using the same group policy, the same conditional access policies that you're using to manage all of your devices in your existing infrastructure and IT domain. Now let's go and connect to one of my existing DevBoxes I have here already. I can connect to the DevBoxes from one of 2 ways. I can either use the browser, and that's great. I love that when I'm on the road or away from my desk and I need to get back and make a quick change on my workstation, I have the full power of my workstation that's available to me anywhere on the road. Or I can connect to this from within a Linux workstation if I'm natively logged in and I need to connect back and make a quick change. I can also connect through RDP. Now, RDP is a native application. It's running locally on the desktop. And this lets me take advantage of all of the capabilities natively available on the OS. It's available on Windows, iOS, Android, and Mac OS. And I can connect here. Now, let me sign in to this. Some of the things that you can take advantage of with the RDP client is, first of all, if I was logged onto the local machine with the same identity as the one I used to sign in here, it would actually use Windows Hello to log me in. So I don't even have to enter my credentials most of the time. The other thing is it takes advantage of 4K, high DPI, even multi-monitor support is available. So you can really take advantage of your full development rig from within this experience. Now, I've just logged into this DevBox. Now, this isn't just a vanilla Windows image. This is actually a developer image that we've downloaded or using that's been pre-built for Visual Studio users to be able to use to have everything they need to build just about anything you can build with the Visual Studio toolset. This image has on it, and it's available in the marketplace for developers. It's available in the Azure Marketplace as the Visual Studio images. It has on it Visual Studio. We have a version with 2022 as well as 2019 available. We have Pro and Enterprise versions available in those images. The images images are built in with all of our PowerShell and Azure CLI tools. You can see it has VS Code. It has Git for Windows built in. It also has nested virtualization enabled on these because these dev boxes actually support cross-platform development as well. Now, I've manually installed Docker Desktop on this particular image because I'm able to actually build my container images and do my cross-platform development from this machine. It even has the developer mode enabled because this is really a developer workstation. Now, I've also just recently cloned down the source code for this project and pre-built it, but we're actually working on building a definition that will check into the podcast repository that will actually build the entire end-to-end workstation, including all of your source code and binaries, so that you can actually get right into your development and start incrementing your code, saving all the time of building your container images. All right, so with Visual Studio running, let's take a look at how this works a little bit behind the scenes before we go in and actually start making some changes. So I'm going to move over here to the Azure portal and talk about some of the unique things that you can do with this service as an administrator of Microsoft DevBox. Everything in Microsoft DevBox kind of anchors around the Dev Center. The Dev Center is kind of like the organization inside of GitHub or the organization concept in Azure DevOps. It's a high-level unit that you can use for your entire company or for a business unit that brings together all the projects that your teams, oh, you can get out of the way, stop that. All the projects that your team are working on. And I can create new projects for different groups of developers within our team. Here we have the podcast application running, and we have the podcast project, and all the users that are a member of the group that have access to use this project will be able to see and create dev boxes from the pools that we saw earlier. Now I can go into the DevBox pools, and I can even see which dev boxes have been provisioned against each of these pools. You can see my main dev box here, as well as a few of the other dev boxes for my team members. Now, one of the questions we often get from customers is, how do I deal with contractors that I need to work on a project and contribute for a short period of time? I need to get them a full working development environment for my complex application, but I don't want to send them a dedicated machine because I have to figure out how I get that device back when our contract is over. I'm also worried about giving them access to their devices into my corporate network, because that means I'm letting unmanaged, insecure devices potentially into my infrastructure, creating more risk for my team. And so that's one of the great things that DevBox allows you to manage, is I can actually create a dedicated project for unique groups of users with their own sets of permissions. So I'm going to go and select the right subscription where my existing Dev Center is running. And let's select the Contoso Dev Center. And we're going to put this in the same Dev Center, but we're going to call this the Podcast Contractor Project. We'll create this. This will take just a moment or two to actually create that. And once this has been provisioned, I will have a project where I can set unique permissions that only the contractors on our team have access to, and that are more constrained and restricted for their use case. So I've got my project now set up. Let's go into Access Control. And let's give our contractors the role assignment for a DevBox user in this particular Dev Center. Select the members, and they are part of, we have an AAD group here for our contractors. And so any users in that podcast contractors group that gets added to there will also be able to access our developer portal and create dev boxes from this one project only. Now, the last thing I need to do is I need to give them a pool of dev boxes from which to create their own dev boxes. Now, one of the things is I can take advantage of all the work that I've done in my internal team, because they're going to be working on our back-end services. So I'm going to use the existing back-end definition that I created for my internal team. So this has the image that's been pre-built with all the tools that we need already on there. It also has the 8-core CPU. If I wanted to have a lower or a higher CPU for this group of developers, I could change that and create a unique definition for them. Now, the one thing I will change, though, from our internal team is I'm going to use this more secure or more restricted network connection for our contractors. Our contractors don't need the same flexibility as our internal developers. They only need to be able to access a few specific endpoints from my application. So I've configured this firewall to limit their network access to only those specific endpoints that they need, further reducing the risk of anything potentially sending information that I don't want outside of the network. Now, that little label is getting in my way, but the second thing I want to show you is that I can also define the level of user rights or access on that dev box. Again, these developers don't need the flexibility of my internal full-time developers, and so I'm going to set it to standard user because I'm already deploying all the tools that they need to build the application, so they shouldn't need to add anything else into that environment. Now, the last thing that I'm going to do is I'm going to set an auto stop time. This is a new feature that we'll have coming out very soon for DevBox in our preview. And it allows me to set a time of day when these dev boxes should shut down when they're not being used. So we'll set that to 5 p.m. and these devs are on the East Coast. So we're going to set an East Coast time zone of, where is New York City? Havana, New York. There we go. Great. So I've set my East Coast time zone. And now, as these dev boxes are running at 5 o'clock in the local time zone, they'll actually shut down automatically. But we're focused on developer productivity. So they won't just arbitrarily shut down a running workstation where a developer is getting their work done. It'll send them a notification first, giving devs a chance to be able to skip or delay that shutdown so they can keep getting their job done when they're busy, but us not wasting compute for resources that are not being used and are sitting idle. OK, so that was a quick rundown, an example of some of the things you can do to be able to provision your own developer workstations using the Microsoft DevBox service. Now let's talk a little bit about how you can do some of the same things with the Azure deployment environment. But first, let's talk about this application, the podcast app. It's a pretty complex application. It's got Kubernetes services, SQL Azure DB, Signal R, all running in an application. And if I was a developer joining the team, having to set up this environment ad hoc on my own is pretty complex. It's pretty time consuming and it's error prone. I might misconfigure that environment. And on the best day, I might misconfigure and not be able to deploy my application. On the worst day, I might misconfigure it in a way that I've left open a security vulnerability in my application. And so the way that enterprises will often deal with that risk is they will lock everything down. They'll say, OK, you know what? We're not going to let just anybody create resources in our subscription. We're going to have our dev infra team or IT admins do the provisioning for you. You as a developer can go submit a ticket to get one of these set up. Well, this just gets in the way of the agility and the speed that developers need to be productive. And so that's where Azure deployment environments come in. It allows developers to self-serve on demand the application infrastructure they need to deploy and run and test their application in what is a real running testing environment. So let's take a look at how that works. I'm going to switch back over to my dev box where I'm connected, and I'm going to come over to the developer portal again here. We're going to go to create a new deployment environment. Now, there are two ways that developers can create deployment environments. They can create deployments ad hoc using our developer portal UI. They can also use the developer CLI, and we'll see how both of those work in just a second. From the UI, they can create new environments for their project, and there are a couple pieces of information they need to set up here. First, they pick which project that they're focused on. Developers don't need to think about what subscription they're a part of or which resource they need to go in. They just know what project they're a member of. They pick their project, and that project defines the next piece of really important information, the environment types. Now, here a dev can pick which environment types they have permissions to. And when they pick an environment type, that connects up and says, for this particular project, which subscription should the service use to provision that environment for the developer, and which identity to use to actually do that on behalf of the developer, allowing the service to do it on their behalf so the developer doesn't need general contributor access to the whole subscription. The last piece of the puzzle here is catalog items. So what catalog items are basically an ARM template with some metadata around them that define all of the infrastructure for the podcast application. Anything you can define in an ARM template, you can put into a catalog item and you can provision with Azure deployment environments. Now, the UI is one way that you can do that for ad hoc, but I want to show you how we're using CLI in a really innovative way to integrate it into our GitOps flow. Let's come back to Visual Studio over here. And I've got Visual Studio running, and I've got my solution open. Let's imagine for a second that our marketing team really wants to do a push on superlatives. And so they want us to really kind of emphasize that we are the first podcast app written in .NET. So let's go ahead and search for our landing page. And I can bring up my landing page here. And I'm going to search for our first announcement here. We are the first podcast powered by .NET MAUI. And so we really want to emphasize this. This is the very, very first podcast app written in MAUI. So let's go ahead and save those changes. And I'm going to move them over to a development branch where I'm going to push these changes up. And it's going to be our marketing changes. And let's create that. I love how Visual Studio kind of detects that I had some uncommitted changes and actually moves them over to the branch for me. So now I've got my branch set up. Let me go ahead and commit those into this dev branch. Marketing changes. Let's go ahead and commit that. And I'm going to push that up to my remote host. So now my changes have just gotten pushed up into our GitHub fork that we've created of the .NET app. And let's go and take a look at what's going on over there. So moving over to GitHub here into our project. Great. I'm going to go into Actions, and that's because here in Actions you see that about 15 seconds ago a new deployment environment was created. What we have here in this sample repository is a workflow that's been configured to actually create a dedicated deployment environment for me each time I create a branch, and then builds my application and deploys that application into that branch for me. So as I'm making changes, I can see those changes running live in that environment and test them and see them and see exactly how that's going to impact the running application. The other thing that we've done here in this sample is we've actually integrated into our pull request flow. So when I create a new pull request against our sample repository here, we're going to go off and kick off another environment provisioning. This one is now a clean environment that lets the code reviewers on our team who are reviewing our source code also see how those changes look in an environment, giving us a chance to detect any potential issues before they get merged in with all the other changes in our team, giving our code reviewers much more confidence in not having to guess about what these changes are doing. Now, I have already a pull request I've created because it takes about 10 minutes for this environment to get set up. So let me go to that. And here I can see in that pull request, it's actually published out a unique URL for the environment that was set up at the time. And here I can see those changes running live. This gives our code reviewers a much richer experience as they're evaluating my changes. Finally, when I'm done with that, I can go and I can merge my pull request. And when I merge that pull request, our workflow is going to go and delete that environment for me. So I don't have any extra resources sitting around unnecessarily. And when this closes the branch, it'll do the same and delete the environment associated with that branch. Now, switching back over to the developer portal, I said there were kind of two key things that kind of make Azure deployment environments what they are. So coming back to the Dev Center here, the first is your catalog items. The second is your environment types. Here in catalog items, the catalog of items that you can provision are basically sourced from a Git repository. This can be any Git host that you're using, GitHub, Azure DevOps, GitLab, etc. And what the service is doing is it's scanning this folder for any Azure ARM templates that are there, along with the metadata that it sees to discover that this is a deployment environment, and making those catalog items available for your developers to provision inside of a deployment environment. This gives you the flexibility to collaborate through a GitOps flow between your development project team and your app infrastructure team. The second part of it is those environment types. So I'm going to come back to the podcast app over here. First, actually, before in the environment types, you can see we have several environment types. I have dev, prod, and this is what wires up and connects the subscription specifically for this project so that the right subscription gets billed for this particular project on the team, as well as the identity that's being used to provision these resources on behalf of my team. Last, we were able to give our engineering team contributor access to the instances of the environments that are created. So you can collaborate and just get permission to the environments that have been created without giving broad access to the subscription. And so if we take a step back here, we can actually see in our environments list all of the environments that have been created through our automated workflow from the CLI, as well as the manual ones that we've created by hand. We can actually drill into the resource groups for each of those, even see the costs associated with each of these environments that are running and manage them one by one. All right, well, so that was a big, quick overview of how Microsoft DevBox and Azure deployment environments give your developers the ability to self-serve their own high-powered, project-specific developer workstations, as well as their application infrastructure. These services today are both available in public preview. We encourage everyone to give them a try and get started. We have a blog, and we have plenty of documentation to help you get started with these services. Thank you very much, everyone, and back to you, Richard.
Thanks, Anthony. And that's it for me. I've been having a great morning hosting, and I hope you've had a great time as well. I've got some new hosts coming in, so let's let them into the building. Myra and John, come on board. Yay. I'll let you guys do the Q&A.
Good job.
Congratulations. Have a great
well done,
time.
Sir.
Appreciate
Thank
it.
you. Thank you.
And that's all for me. Have a great .NET Conf.
Wow. All right. So we are the lucky next presenters. Woo! Hello.
Hi, everyone.
So we were on yesterday for a full session, and we have the privilege of hosting today for the next 5 hours.
Yeah. And we're wrapping up our GitHub section here. Anthony just finished the DevBox talk, so thank you so much, Anthony.
Yeah.
And I think we do have some questions, right?
We have some good questions. I'm not sure I can find it on the board. I was looking on my phone beforehand. There was one that was interesting, which was possibility of integrating with local compute. So if I've got a dev box and I've also got beefy resources elsewhere, is there a way to kind of integrate those together?
Oh yeah, for sure. So one of the things that you can do is you can configure your network to be able to connect both to the cloud and your on-premise resources. And so you can set up your virtual network to have a VPN connection into that. You can access your on-premise devices, any behind the firewall resources. So you have a tremendous amount of flexibility of how you can configure those connections.
Great. And then what is kind of, as I'm moving into this, where do I think about like roadmap-wise? What are some things that this could expand to in the future?
Oh, there is a ton of opportunities of where we can expand. There's only so much I can share now, but the thing I want to kind of leave folks with thinking about is really the focus is about giving developers ready-to-code development environments. It's about getting them kind of all the way to the point that they can focus on incrementally building their application, not having to go and do all that setup and configuration themselves. And so you can just start to imagine some of the things that we'll be doing over time beyond just pre-building the workstation itself that will give us really a rich, powerful environment for developers to build applications of just about any size for any size team.
Great. Let me see. I'm not seeing any other questions.
There's one about there from Richard, if there's going to be dev
This one?
boxes in
Wait,
South
no.
Africa. Right at the point there.
In South Africa region? That's
Yeah.
a great question. We have been building out our deployment, and so yes, we are actively expanding what regions we're available in. And so we've been looking at where capacity is in each of those, because as a production service, as a service where developers will be spending their full-time development, we want to make sure that we've got the capacity to deliver the best-in-class experience we can. This is something that developers will rely on, and so we're looking at all the regions where we can get capacity to deliver a great end-to-end service for us.
All right. Thanks, Anthony, for that great session. And now let's move on to our next section of
we've been told we're actually not ready to move on to the next one. Great. Okay. So actually, now's a great time where we can talk about the structure of this morning, right? So we've had, at the beginning of the morning, we had some really kind of advanced content, deep into like language features and some really advanced, like let's build a feature and stuff. Then we moved into a Blazor section, and that was really kind of cool, including the mind-blowing thing for me was Steve Sanderson live coding a live audio editor thing. I was like,
oh my gosh.
as Steve only can do, right? And he's doing audio wave visualization and playback and making it more performant and stuff. So we wrapped up the Blazor section, then we had the GitHub section, and then now we're going into a new exciting thing, which is low code and Power Platform.
Yeah, and Teams. So we're going to learn all about that integration. And we had our like conference to conference like connection here. It was so awesome to see. And I want a DJ for us here too.
That's right, that's right. And tie in there, but that was actually done using Teams. We've been using Teams NDI for these conference to conference calls and remote calls. We're using Teams for all of that. And it's amazing how Teams kind of scales up to handle all that stuff.
Yeah, and go on to dotnetconf.net and fill out the survey. We have a survey for you to fill out. And then you can fill out a form and run like there are 25 bags that are sponsored.
Oh, that's right, yeah. So yeah, it's a great time to, like, you can fill out and you can enter in to join that.
Yeah, so great prizes.
Awesome. Okay, so we are ready for Caruana and Heather to tell us our first session, which is on low code and productivity. Gosh, I'm getting the name wrong, but it's an awesome session.
Let's boost our .NET productivity.
There you go.
Right. Well, that's okay. Hello, everyone. It's okay if you got the name wrong. We know what we're talking about. Thank you, hosts.
Yes, for sure. Good afternoon, Caruana. How are you?
Good afternoon, Heather Newman. How are you today?
Fantastic. Smidge of a cold, but rocking through. So
excellent.
Yeah, awesome. Well, hello everyone at the .NET conference. So happy to be here with you today. We are talking about boosting your .NET productivity with low-code tools. So Caruana and I are going to take turns times chatting with you. So a big welcome. And again, thank you to our hosts, and thank you to everyone who's been on this. There's just massive numbers, and it's just so great to see everybody here. So right on. So we're really excited about being here. My name is Heather Cook Newman. My pronouns are she and her. I'm a Power Platform and Dynamics 365 customer and community success lead here at Microsoft. I'm on the BAP team, so in Charles Lamanna's organization, and I pretty much think about all day how to build programs at scale for our community, for our makers and our users and all that kind of jazz. I live in Los Angeles, California, is where I'm coming to you today from here, and I'm originally from Michigan. I'm in the Mitten State, and I spent time in Seattle at the University of Washington, and I was a theater major. And yeah, jazz hands, everybody, jazz hands.
Absolutely.
Yeah, and I've been in around Microsoft for about 21 years. I've been back as a full-time employee the last 2.5. Thrilled to be back, and very excited to work with folks like Caruana, who has been an amazing partner for me for many years when I was in the community as a Microsoft MVP, and now back here at Microsoft. So Caruana. Oh, also, we have our LinkedIn QR codes on our slides. And so if you have a camera or a smartphone and want to do a quick snap of that QR code, then we're connected on LinkedIn forever and ever and ever. So awesome. I will make the slides go for yours, Caruana.
Excellent. Thanks. Hi, everybody. Caruana Gatimu, Microsoft Teams Engineering. I run the customer advocacy group. My pronouns are she and her. And much like Heather, I do community at scale. My team also delivers a lot of engineering solutions around Teams templates, the Teams Emergency Operations Center, adoption.microsoft.com, and more. So yes, snap that QR code, visit my YouTube channel. But let's go ahead and just hop in. You want to know more about us? You can always find us out there on the wire.
Absolutely. So, our jobs revolve around these 3 big items here on the list. And for me, my story is very similar to many in the world where I've been pivoting, learning, and upskilling around the way. And that theater background that I was talking to you about makes it so that I give a lot of keynotes and speak to students, mentoring, all of that kind of thing. Very passionate about women, people of color, and students and allies who are looking to do that career switch or who want to bring more value to their jobs every day. So every day we're talking digital literacy, digital equity. How do we bring these programs to scale and get people prepped for what's to come? And I think that's where a lot of you are thinking about what is to come from where we are today into the future. I know, Caruana, you have such passion around this as well. Do you want to say anything to this slide as well?
I do. I think that you're going to learn a lot about and deep dive into the technology capabilities that are available to you. But Heather and I want you to put that in the context of your broader career. We both feel really strongly that if you're not enjoying what you're doing right now, then now's the time to make a change. And we have so many programs and capabilities that are coming between the low code work that we're going to talk about, the collaborative apps, but also the metaverse that comes, that now is a time to really lean into, by attending conferences like this and taking online skilling and what have you, to really boost your career. So, Heather and I are both products of the community. I know we both believe that we wouldn't have the jobs we have if it wasn't for what community conferences like this can do. And I think it's important for us to also reach out and help others who are coming along. Many of you have been around the Microsoft ecosystem a long time, and you probably understand it well, but it's changing. And so now is the time where you can leverage community and the new technology to make sure that you're positioning yourself for the future and being able to help others along the way.
Yeah. So a lot of this content came from a lot of blogs from our colleagues from the Work Trends report. And so you'll see a lot of statistics and data from that. We're going to talk a little bit today about innovations around low code, where I live and breathe every day, the infusion of AI, automation of business processes, collaborative apps, metaverse, like Caruana was saying as well. So, and a little bit about where we see the tech industry going. These slides have been around a little bit, but they're very important. There are some waves of change in development that have been happening, and it's changing the way we work and how we develop, how all of you develop. The first wave is really about the changing workforce. 35% of the workforce are millennials. Folks are graduating who have our, the iPhones in their hands at the age of 5 now. And so everyone's expecting that mobile first-class experience environment, not just on our smartphones, but in the workplace. And it's not really just millennials, it's all business cases. And digital demand, because our workforce will soon be millennials, and you can see the numbers there on Gen Z. Similar, wave 2. This just changed. It was 500 million. It's now 750 million applications will be created in the next 5 years than in the last 40. Wow, right? That's huge.
That is so much. That is so much to think about. And to add one thing there, is your app going to be part of the ones of that 750 million apps that people love to use, that continues to live through the life cycle? It's really important that it's not just about the numbers, but it's also about the quality of the kind of development that you're doing. And that's where we hope we can help you a little bit today.
Absolutely. And I think it's professional developers. Some people have a bad taste in their mouth when you start taking the word developer and say citizen or pro or maker and all of that. And frankly, we're talking to everybody. We're talking to all of you who are our professional developers, of course, and you're awesome at what you do. And there's also all of these new low-code tools that are really exciting that are upskilling folks who maybe are in a marketing department or an HR department or doing other things that are helping contribute to the development process. And hopefully low-code tools are also helping professional developers go faster, right? Which is really exciting as well. And it closes that app gap that we are talking about for sure. I think this is another, this went from 1 million to 4 million very recently. So there's a 4 million developer shortfall. More than 80% of users and potential users of the low-code and no-code platforms say that they are willing to work for a company that invests in their technical upskilling. So if you're working at a company that's not helping you do that, people are looking for new jobs in places that will do that. So to fill that developer shortfall. What is that? What is the answer to this? It's not necessarily teach everybody to code, right? I think, Caroline, you and I have talked about it before. We'd love to potentially be plugged into the matrix without all the weird stuff so that we could, you learn faster, right?
Yeah, for sure. Yeah. I'd love that. I have no problem with that as long as it has an off switch. Privacy slider, something like that is what I would like. But yes, exactly. To the matrix.
Yeah. And, you're a solution architect. That was part of the background of you in the community, right? But your prior job. So that's part of your DNA. Yeah.
Yes, it is. But at the same time, it's not my favorite thing to do. So I differentiate between a cloud solution architect who lives and breathes in that code and has a very deep technical background. I have a deep technical background, but I am a business solution architect. I prefer to listen to customers, assemble building blocks, and use low-code solutions and out-of-the-box capabilities whenever possible to solve a customer's problem. And I think that this speaks to what you're saying about the diversity of people who do this. Can I code? Yes, I can. Am I fast anymore? No, I'm not. But it's also not what sings to me. So it's important to understand what makes you feel like you're getting meaning from your work as you are addressing these industry trends and issues. The bottom line is we're in demand. People who can navigate this ecosystem, leverage all the tools that are available, and solve business problems are going to be well employed over the next decade. And so you're positioning yourself really well by being here right now to build that skill set.
Absolutely. It's one of those things where I come from a consulting background, owning my own business, all of that, right? So I was continuously looking to how do I build for people? How do we get new marketing solutions in there? How do we make sure that we're solving the problems every day for folks? And that is the life of so many of you who are consultants as well, who don't work for those larger companies, right? So this is the place to be. It's an exciting time. What is the answer? Right? Well, low code, AI, metaverse, hybrid meetings, all of these things from the Work Trends Index. And if you don't know what that is, that Microsoft, we're the biggest lab out there. And so there's lots of information from the Work Trends Index. You can type that in right now and go check it out. But the 85% have positive impact on work satisfaction from using all of these new tools because people love learning, right? And so, they're very user friendly. right? So they're a more user-friendly model than we've seen in the past. And so that upskilling experience has a positive uptick on satisfaction and morale by users. Those are data points that's not me just spouting it off, but that's coming from our Work Trends Index. It's really exciting.
I'm sorry, Heather, I didn't mean to interrupt you. One other thing I just wanted to say, these stats may not land with you right now, or maybe you don't think they're super relevant, but they're very relevant when you're trying to make the business case for the funding for your next app. Right, or for your next development project, right? These pieces of information validated by Microsoft Research can help you move forward your next project. So that's one of the reasons we want to share them with you, is so that you're armed with this information as you're trying to get your next project off the ground, or take it from an experiment into a production application, which always requires additional work.
Absolutely. And people, we want to instill confidence in each other, right? And so whether you're from a traditional software background or not, to see the value of your work contributing to your team's success is huge, right? Happy people are productive people. Productive people help drive more revenue, right? That's that wonderful combination right there. So some paradigm shift that's coming up with artificial intelligence and AI. So this is also obviously fueling innovation in technology, and it's allowing all of you to build software solutions using the same language when people talk to each other, like we're talking to each other right now, right? So natural language translated into programming language, and that paradigm shift is being driven by Codex. Most of you probably know what Codex is, but if you don't, it's a machine learning model from the AI company OpenAI out of San Francisco that translates natural language commands into a dozen programming languages. So get this, you're talking about this. Hello, Python, da-da-da-da, Csharp, da-da-da-da. That's amazing. That's where we are right now. And that Codex really descended from the GPT-3. Sounds like a robot, but it kind of is, right? Generative pre-trained transformer. And it's an autoregressive language model that uses deep learning to produce that human-like text. So once you give it a prompt, it produces the text that continues that prompt, right? And so all that learning for GPT-3 actually came from language data from the internet. So from everybody on this call and beyond, plus learning code from GitHub and other repositories. So you put all of the language on the internet and how we talk and how we speak, and then all the code together. Here we go. Artificial intelligence, AI.
And if all of that was just a bunch of wah, 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 because you might be new here, it matters because this creates an accessible portal for people to speak what is needed and not have to work as hard at some of the things that have been the bane of our coding existence forever. Where's the comma? Where's the semicolon? Are you a tabs or a spaces person? This sort of thing. And so being able to have a different sort of interface to unleash your creativity as a developer is what this is about. Right. I love going deep into what this all means and super impressed, Heather, by your overview of that. I don't think I could have done that well. It was really good. But I also want to connect that to why this matters to you, especially if you're new here. Right. Absolutely. This is important stuff moving forward.
Yeah, and it's somebody new to me too. And I was like, I went deep into this because I was like, I want to know what this is about, And so I think it is the marriage of what you're talking about. How do we make this real? And then where does this thing come from?
Yeah.
We often don't get the origin story sometimes on these things, and we just go next. But anyway, I think there's really a call to invest in employee development, and low code really does empower everyone. We've got business users, IT pros, pro developers, and we at Microsoft are definitely talking about fusion teams, which is these three together in the trifecta or triad, if you want, of bringing people together to work on these things and to build new apps and to solve business problems together. And so the thing is that those leaders and business decision makers out there, those of you who own businesses, you really got to critically examine the opportunities that are there for offering your employees an opportunity, one, to start working together more. Look at your IT teams, look at your business analysts, look at your developers. Do they talk to each other? I was at a business one time where the support team and my marketing team had never talked. And this was way back, and we were in person in an office. I won't say where, but I said, everybody get up. We got up and we walked over to the support team, and I had the marketing and support team meet because they had never met. Now, these days it's harder to do that, but it is up to leaders of business to be bringing teams together to work on these solutions together. And that's all about meaningful opportunities for career advancement, networking, because the person next to you is probably the person, or the next to you on the call can help you with what you're doing next and next and next in your careers. So anyway, that's what I have to say about that slide. So exciting. So Power Apps. I want to talk about Power Apps for a second. We're creating software applications like Power Apps to make that app development even easier and faster for those Fusion development teams, right? So that's that combination I was talking about. And also the capability to develop all the custom connectors with Microsoft Power Platform on the back end. Just one piece that I was really excited about that has been announced recently was, natural language and express design. So developers, citizens, professionals can create low code faster with this. This leverages a lot of that fun stuff that I was just talking about with AI. It's cognitive services, it's detection models. So, those of you who use Figma for your design, which is one of the leading, UI, UX design tools recently bought by Adobe, you can just upload a Figma design file. I was in front of a college last week and they looked at me when I said Figma. They were like, huh? And I said, how about a PDF? And they were like, oh, yeah, I have those. So PDFs, PowerPoints, paper, a screenshot of a legacy user interface, even a picture of a hand-drawn app can now be converted by Power Apps into a working Power App within seconds, right? With a connected data schema. So these kind of innovations are what makes it so, a developer can go faster, a non-traditional developer can take these new low codes and make apps almost instantly. And this, y'all, is the trend for the next couple of decades that's coming out. So I was really excited about this Power. There's a million things that are happening in Power Apps, and you can check that out on the Power Apps blog or in our community, but this was one I wanted to point out to everybody. So we want to talk about teams a little bit. Caroline, you want to talk about teams and hybrid work? Yeah.
Oh, I'm happy to. Working in the collaborative apps and platform organization under Jeff Teeper is an exciting place to be. We've released 450 new features just in the last year, these 270 million users. Of course, that was tremendous growth almost overnight because of the pandemic, but we're seeing that growth stabilize and be retained because people are understanding the power of bringing folks together in an organization in a more modern centralized interface. And so Microsoft Teams is that center of gravity for the productivity experience. But when it really becomes powerful is when it's the center for app experiences, whether developed in this wonderful kind of fast way that Heather was just outlining, or custom developed apps. Teams is better when people have more of a reason to go there, more than chat and having a video call. Those are great capabilities. I use them every day, of course, and I love them. But what is really powerful about Teams is bringing in those app experiences. And as you think about really transforming business processes in general. And if we go ahead and click to the next one, a big piece of that is thinking about these immersive experiences. So the expectations of the new workforce, of the changing workforce, is something that we have to think about, right? And so, people who are digital natives, who had that cell phone in their hand, that iPhone in their hand since they were 5, expect to have a different sort and a more integrated productivity experience in their workplace, right? And the metaverse is going to help further transform this over time. When we talk about the metaverse, we talk about, your portable avatar, being able to dynamically create different sorts of avatars for different sorts of experiences. I used mine this morning in a presentation about the metaverse with an innovation company from France, and it was the one that has a nice, than the one that I have for my team meetings. Those avatars are going to be portable, and they'll be able to interact with not only each other, but the environments that are created in the immersive meeting experiences. To get an overview of that, you can go and take a look at our Ignite sessions and what have you. But from a developer perspective, what matters is, if you, again, want to transform your career, certainly we are going to need more developer staff and creative talent to build these immersive worlds, right? The Unity 3D gaming engine is a big piece of what's coming and what we're standardizing on. And so it's very important to be thinking about this as we go forward. In the next graphic, we're just really showing the power of those connected experiences. So we all know, right, we're going to have a lot more apps and a lot more connected experiences. That's the end of the day. And that's the opportunity that's here But again, I caution you, many organizations are diving into low code and to custom development and to collaborative apps and experiences. And we appreciate that at Microsoft, but we want quality experiences. We want you to think about the user interface. We want you to think about data governance. We want you to think about making sure that your app experience is accessible and can be trusted and has good best practices. And that's why learning and modernizing your development best practices is so essential. Like some of us enjoy learning. Some of us are a little bit tired of learning something new every day. That would probably be me, just because it can be very overwhelming, right? But it is very important to modernize these practices as we think about what's coming next. And building these apps with the Microsoft Cloud is also important because as we think about the graph and all of the data from Microsoft 365 application experiences living in the graph, it allows us to expand the capabilities, the business process improvement, the decision making that can be done. And you can sit down as a professional developer, even with just a simple business analyst, and say, give me an example of your process that needs to be improved. Sketch it out on a piece of paper or in a PowerPoint slide, and then go. And this idea of agile development, right? Agile doesn't mean, badgel, which is poor requirements and not enough user feedback. It means that you can quickly develop and iterate an experience, and especially in a collaborative way, especially with the new tools around Fusion development, you can collaborate on that code together, leveraging the power of the graph and all of the other components, Azure Data, the Dataverse, and all the data that comes from our user experiences into evolving that experience very quickly. And that's what we encourage, because most organizations don't have the sorts of budgets that can be sunk into these very long, very expensive custom development projects. People expect faster results now. They expect more polished experiences, and they expect it with less, hours of investment there. So it's important to think that through as you're doing that. And then,
I think,
keep going.
The co-authoring, that was new. That was just announced also for Power Apps as well. That was another big feature of that, finally getting that co-authoring in there so you can be in there at the same time, right?
Absolutely. And I know we're going to continue to develop capabilities and APIs and feature sets that will allow you to meet users in the flow of work, right? Bringing your app into Teams and also having other mobile experiences and web experiences is an inclusive act. And that way you're also, by developing in this ecosystem, getting the benefits of the accessibility, compliance, and security capabilities that are already built in to the Microsoft Cloud, right? You don't have to come up with a governance model or an app deployment model from scratch. It's already built into the Teams ecosystem with our upgraded app store and more. And so we are a platform. I know many people think of Microsoft Teams as the end user experience, but we think of ourselves as a platform for you to build upon. And so the creativity and opportunity is endless. And I think when we think about those collaborative apps, it becomes really important, to focus on the fact that we are transforming the people experience with better, ubiquitous, but governed control and access to data so that the process itself can be improved, right? This is the ecosystem that we have to operate in now when we start to think about app development. And I love this quote from Satya. I really want to make sure that we get to show this because everything I do as a business solution architect, everything I think about, and Heather and I think about as customer advocates and community success people, is about ensuring that employees are thriving in organizations, right? That is the differentiator competitively, from a career perspective, from a human satisfaction perspective, that makes all the difference. And it is all about this people first strategy that has led us to having a new frame of reference for the way that we approach development, the way that we approach solution design, and identify opportunities. And it really hinges on that last column there, which is about feedback. If you're doing development work right now and you don't have an established way to get feedback from your users in a structured manner, I would suggest you're missing something, right? Some of the best innovation comes from employees who are closest to the processes you're trying to improve. And so this is very important when you think about collaborative apps. I think it's important in general, but certainly in the collaborative app space, feedback from stakeholders, end users, and the people you're trying to serve is super important. And especially if you skip 2 slides to the scenarios, Heather, I really want everyone to think about how collaborative apps and ultimately the metaverse is going to transform these types of scenarios, right? Operational scenarios, understanding by the use of analytics and digital twins, the kinds of production or manufacturing line changes that can be made. We think about the industrial metaverse at Microsoft. And the data and AI and low-code access and collaborative apps that are going to express themselves inside the 3-dimensional immersive meeting space is what's up.
Yeah, absolutely. And I think one of the things that came out a lot about flexibility, right? Being flexible, having opportunities for people to grow, to change, to learn, to bring in some of these new ideas. Flexibility is a feature these days. It's not a fad, right? And all of these low-code solutions and other things that we're talking about, leaders who are not changing, 2019 leadership practices are not going to meet the moment for
no
distributed.
Nope. Bad idea.
Yeah, absolutely. So positive business outcomes depend on positive people outcomes. And if nothing else, leaving you with that about flexibility is a feature, not a fad. Remember that as you're looking for the new opportunity that you have and when you're giving opportunities as a leader, both.
Absolutely.
Yep. And I think we're at our time for questions, aren't we?
I think we are.
Yeah, and I'll put a couple of calls to action up there. If you'd like to join the conversation from Microsoft Community, follow Adoption and Community Twitter handle that Caroline and I and the team all work on together. And any questions, please let us know.
But just make sure that we're happy to answer your questions. And this community, this space, this revolution is open to everyone. There is room for everyone at this table. And I really want to, both Heather and I want to encourage you, take a look at your career, make sure you're finding meaning in your work. If you don't feel included, then join our community to feel like you are. I mean, the .NET conference community is an amazing place. I just want everyone to know that, across Microsoft, you are welcome and so are your ideas. And so we're really, really happy to get to be here. Do we have any questions from the hosts back there? Because, Heather and I, we can keep talking about this for a really long time.
Wow. Yeah, that was awesome. So I have a personal question I've had. As a .NET developer, I love low code. We use it a lot in the .NET team. We use Power Automate. We have things piped all over the place. Write as little code, so write as few bugs as possible. And integrating with clouds resources is great. But I do wonder sometimes as a developer how to best integrate with development resources. Like, do I need to worry about version control? My question is, how do .NET developers integrate with people that are doing low-code solutions? Or how do we manage those things together?
I think that's a great question. So I will say that developer best practices like version control, code checking, and what have you, all of that applies. You shouldn't leave that at the door because you're using low-code capabilities, really. I think as Microsoft, we could do a better job of automating those things and bringing those things together from a tools perspective. But certainly all the best practices I learned, 20 years ago still apply. So don't leave them. And I'm sure, Heather, you have something to mention about that.
No, I was going to sort of double down on what you said. Yeah, I think it's keep your best practices, and also if the tools aren't keeping up with some of those best practices, we need to push on the tools to make sure that they are, right? Yeah. And so I feel like that's a really important thing. And then GitHub is still a best practices place to keep repos and all of that sort of things as well.
100%.
Yep.
Excellent. Any other questions?
Awesome. What do we got on the board?
Let's see if we have anything. I think we have mostly announcements. We had one from Jen just saying how awesome it is to have you two. You are so inspirational, two awesome women, and we're also gonna have our next speakers, also another awesome women. So I love to have all this representation here on the conference as well. And I love the like the access to everyone, like creating that space for everyone to participate, right? And you, John, you were talking about like how we use it, the Power Platform and Power Apps in our day-to-day. And so like one thing that we do for the .NET website, we have like the integration with Azure and our website to like get all those alerts to see if monitoring our solutions. So it's not just for like low-code developers.
One other thing, one other amazing thing. Sorry, we use it also in the .NET Conf system. When people create a new local event, they actually will fill in a form. The form goes through Flow. The Flow like goes into an Excel spreadsheet that does use geolocation inside of Power Automate, and then it like uploads it to an Azure blob, and then the website so it's all this like, but it's stuff we wrote like 3 years ago, and it still works, and it's so amazing, and it integrates with all these different like services. So.
Yeah. And I was just going to add, if you're not using adaptive cards to get those alerts directly in Teams, that is something that every developer should know how to do. ACE is a reasonably easy thing to wire up and make such great portable user experiences. It's an awesome thing.
Yeah, and John, maybe we can write a blog together on the question you just asked.
Oh, we sure should. Yep.
That's a great idea. I'll read it.
All right.
A bit more. So yeah, thank you. It's great. Yep.
I also want to thank you both for being here today. Thank you, Karan and Heather. And now we're going to move on to our next session. It seems like an exciting talk.
It sure does. So Julia Casper is going to be talking about using Power Apps on top of web APIs.
Hi everyone, and welcome to the .NET Conference 2022. I'm super excited to be here, and I'm a program manager at the Microsoft Developer Division, overlooking the end-to-end experience for developer and how to integrate and interact with the low-code tooling we just heard about. So today I'm going to talk about how to easily create a web application using Microsoft Power Apps and interact with some of our with a .NET REST API as well. I know probably a lot of people haven't heard of Microsoft Power Platform or haven't even heard of Microsoft Power Apps. So before I'm going to jump right into our demo, I first kind of want to touch on some of the fundamentals, and especially want to touch why as a developer I should be caring about this, or why is this super interesting for me and what I can actually do with the